Burada da.
Yok siz gelmeyin.
Tamam, komşu. Hilmi hoş geldin.
Hoş bulduk hocam, nasılsınız?
İyiyim, sen nasılsın? Tamamsın.
Evet.
İyi görünüyor.
Onurum.
İyi hocam nasılsınız?
Muhammed.
Hilmi nasılsın?
Hem vereyim, hem vereyim.
Ne yaptın? İyisin.
Gel böyle buralara otur da öne öyle ön tarafa otur sen. Sen bir ay seni.
Sağ ol kardeşim.
Otur öyle.
Seninle sizden mi?
Ha, yükleyeceksin şeyi.
Hem yükleyelim şeyimi sağ arabadan bir şey vereceğim.
Yok gidemem şimdi arkadaşlar.
Arabayı değil mi?
Ne vereceksin? Şey var mı? Hani alırız ya. Bütün
Hazırlatasın.
tamam.
Hani
Dersen şey.
Tamam.
Böyle
Drive'dan yüklemesen sarı.
gördün mü?
Daha
Gel kardeş gel yardımcı olayım.
Tamam. Ben alayım. İyi sarı.
Ne buradan istersen şuradan verecek.
Bir ara bir başlayalım. Böyle siz ortaya oturun. Böyle gelin bu tarafa.
Elektrik var ya burada bilgisayarı
Tam başında. Biraz oturun bu tarafta. Bir yal bağlı köprüsün böyle. More proud. Sit here. Okay? Front there. Yeah. For now, I mean, the beginning, then we will go out anyway to talk. Yeah? We need to see what you have done. Yeah?
Şimdi mi?
Ha, şimdi.
Evet sen daha gösterelim. Bu aşağı tamam, yok onu şey yapıyoruz. Sen benim istediğin bir yere atmalıyım. Yok, ben söyleyeyim. Tamam, ben anladım.
Gel abi.
Tamam. Evet, geldi. Tamam. Evet. Tamam. Evet. Evet. Evet. Evet. Aramayacak. Yok, sadece bu arada bir cuma pazara yani cuma değil, onda takalım. Cuma değil. Bu cuma gibi çıkıyor onda alalım. Evet. Aynı zamanda
Çok yaşadım ben.
Böyle. Sabahleyin çok erken. Yani 10'da falan başlatmak lazım. Daha millet ancak toplanır.
tamam. Lazım çıksın.
Hayal hepsini kaydırırsın. Benim için şey değil. Problem değil yani.
Slightly hungover you. Slightly hungover. Slightly hungover you. I'd be lying, baby, if I said it wasn't slightly hungover. Maybe slightly. Slightly hungover. Maybe slightly.
Speküler artık.
I've never had to do baby before I met you.
Sadece bakın transferde hiç sorun yok. Ama söyleme.
Slightly hungover. Slightly hungover you. Slightly hungover. Slightly hungover you. You should lie, baby, no, no.
Uyanamadı sene Kıbrıs'ta.
Someone who loves you. And I do.
Koşu da olsa daha kalabalık.
Çok kongreler hepsi çok güzel oluyor. Bütün kongreler zaten ilk günü başlıyor, önemli bitiyor. Ondan sonra çantayı mantayı kapıp hadi gidiyor yani. Benim için hiç problem değil.
İyisiniz. Biz sizi biliyoruz.
Benim için
Yerlisiniz.
ben yerliyim.
Öyle sizinle uğraşmıyoruz. Yani
Ben
buraya gidelim, öyle geçelim.
Yok.
Siz rahatsınız.
Ben kırmızıya 50 kere gelmişim, ya 60 kere. O sana İspanyol.
Ya sen iyisin. Sağ olasın.
Evet. Evet.
Çelik biraz da fiyatları birazcık geri gitti. Ne başladı? Bakın 200 dolara çıktı.
%80 açıkladılar. Burada da 300'dür belki. Adalar hangi ada olursa olsun dünyada daha pahalı anakart. Yani çünkü transportation cost'unu koyuveriyor üstüne.
Allah'ın sodası 2 lira var, 6 liraya çıkıyor. Marketteki şey.
Market.
Adam şimdi bir yere gidecek, soğutacak.
Şimdi ben balıkçıya gidiyorum.
Elektrik fiyatları. Fiyatını istiyor.
Balıkçıya gidiyorum abi. Bir duble yeni rakı. 125 lira, 120 lira yazıyorlar. Bir duble 123 lira. Zaten 2 tane de
Bizde de sizinkinde oldular. İşçileri bağlı ettiler. Yani tabelalar çıkmadı ama eskiye göre evet bayağı çıktı.
sigara ucuz.
Sigara biraz... Güneyden de akıllı insanlar buraya geliyor.
Niye? Almak için.
Her türlü. Yani benzin bizde daha ucuz. Yani arabası yok. Yemeği içmemiz daha ucuz. Market şeyleri daha ucuz güneyden. Yani ben de geçenlerde bir markette baktım. Gerçekten öyle. Yani yemekler daha ucuz. Bu sefer de bize akıl. Ama göresin ama nasıl değil? Sen o kapılar, arabalar yığın yani.
Tamam da şimdi bizde
Gelir oturur mesela kafeye de oturur. Lamaza'ya gider. Mesela oturur. Daha şimdi.
Yunanlılar, Bulgarlar
Evet.
olmuş. O İran tarafından Kars mı? Oraya gidiyor.
Dün gösterildi şeyi okul alı.
Euro'yu bozduruyor.
Tabii.
Ana.
Okul alışverişi için dün gösterildi edilmeyi. Biraz fark ettik. Koşullar çok zorlaştı. Yani para kazanmak da zorlaştı. Şartlar da ağırlaştı. Yani gördüğüm bir durum.
Bir de dolandırıcılar da çok fazlalaştı. Eskinin dolandırıcıları ne güzeldi. Hiç olmazsa küfür ederdi, döverdi.
Tanıdık dolandırıyor.
Evet şimdi.
Aradığında şey oluyor.
Özgün was our how to say that ex-president of the kingdom. Past president. So not ex. This sounds yeah. And Talat Hoca is actually from Turkey. And Andreas Brander is a ECE president, European Council of Civil Engineers president. So it's a famous figure for us in construction management. Actually, he's lecturer of all of us actually.
Günaydın.
Günaydın hocam.
Yeah, just like you said, he was also.
Yeah.
Forget it. It is 43 years. I mean, 43 years of experience.
Something which you cannot buy.
Yeah.
Experience.
43 years and continues.
Yes.
I think you are obliged to share.
Yeah, we are trying to.
Yeah, if the I am also of 70. I years of so I want to share experience I made and if my opposite accepts it or not,
I can understand. We are
he could learn it. He could learn it.
This last month or last year, I have counted how many students that has taken courses from me. Unbelievable. It is something like 9,000 students have passed on me for the last 43 years. I cannot do anything more than this. 9,000. Method study has a seating capacity of 5,000.
5,000.
You have to make one more.
2 times.
That's another few.
Otelde misin? Şeyde misin? Acapulco'da mısın? Sen bisikletle mi geldin Özgür?
Mercedes Jeep'le geldi.
He's a great cyclist. Champion. Champion of Cyprus. Captain of national team.
Yes.
As far as I can remember.
Still cycling?
Yeah, he's still pedaling. He's still pedaling.
Yes. Sunday always. Past the green line and then Atalasa forest. The mountain bike. Mountain bike, yes.
We have a rather strange communication. We have met him some 5 or 10 years ago. I used to come here for a seminar and we have met him. At that time he was involved in this Cyprus Chamber of Civil Engineers. And from that day on, he is sending me WhatsApp messages 365 days in a year, continuous. Unbelievable. Yılda 365 gün bana mesaj atan tek kişi. Ya çok enteresan. Atıyor, her gün atıyor bu. Ben de 165 kere falan cevap veririm.
Sizi unutmuyoruz.
Ya unutma ama yani. He's very dear friend to me.
I don't forget you.
You have some very good days, you remember.
İyiydi.
Şimdi bilmiyorum ama
İyiydi.
in my opinion, the most difficult job in the world is this one. Simultaneous translation.
Turkish is our native tongue and we understand English well, but I don't think I will be able to translate from English to Turkish.
Sentence structure
It's different.
You have to listen to the
and then
Elektriğini yaptı, inşaatlar hocam. İyi müteahhittir bu tüfekçi, yani şeydir. Benim çocukluk arkadaşım.
Yok
yani.
ya, niye yapışmadın lan sen de?
Yani şeydir.
Niye yapışmadın?
Çok düzgün insanlar esasında. Yalancılık yap da kendine yapmaz yani. Bunlar böyle çocukluktan yani okumuş bir değil yani. Bunlar makinesi. O dozer alırdı, bu dozer alırdı, birleştirdi, Caterpillar aldı falan, gazı işine girdi, bilmem ne işine girdi. Ondan sonra böyle bir sınıf müteahhit oldu. Yani şu anda daha ocağın, ocak tesisi var. Çünkü bu uçak bunu yeni çıkarır. Beton santralı var. Birinci sınıf müteahhit.
600 kişi çalışıyor dediler. Ben
Tabii,
dinledim.
tabii.
Ben başkası şey yaptı ama
Evet.
kendi konuşmadı ama.
Eski yapalım. Yaptırırız yani, yaptırırız. Çalışsın arkadaşlar da dedik gençler. Ben mesela şimdi daha dediğim gibi şeye çekildim. Mesela orada bizim Paşa'nın güzel bir oteli var, orada olduğum gibi. Paşa'nın oteli. Ve Paşa'dan ben gözler. İyi de otel. Zor oluyor. Yani Türkiye'miz de çok katılık olacak. Çok daha ya. Ama işte bak. Hepsi bak açık söylüyoruz. Açık söyleyemeyiz. Günün için gelmedik. Ben geleceğimizi bilmiyorum. Yani bundan sonra iki toplantım var diye tereye dedim yani. İki tane gideceğim. Hocam diyor, sana diyor ilave masraf çıkacak. O masraf zaten beraber geldi deseydiniz. Herkese de söyle. Doğru. Herkese de söyle. Yok Serhat sağlam. İçlerinden 3 tanesini bana da yapmasın dedi, bir tanesini öyle. Çok yazdı.
Orada bir tane
Bana bir de öğrenci alıp geliyor mu, gelmiyor mu, alıyor mu, geliyor mu, gelmiyor mu bilmiyorum yani. Beraber gidecekler, birazcık konuştuk işte. Tayyip de sorumlusu kaç kişi geldi. Valla 8 kapı. Anlısı. İkinci. 8 kişi kaldı. Valla ne yaparsın 8 kişi.
Sayın Başkan.
Yapalım.
Sayın TMMOB İMO Şube Başkanı ve yöneticileri, Sayın Avusturya Federal Uzman İnşaat Mühendisleri Grubu Başkanı, çok değerli hocalarımız ve siz kıymetli misafirler. İnşaat Mühendisleri Odası tarafından düzenlenen etkinliğimize hoş geldiniz. Bugün 2. Ulusal İnşaat Mühendisliği Sempozyumu'nun 2. günü, 16 Eylül'de Yapılar için Doğadan İlham Alan Çözümler Konferansı, 17 Eylül'de ise sıvılaşan zeminlerde laboratuvar uygulamaları çalıştayı gerçekleştirildi. Dear Chamber of Civil Engineers, Branch Chair and Executives, dear Chairman of the Federal Expert Group of Civil Engineers of Austria, our dear professors and dear guests, welcome all to the second National Civil Engineering Symposium. Today is the second day of National Civil Engineering Symposium. On the 16th will be second Nature-Inspired Solution for the Built Environment Conference. And on the last day will be International Workshop on Advancing Laboratory Testing of Liquefiable Soils. Now I would like to present Mr. Assistant Professor Berto for the opening.
Yes, today we will continue on to our second National Civil Engineering Symposium. According to the program, there will be 4 sessions today. First 2 will be before lunch, and after lunch we are going to take another 2 will be held. First session will be about transport, will be about construction management, and then transportation engineering. And after lunch there will be 2 sessions about construction materials. I'm going to invite Professor Dr. Fatih Çelik as the session chair. Thank you very much, John. Good morning, my colleagues. I am opening the fourth session of our conference. In this session, there will be one keynote speaker and 4 paper presentations. The keynote speaker is one of my dearest friend, Professor Dr. Talat Birgeli from Middle East Technical University. Actually, you can see his short CV on the screen, so probably I will not read it here, but he is one of the leading professors, especially in construction management among Turkish universities. I have known him since 40-something years, 45 years. We have very good collaboration in many conferences, in many studies, as you can see his CV there, he has some 43 years of experience in education. I would like to introduce him to you, Professor Talat Birgeli. The floor is yours.
Okay. Good morning, ladies and gentlemen. Good morning, dear Chairman. Thank you very much for joining my presentation at this early hour of the day. And I am very much pleased to be a part of this meeting and honored in addressing this very selective audience. Also, I would like to thank to Cyprus Chamber of Civil Engineers inviting me and personally to Gülhan Başkan, Tahir Hoca, Ayşe Hoca, Abdullah Hoca, Kale, Kızıldere, and Enver Toker for the support and hospitality that they have shown to me during the Congress. My speech will be a little bit different than those of the traditional speeches that you used to listen. Within this context, I tried to prepare a presentation as entertaining as possible. For the senior colleagues, it will be a nostalgic journey at which they will refresh their memories, and for the more younger and junior colleagues, it will be a timeline journey, learning how construction management topics have evolved within the last 4 decades. Now, let's get started. As you can see, the division that I belong to is construction management, and naturally, I am going to talk about construction management. Now, ladies and gentlemen, if you happen to read this, it is composed of 2 words. One of them is construction, which is purely technical, scientific, and the other one is rather different to us, which is management. So if you combine these 2 words, what we come to a conclusion is that management is a combination of art and science. Okay, this is for sure, and this is being reported in the literature. So if you combine this construction management together and read it together, the definition becomes as it is an interdisciplinary science which exists at the intersection point of 2 applied sciences, namely construction and management. Maybe this picture, which is the picture of an ostrich, Devekuş in Turkish, could explain the status of construction management, because it is a bird It belongs to the family of birds. It has got wings, but it cannot fly. And it can run as quickly and as speed as 50-60 kilometers per hour. So construction management is something in between at the interface of two things. And sometimes our dear colleagues address construction management discipline as soft science. When I was a little bit or more younger, I was a little bit worried and irritated from this nomenclature. But now I am proud to be a soft science, and we are trying to be twice as soft as possible in this construction management discipline. Now, if we go a little bit further, you see construction management is a professional service that provides project owners with effective management of project schedule, cost, quality, safety, scope, and function. Within this context, in my presentation, I am going to focus on time, cost, and quality aspects within the forthcoming slides. Now, this is the very famous triangle. This triangle is known as project management triangle, or sometimes in the literature, triple constraint. And in Turkish, it is being translated as üçlü sacaya, while defining the project management practices. In one vertex of the triangle, here comes the time. In my opinion, time is the most important aspect within this construction planning process, because once it is being consumed, it cannot be recovered. A contractor can earn more money, but a contractor cannot earn more time. So every project has a starting date, finishing date, and duration, and you have to complete the job within the predetermined time, on time. And if you, what will happen if you cannot finish it on time? Then you have to pay daily penalties. And even if you cannot finish the job at the time extension, then most probably the contract will be terminated. Your guarantee letters will be cashed, and you will be banned from public procurements for 1 or 2 years. And most probably there will be legal lawsuits that will come to you, your company. The second one is the cost. You have to complete the job on time, and also you have to complete the project at the desired quality level. But these are the three classical approaches. Nowadays, there are some additional factors which have been added to this triangle. One of them is health and safety measures. You have to finish the job on time, within budget, and at the desired quality. But if you have 5 injuries, this is not acceptable. Our target is 0 death rates and 0 injury rates. Also, if you finish the job on time, within budget, at the desired level, with no health and safety problems, but if you have 5 or 10 legal disputes with the subcontractors or with the client, also this is something undesirable. And there is also one very, very famous word that has entered into our agenda, which is sustainability. You have to respect to the environment. You have to minimize the waste. You have to apply the governing rules in order to ensure green and safety structures. Now, I am going to take you today we are going to start with the evolution of time management subjects, and I am going to take you details till to the starting years of 1910s. This is Mr. Henry Lawrence Gant. He is from the States. He is a mechanical engineer and a management consultant. And his main contribution into the field of management is the development of this bar chart, or as a tribute to his name, Gantt charts. What is happening is that you see in one axis we have the time scale, and on the vertical scale the subjects that are under the investigation. And you see it is very clear the development or the progress of the job could be understood it is easy to draw. You don't need any drafting experience. Easy to understand, even for the ordinary workers. If you hang it at the entrance point of the company, even the ordinary worker will understand what is going to be done within the next coming days. Shows the passing of time, and you could compare with what is done and what will be done in the future. There is continuity, and a break in the records is immediately seen, and it is compact. You can take it to home, put it into your pocket. You can print it in an A4 size paper, but, ladies and gentlemen, there is one great disadvantage. There is one great shortcoming associated with this bar charts, which is it is static, it is not dynamic, and it doesn't show the interrelationship of activities between each other. In other words, if the foundation job is being delayed 2 days, what will be the effect of this 2 delay on the 4th floor construction cannot be seen on this bar charts. So as a result of this very big shortcoming, it is being criticized bitterly, and in the United States during the years 1956 and 67, the critical method has been developed as a reaction to the static nature of this Gantt charts. It was developed by Kelly and Walker in an attempt to reduce the cost associated with the shutdown and operation restarts due to inefficient schedule. Now, at this part of the lecture, I want to introduce one gentleman. This is Professor Dr. David Arditi, a professor of myself and also a very close friend of Tahir. And he's a graduate of Middle East Technical University. Upon his graduation, he has gone to Loughborough University and conducted his PhD. His PhD was on CPM application. And immediately after completing his PhD, he has returned to Middle East Technical University and started as a full-time professor. And I was those very lucky students who found the opportunity of taking this construction planning course from him immediately after his return to Turkey. So his contribution to this field is very important, and we have learned how to conduct CPM analysis, and we have given lots of consultancy services to the companies, and we have taught this topic to thousands of students. So this is the person who has brought the CPM approach to Turkey, and then later work afterwards it has been spread all over Turkey. Also, ladies and gentlemen, there is one more time management technique, which is known as program evaluation and review technique. Again, it is being simultaneously developed together with the CPM, but they are not aware of each other. This has been developed in the year 1958 by the US Navy in the planning and scheduling of Polaris nuclear missile. It could be fired either from the submarine or from the land. And in the construction or in the building of this missile, there exists 3,008 contractors and more than 6 activities. The only difference between CPM and PAT is that CPM is the deterministic approach, PAT is the probabilistic approach. In other words, in the PAT, we have 3 time estimates, as you see, the optimistic time, the most likely time, and the pessimistic time. And the formulation is this in order to find the expected mean time. But in the construction industry, we never use this PAT, but as for the sake of completeness, I am lecturing this subject also to my students. This is more popular for the industrial engineers, for the mechanical engineers. And now I will pass to quality management topic, which is one important aspect of the project management. Now, these are the definitions regarding to quality. These are the rules of the quality subject, which is cross, limit, Juran, and Görna. These are the definitions for quality. But when we pass from these general definitions to the construction sector, it is understood as the ability to meet the requirements contracted with the clients. In other words, if you sign a contract in order to construct a 3-star hotel, then you have to construct according to this 3-star quality levels. You do not either increase or decrease it. Now, if we further continue with this quality management aspects, this is the development of the subject in the Western organizations. And finally, in the year 1992, the British standards 7,850 for total quality management is published. So this is the popular topic within the 1980s and 90s. Now, when we again return back to the construction industry, great expenditures of time, money, and resources are wasted due to insufficient or non-existent quality levels in the construction industry. And at this part of the presentation, I would like to introduce the quality cost breakdown, which is known in the literature as PAF approach. What do we mean is that the quality control cost, which is the curve that you see on the right hand side of the screen, it starts with 100% defects and goes to the 0 defects. You see at the 100% defect, the cost is minimum, and as the defects decreases, and I don't see it. Never mind. The quality control cost is the summation of prevention cost and appraisal cost. Prevention cost is translated into Turkish as the design reviews, education, training, and supplier selection process improvement. And appraisal cost could be translated into Turkish as değerlendirme maliyetleri, which is associated with the measuring, evaluating, and inspection costs. And failure cost is composed of internal failure costs and external failure costs. Internal failure costs are the associated costs until to the time that the product is being delivered to the customer, and external failure costs are the costs that occur after the delivery of the product to the customer. Now, the external failure costs could be somehow very dramatic, because under normal circumstances, if you buy a TV, the guarantee period is something like 2 years. In the case of houses and summer houses, the guarantee period is 5 years. But if the defect is hidden and occurred by cheating or gross negligence, then the guarantee period continues till to the eternity. There is no guarantee period. The contractor is responsible till to the end of its life. Okay, so external failure costs are very important and should be avoided somehow. So if you sum them up, the total cost of quality is equal to the quality control cost and failure cost. This is the graph that is being developed for the manufacturing industry. We have used this approach, which is the PAF approach, into the construction industry and come to the conclusion that this approach could also be applicable for the construction industry. Now, ladies and gentlemen, I will come to other topic, which I believe very, very important. It is famous and it is becoming more and more famous. It's a very hot topic, it's a very trendy topic, which is known as claim management. The Turkish for claim management is hukuksal hak talepleri, could be translated into Turkish as hukuksal hak talepleri. And you see the definition, which is a collective term for the advice and services provided in respect of claims for the compensation, reiteration, or any other remedy for financial loss or breach of contractual obligations. Now, ladies and gentlemen, 5 or 10 years ago, I met a British lawyer, and while we are talking, I have asked him, what are the most important contributions of this British people to our community, to the world. And he has said that we have invented the football, and also he said that we have invented the claim management. Maybe if you ask it today, maybe democratic monarchy after the death of Queen Elizabeth II could be the third option. Okay, but British people are very proud that they have invented the football and they have invented the claim management. So British lawyers are very, very powerful, especially in this claim management process. Now, as a civil engineer, we are among civil engineers. What can you do in this claim management process? As that in the courts, you can serve as expert witness. If you are over the age of 25 and having a professional experience of 3 years, everybody in this salon would serve to the courts as expert witness. In arbitration process, other than the cases being held in arbitration tribunals, you can be an expert. You can, this is becoming more or less very familiar, dispute education board member, uyuşmazlık çözüm kurulu üyeliği. This is, I have acted as dispute education board member in Ümraniye Maternity Hospital, in Kartal Oncology Hospital, in Göztepe and Ok Meydanı Hospital, and Haydarpaşa Vocational High School projects. The decision of the dispute education board is binding, but it is not final. If you are unhappy with the decision of the dispute education board, within 28 days, you can issue a letter of dissatisfaction. So after memnuniyetsizlik belgesi, after the issuance of this letter, you can go to the arbitral tribunal. But the decision has to be obeyed and the construction has to continue. This is the principal idea in dispute education membership process. The job has to continue, or you can act as arbiter, a judge in the arbitration, or also you can serve as a consultant. So if you have a look to this profile, as civil engineers, we can work in some of the positions that has been advertised in here. Now, the frequently observed dispute headings could be listed in the claim management as delay analysis, delay, disruption, and quantum, which I am going to talk in the forthcoming slide. There are change orders, so in the existence of change orders, what should be done? Termination of the contract is very, very popular. You have to come to a conclusion whether it is a rightful or unjust termination. And if it is an unjust termination, then you have to calculate the loss of profit. If you are in a position to derive new unit price formation, there is always a dispute between the client and the contractor, and the contents of the unit price are always a disputed item. Now, also final account computations, kesin hesap çıkarılması is always in the agenda of the Turkish courts. Now, at this part of the lecture, I am going to pass to a new chapter, which is delay, disruption, and quantum. In London, if you walk into any law office, okay, you might come across with two types of experts. One type of experts, one category experts they are the experts for delay and disruption, and the other part of the experts is quantum. And I am very proud that majority of our students are serving in this law offices in London, in British, in Singapore, in Qatar, Abu Dhabi, and elsewhere. So these topics are relatively familiar and suitable for the Turkish way of thinking. Now, what do we mean by saying delays? It is concerned with time, and if a delay is concerned, you have to make an analysis. How you are going to make the analysis? You are going to make the analysis by using the CPM method that I have taught in the first slides. Okay, CPM method is being used for the delay analysis. Now, disruption is something very fuzzy, and it is concerned with the disturbance, hindrance, or interruption per contractor's normal work, which results in lower productivity or efficiency. And disruption and delay are the two terms which are being used within the same breath. This is quite understandable because the causes of this delay and disruption could originate from the same event, but they are not the same thing. There is an analogy similar to the egg and chicken analogy, but the disruption could turn into a delay, and delay could cause a disruption. But the main difference between delay and disruption is that in order to avoid an extension of time from the delay, it has to be on the critical part. If it is not on the critical part, and if it is not affecting the final termination completion date of the project, we do not consider as delay. And on the other way, disruption could take any place, even on the non-critical part, and it causes, under these circumstances, the financial loss of the contractor should be paid, even if it is occurring at a non-critical activity. And the third one is quantum. Quantum is the computation of monetary amounts awarded by the court in the which is to be paid to a successful party in a claim. So delay, disruption, and quantum are the most disputable amounts, and we have to work on this because it is coming through the agenda of every day, especially in international arbitration. These are the hot topics. Now, at this part of the claim management, I will pass to float. Float is called in Turkish bolluk. And how do we obtain this float is that from the CPM analysis. Float is the flexibility of that activity which could be delayed. In other words, if the float is 28 days, then this means that that activity could be delayed 28 days without affecting the final termination of the project. And if the float is 0 days, then this means that this is a critical activity. That's to mean that there is no flexibility at all. The earliest start and earliest finish dates coincide with each other. Latest start and latest finish times coincide with each other. It is something very dangerous. The contract management processes, the project management manager should express special attention to these critical activities. Critical part is the longest part in a project, having the shortest duration, and within this context, in a project there should be at least one critical part. There could be 2 critical parts, there could be 5 critical parts, and even all the activities in a project would be critical if their floats are 0. Now, this is something very debatable, so I want to share my experience because there are lots of discussion going on about the float ownership. Okay, who owns the float? Bolluk kime ait? Okay, there are 2 schools of thinking about this. Here, the contractor says that we have prepared the work program, we have determined the method of construction, we have allocated the budget, we have organized the cash flow. So, in the case of a float, this float belongs to us. Whereas the employer says 1 minute. We are the boss, we are paying the money, and at the end of the project will belong to us. So we do have the right to consume float. And after years of discussion, this is the final conclusion related to float ownership. According to Society of Construction Law, which is a British non-profit organization, it is being determined or it is being advised that float is not the exclusive user benefit to either of the employer or contractor. It doesn't belong to the contractor. It doesn't belong to the employer. It is a common commodity which belongs to the project, and the float could be used even by the contractor or employer on a first come, first basis. Okay, but if the float is 28 days, say, and if the contractor, if the employer has been delayed 14 days, then the contractor cannot be granted an extension of time. Whereas if the float is 28 days, but the employer has delayed 30 days, then this time the contractor has the right for a 2-day extension of time. Now, this is the second debatable topic, which is concurrent delays. Delays are not always occurring by the employer or by the contractor, but delays could occur concurrently, both at the same time simultaneously by the employer and contractor. And what will happen in the case that we have a concurrent delay? You see, this is some example for the concurrent delay. One example is true concurrency. This is a very narrow definition of true concurrency. You see, it is very seldom occurs, but this is the critical part. On the critical part, the employer started to delay, and immediately at the same time, the contractor started to delay the job. If it is on the critical part and if it is being triggered by the employer, under this scenario, the contractor should be given an extension of time, because the employer is the responsible body and he is the body who has started the delay at the first instance. The contractor has been inspired, the contractor has been affected by this delay. Whereas this is more or less more important. This is an example for the concurrent delay. And you see, in this time, the contractor started a delay on the 21st of January, and it is continuing while the delay is still valid, or starting on the 1st of February, and in between the dates to the 14th of February, the employer at the same time started to delay. So under this scenario, the contractor will be given a time extension by reducing the employer's delaying time? No, under this scenario, since the contractor has already started the delay, the employer's delay has no effect on the contractor's delay. Under this scenario, the contractor will not be given any time extension due to the period between the 1st of February and 14th of February due to the default of the employer. This is the case for concurrent delays, and I think in today's presentation, these two topics, which is the ownership of float and concurrent delays, are the most important items that you have to keep in your mind, because these are very debatable subjects and it has been written nowhere. The knowledge regarding to this is something kept hidden, so please make a note. Now, what are the observations and recommendations regarding to this claim management and time management sector? Is that we have an industry culture, you know, civil engineers and contractors have a culture, and there is what I have seen is that there is a reluctance to planning and frequent updating. The planning is being done just for the sake of a contractor obligation, and it is not being updated. And the project manager generally prints these handouts or outputs and put it as a wallpaper under at the backside of his room. It is used for decorative purposes and never been updated. Whereas in the societal construction law, it is been said that it should be updated within every month. Whereas I agree to do this job within every 3 months. 3 months is also could be acceptable. Also in the time management, we have the wait and see approach. This approach is strongly discouraged. It should be strongly discouraged. And immediately at the occurrence of this delay, the necessary steps should be taken. We have in the sector a very rapid staff turnover. An engineer works 3 months and then he resigns and goes to or transfers to another company and then to the other company. And while going there, he takes the laptop or he erases some very useful information. Since the construction companies do not have organizational memories, there is a loss in the information being gathered, and this is a final drawback, especially in claim management practices. There is a lack of communication between parties. The lawyers, engineers, the consultants do not understand the situation exactly, and they could have some fluctuating documents. In Turkey, what we have seen is that Turkish contractors have a very poor record regarding poor documentation and collecting lack of sufficient data. When the things are going properly, they never document it. They obey to the verbal conversation rather than the written conversation, and which becomes a very important drawback, especially in case of law management. And this is just a reputation, but I say there is a very poor record in quality achievement. Now, I have 5 minutes, so let me talk about some potential research teams. We cannot think of a construction industry independent of global problems. So the construction industry has to lead on solution-oriented and high-impact research topics. Within this context, I am going to talk about sustainable development goals. In the year 2015, at the General Assembly of United Nations, this sustainable development goals has been signed. 195 countries have signed this sustainable development goals. There exist 17 sustainable development goals, and the countries that have signed this protocol has agreed that till the year 2030 they will achieve these standards. Among these 17 sustainable development goals, I believe this 3 is related to the construction industry, and it would be a further research topic, especially for the young generations, for the master and PhD students having difficulty in finding these topics. Some of them is clean water and sanitation, the other thing is affordable and clean energy, and the other one is sustainable cities and communities. These are, I have selected among the 7 sustainable development goals. Now, digitalization is a concept that is affecting every industry, and as construction industry, we are taking our share. It is an enabler for a more efficient and sustainable construction industry, such as digital twins, virtual reality, augmented reality, robotics, information technologies. It is not slowly, but it is very rapidly entering into our agenda. And these, especially for the young generation, please note this word, resilience and resilience, resilient and resilience, dirençlilik. This is also entering our agenda. This is a critical success factor, for extreme events such as pandemics, disasters, and risks. We have earthquakes, we have landslides, we have wildfires, we have floods. So the construction industry should be prepared for in a resilient manner to these risks. And ladies and gentlemen, this is one concept which I believe is very important: globalization. It is a synthetic word, right? The glo comes from the global and cal comes from the local. So altogether, it is localization. What does this mean? Is that your company is to be a global company while paying attention to the local laws, regulations, customs that is inherent in the country that you are operating. So you are going to be a global company, but you should be taking advice from your local partners. This is known as globalization. Ladies and gentlemen, this off-site and modular construction, in my opinion, is very, very important, and it is not an investment decision or proposal, but it is going to be very popular within the next coming years. Public-private partnership, BOTs, are very, very important. Lean and green type of approaches are very important. The green building information modeling, in my opinion, is a very hot topic, and again, in my opinion, it will shape the curriculums of the not only civil engineering departments, but the mechanical and engineering departments, and most probably within the next forthcoming years, there will be a mass course for the lean. Lean is something very spiritual. It is being created by the Toyota company. It is being based on respect and Kaizen in Japanese. Kaizen means continuous improvement. The aim is to minimize the cost and to maximize the value. Within this context, all non-value added processes are being discarded from the operation, and waste minimization should be encouraged. And when they say waste, it is not only the material scrap, but it is time, it is rework, it is the cost that is being paid to the storage areas. Just in time installation should be encouraged, so on. Green is self-explanatory, which is being in the hot topics for the next years. Now, I have run out of time, but there is a very huge discussion about the name of this division. We first start with yapı stratejisi in construction strategy in Madrid during the years 1980. This is the name given by Dr. David Arditi, but this is a very narrow definition, so we abandon it because it doesn't accommodate all the aspects of the construction management practices. Later, this yapı işletmesi is being used by İTÜ Civil Engineering Department, Yıldız Teknik Üniversitesi, Akdeniz University, Ege University, and Higher Education Board, which I believe is a very wrong name because it is being translated in a very defaulted manner. Yapı yönetimi is something very miserable. It's being used by Eskişehir Teknik Üniversitesi and Beykoz Üniversitesi. Whereas yapım yönetimi is the correct word, which is being used by METU, Boğaziçi Üniversitesi, the Scientific Research Council of Turkey, Karadeniz Teknik Üniversitesi, Bilgi Üniversitesi, and İTÜ Faculty of Architecture. This is the conclusion. İTÜ Civil Engineering Department uses yapı işletmesi, whereas İTÜ Mimarlık Fakültesi uses yapım yönetimi. So this is a debate among the parties. And in my opinion, the correct name should be yapım mühendisliği ve yönetimi, construction engineering and management. Now, I am coming to the last two slides. At this part of the presentation, I would like to introduce you gentleman, Mr. Ekrem Yeşilada. As you can understand, as you can expect from the surname, he is born in Nicosia. He is graduated, he is one of the very early graduates of Istanbul Technical University. And during the years 1984 and 87, he has acted as a full-time member, and even a chairman in Eastern Mediterranean University. And also within these years, he has acted as a part-time lecturer in Metro. Now, upon his research and upon conducting his research in UCL, he has returned back to Turkey to the General Directorate of Highways, and he has prepared the general price analysis. And while preparing this general price analysis, he has made a translation, and while translating ship's bootroller, he said to me that due to his poor Turkish, he has translated ship's bootroller as Pechaya. He couldn't understand the difference between sheep and goat, so he has named the ship's bootroller as Pechaya. This is something by mistake, but the construction industry is happy, and although the translation is wrong, we are still continuing Pechaya in the Turkish, and I would like to bring this anecdote as a tribute to Mr. Ekrem Mishradan. And this will be the last slide. I am running out of time. I am delayed 3 minutes. This is the concrete boat that happens, that exists at the parking garage, parking lot of Middle East Technical University Civil Engineering Department. This has been built in the year 1976 by the inspiration from Swedish boatsmen, Swedish fishermen, and it is made from ferro cement, and in between there is a wire mesh. It has never been tested, but it's a good anecdote to bring to the attention of, we are not only dealing with management aspects, but we are also dealing with the construction engineering part. It has become a legend, it has become a landmark, just like Eiffel Tower. It is one of the landmarks of our university. So next time, if you happen to visit me in Middle East Technical University, you have to say to the taxi driver, beni Betonkaya'ya götür, and that will be the sufficient thing in order to reach me. I will be welcoming you right at there. Now, ladies and gentlemen, that completes my presentation for today. In case that you have questions, I can answer them right now, or I will be available during the coffee break or lunch, or after departure from Turkey. Also, you can contact me via email. We are open to any kind of collaboration and discussion among the parties. Thank you very much for your attendance.
Thank you very much for Professor Dr. Talat Bilgin'in quite illustrative presentation.
That means we have no question then.
If there is any question, you can ask it now or after for
I will be
presentation.
available at the coffee. Yeah, the coffee or lunch also.
We have a question answer sessions for presentations after. You can ask that time as well.
Okay.
Thanks.
Ana konuşmacımız olan Profesör Doktor Talat Bilgin'in kendisini vermek üzere Kıbrıs Türk Mühendisleri Mimar Odaları Birliği onun kurulu başkanı Sayın Serhan Aysal'ı sahneye davet ediyorum.
Kısmet sanaymış. Teşekkür ederim. Aldım, kabul ettim. Çok teşekkür ederim.
Thank you. Now we are going to start the papers presentations. As I said, in this session there are 4 papers to be presented. First one to be presented by Tahir Çelik, so I may invite myself to do my presentation over there. As you can hear me now, optimization of reinforcement steel in building construction projects. Actually, this is a master thesis prepared one of my students. His name is Abdul Ibrahim Kamara. Abdul, can you show yourself, please? Here is the guy. We just completed the thesis, and I would like to do the outputs of this master thesis. It is one of the important issues of construction industry, especially in Cyprus here. I have some so many years experience, and I know that we always uses more than the designed amount of reinforcement in our construction. If we talk about waste stages of reinforcement in building construction, there could be unavoidable reinforcement waste. What are those? Cutting bar waste after optimization. You can make an optimization, but still, because the length of the bar is standard 12 meters, some amount, some length is unfortunately unavoidable and should be wasted. Or expenditures required to reduce waste is superior in economy. You say, rather than doing optimization, spending time, engineering costs, etc., better not to do it. Avoidable waste caused by disorganized operating technique on the construction site, using excessive bars or longer than the required length. This is the most important part of the problem. Unoptimized waste delivered 12-meter long bars were ineffectively cut. This is again one of the important points I want to talk. As a result, leftover pieces longer than 1 meter may be economically unusable. However, our statistics are clever enough. On construction sites, you may not find those pieces. They left in the concrete, so you don't see any base here. Rework is quite obvious. If you change your design and do it again, and design changes result is rework comes down. And production of defective or non-compliant with the standard of reinforcement. This is a bit unclear in this country because we do not do regularly what reinforcement are imported to this country. Sometimes some reinforcement could be out of standard. What do we do with them? Just waste. To minimize the waste, different stages, one is pre-design. You will prepare a feasibility study. What is feasibility study? Everybody knows this. You will make marketing, financial, and technical analysis and see which one is better for you. Structural design stage, selection of parameters among many. You know, many or most, probably most of us are using computer programs in structural design, and once this analysis is done, the program tells us you can use reinforcement diameter 14, 16, 18, 20, whatever it is, which one you are going to select. While selecting, an optimization can be done. Construction stage, of course, application optimization system. I don't see any construction project in our country makes this optimization. Economic effects, amount of material to be produced, how more from the, amount of material to be purchased, to be procured. How more from the exact design BOQ. You know, today the computer programs we use give actually us what is the exact amount of reinforcement required. But we always discuss how much more you are going to buy reinforcement from that amount. Disposing cost of waste material from the site and still fixed wages. Using excessive bars or longer lengths than the required lengths, actually more reinforcement is used in the construction, and you pay the cost of these workmanship, cost of these reinforcement. Normally, we used to teach calculation of BOQ by using Excel, something like this. So what do we do here? We describe what are the places for reinforcement, then diameters, then lengths from design. These are the exact lengths specified by project, and how many number of them, and then if there are similar elements. And then by using an if command, it goes and multiplies this, and this, and fix it under the diameter. 20 millimeter or 16 millimeter. Here goes and put under 16 millimeter. It's a simple, easy if command by using Excel. You can calculate all the reinforcement here, as you see, by multiplying them. So what I want to say here, by using Excel, you can create from each parameter what length or weight of reinforcement will be used exactly. These are designed BOQ. From that point on, very cool. So one of the most fundamental definition of optimization, you can find many definitions in the literature. The one I like most is doing the most with the least. Reinforcement bars are manually or mechanically cut to the appropriate lengths and bent into the shapes specified on the project model. This is what the statistics do. Before cutting the bar cutting schedule needs to be developed and given to steel fixers. As many years ago, while I was doing my study and case studies in Britain, I have learned that in Britain, a steel fixer cannot start to cut reinforcement by himself. He prepares a schedule, he goes and gets the approval of the engineer, and then he applies it, which is not done in our country. Therefore, the process of generating a bar cutting pattern that meets demand while producing the least amount of waste is referred to as optimization. In literature, it is mentioned that the waste in the reinforcement can be more than 10 to 15%, more than that. In our thesis study, we use, there are many optimization programs we can find. We use pro-optimization program. This cutting optimization pro is a software that creates cutting and nesting patterns for one or two dimensional materials. We could use one dimensional part of this one. Reduces waste and cost by specifying a maximum cut length from the C bar. It can import data from Microsoft. Here is a screenshot of it. What I can say, you can specify here what is the quantity you require, which then where. And then you can specify your stock here, and it prepares you a graphic something like this, a schedule. It says you can use 16 millimeter diameter, you cut 3 of them, and these are you are going to cut pieces. And no waste here, no waste here. Here there is a waste. You can see. So this is a very easy, very quick, very practical application of this. And at last, you can get a figure for that. It is very easy for us to get this and then give it to steel fixer. Steel fixer will cut reinforcement like this and will reduce the waste. Here is a case study for a construction site, 2-story villa house, 230 square meter. It was me actually controlling this site. This is why I know all the details. We did the BOQ for reinforcement, and then this is what we obtained by applying pro-cutting optimization program. As you see, we have all the detail here from which diameter, how many quantity, how will we cut, etc. And then this is what we obtained. That much reinforcement was actually what? That much 14,800 actually used on the site, and actually remain on the side of this, and required by PRO is this much. So the previous figure showed us that much reinforcement is enough for this construction according to the below quantity. So what we could obtain here, required exact reinforcement by design program, which for structure I used to design this, is 10,445 kilograms. Actually used on the construction site is 14,823 kilograms. Waste rate based on design program, that much. For optimization program, usage rate is this. So that means optimization also has a small waste, unavoidable waste, is 826 kilograms. Saving by optimization is 3,552 kilograms for reinforcement. So this saving is equal to around 24%. 24% reinforcement could be saved if you could use optimization, and if our steel fixer used the graphic prepared by the optimization. So in case of case study, waste rate is 24%. This ratio may change an amount depending on the selected reinforcement steel diameter. Of course, larger diameter, relatively more change. But how much? You can discuss this. Steel fixer, rather than cutting and generating many steel pieces of reinforcement, prefer fixing unnecessarily long parts in. So, in practical, if there is 2 meter length, and if steel fixer finds here 5 meter, it puts in 5 meter, it doesn't cut. If you cut, you will already see it there, so it will 5 with him. So, and you pay as owner the rate of steel fixer. Therefore, the economical impact of the amount of steel fixing is not only purchasing, but includes workmanship price and value. Now, I got this data from Economic and Energy Ministry. Roughly, the reinforcement imported to this country. I don't know, 2021, they couldn't produce it yet, I asked them, but roughly around 100,000 tons of reinforcement we use in this country. So, applying optimization for reinforcement, we say some about 24,000 tons of reinforcement. Including the steel fixer rate, this made around $28 million. This is year. Therefore, my recommendation is reinforcement cutting optimization should be obligatory in GRC. Structural design softwares can do a reinforcement optimization during selecting the best reinforcement diameter. After selecting reinforcement diameter, make an optimization and produce reinforcement traffic or cutting path. I haven't confirmed this, but I heard that one of the design programs can do optimization is Tekla. Bin software Tekla can do this. I heard this. I cannot guarantee, but it's what I heard. So it's not difficult. So here is, I don't know anybody related with the development of these computer softwares for structural design. I think we need to consider them as well. And this could be maintained by a Chamber of Civil Engineers through visa operation of the project. So it is very easy for us to say $28 million in this country per year if our visa office asks this graphic as well and put into the visa file. It is so easy, my friends, so I invite Board of Directors of the Chamber of Civil Engineers to consider it. Thank you for listening. I think at the end of board presentation, some questions may be answered. Okay, now our second presentation will be done by James Budayan. May I invite James Budayan? His presentation will be on is written in Turkish, but let me go ahead. Not certain Turkish, but I will make my presentation. Go ahead.
Today I will make a presentation about different factors and effects of luxury real estate collection advertisements. This study is conducted by me and Sedinaz. First, I would like to introduce myself. Of course, I'm a composition doctor, a British State University, Northern Science campus. All right, first I would like to give information about what I can tell you today. First, I start my presentation with an introduction. I will give details about the research, and I would like to show why we conduct this study and why it is important for the construction industry. Then I will give some background about this subject. For that purpose, I will talk about advertisement appeal and advertisement effectiveness. I will talk about the types of advertisement appeals, and then I will talk about advertisement effectiveness, how we can calculate advertisement effectiveness. There are different methods for that. I will talk about them. Then I will talk about research methodology, how we conduct this study, and finally, we will perform some analysis, what kind of analysis we perform for this study. Based on the outputs of analysis, we will discuss the findings, and finally, I will conclude my presentation with a brief conclusion. In the conclusion, I will state the brief important points, and finally, I would like to give some information how we can improve this study. Firstly, I would like to talk about advertisements. Why we advertisements? As you can see, most of the companies spend a lot of money for advertisement. Firstly, they spend money for advertisement to have an opportunity to communicate with the customer, and branding. Maybe that's construction industry actually didn't spend a lot of money for advertising, but in recent years with the building luxury real estates, they start kind of a lot of money for advertisements. We can see this in this research. As you can see, construction industry is the third longest cycle time, and it is the first with advertisement spots. And although the real estate sector invests in advertising, not all these advertisements have the same level of effect on customers. Therefore, we should understand which advertisements are more effective on the customer, so we can prepare better advertisements and we don't waste our money and time for useless advertisements. In this study, we consider two main advertisement appeals. There are many studies which show that there is a direct relationship between the advertising appeal and effectiveness. So in this study, we focus these two main advertising appeals. In construction industry, unfortunately, there is no study like that. In the literature, there are many studies. And when we check the advertising concept, appeal is a Latin meaning refers to the content or appearance designed to draw attention to any message, object, or person to create interest or to influence people on this equation. As you can see, it's a very critical subject, and we need to issue appeal in advertisements so we can take the attention of the people, draw the attention of the people to our message. We can convey our message to our customers. Right? There are different classifications for advertising appeal. One of the popular ones is David's classification. According to David's, there are two main categories. First one is rational, the other one is emotional. And also there are subcategories of these main categories, but in this study we focus on these two main categories. When we check the literature, we can see that there are different proposals about the effectiveness of these appeals. Some of the researchers support the rational advertisement appeal on the other, and some of them support the emotional advertisement appeal. But when we check this research, we can see that these research are conducted for different industries and for different customer groups. Therefore, in order to understand which is effective for construction tasks, also we need to perform another study for the construction industry. When we check the advertising effectiveness, also there are different definitions for advertising effectiveness. In this one, we show one of them. And according to that, advertising effectiveness refers to the measurement of the results of an advertising campaign or a specific advertisement. There are different methods, models for measuring the advertisement effectiveness. We can see some of them. And in this study also we use these models in order to measure the advertising effectiveness. And when we check the research design, as I said before, we consider the Davis advertising ethical classification. Also, there is a scale which is developed by Beard and Santana and Wells. Based on their scale, we use 14 criteria, and based on these 14 criteria, we try to measure the effectiveness of the advertisements. Pierce and Santos applies two types of tests, so we get these two criteria from this research, and also we use Wells, and Wells scale was used to measure the emotional attraction, and they have 12 criterions parameters, and totally we have 14 criterions, as you can see. Also, when we check the main parts of these criterions, groups of these criterions, you can see that we have few dimensions, and we use these 3 dimensions to measure the advertisement appeals, effectiveness. Then we start collecting the data. For that purpose, we prepare a questionnaire. This questionnaire consists of two parts. First part is about collecting information about participants. Second part is about measuring the effectiveness of the advertisement. In the first part of the questionnaire, the questions about age of the participants, education of the participant, intention of purchasing a new real estate, and advertisement watching habit were asked. We try to get the demographic search of the participants. In the second part, we use 7-point Likert scale. In the first question, we try to understand the recallability of the advertisements. We ask, do you remember the advertisement which we showed to you? They evaluate it with a 7-point Likert scale, as I said before. 1 indicates I don't remember the advertisements. 7 indicates that I remember all the details of these advertisements. In the second question, we ask the enjoyment level, and also we use 7-point Likert scale for that question. And 1 indicates the advertisement is not enjoyable. 7 indicates that the advertisement is very enjoyable. And remaining 12 questions were obtained from balanced scale, as I said before. In this one, we have some statements, and they also they state that whether they agree this statement or not. And we use 7-point scale for that. One means that I agree, I don't agree these statements at all, and 7 indicates that I agree these statements. We perform this advertisement effectiveness questionnaire for each advertisement. For that one, we consider 2 advertisements. The first one reflects the racial advertisement appeal. The other one has the emotional advertisement appeal. We can watch these advertisements via these links. However, due to the time limitation, I skip that part. Also, I know that much time. I will
The last 3 minutes, please.
all right, no problem. When we check the methodology, firstly, the participants complete the first part of the questionnaire, then they watch the first advertisement. We ask the questions related to the effectiveness of this first advertisement, and they watch the second advertisement, and they complete the advertisement effectiveness questions. And when we check the total data, we can see that we have collected 221 data. However, 5 of them were eliminated, since in this questionnaire, participants gave the same answers to all questions. When we check the profile of the participants, as you can see, there is a heterogeneity, so we get different opinions from different groups in this research. And we perform pairwise t-tests. Before performing pairwise t-tests, of course, there are some important preconditions. We check these preconditions, and based on that, we determine that we can perform the pairwise t-test. In this test, we can see the mean of the effectiveness of these advertisements. Here, this. Also, we can see the significance level. This significance level shows whether there is a significant difference between these two mean value. And if it is smaller than 0.05, it means that there is a significant difference. And when we check all these 3 dimensions, you can see that all of them state that there are significant differences between these 2 advertisements effectiveness. And when we check the means, you can see that advertisement 2 has more effect on the participants. And when we summarize the findings, you can see that there are significant differences between emotional and rational advertising appeals. In most of the situations, we think that buying and purchasing a real estate is an important investment, but most of the people consider that facial thinking is important, but emotions are more important because they think that they consider their real estate as a shelter. They want to be happy in their real estate. They want to feel safe in their real estate. Therefore, emotional, fragmented advertisements trigger their emotions, and they are more affected from these kind of advertisements. So the advertisements that inspire customers were determined as effective. Finally, I would like to give some information about how we can improve this study. In this one, as you can see, we just consider two main categories, advertising categories. However, there are subcategories. We also can consider these subcategories, or we consider choose advertisements, but we can increase the number of advertisements, and based on the examining of these different advertisements, maybe we can improve the reliability of the findings. Also, finally, we can consider the profile of the target population. In this one, there are different categories, as you can see. For example, age. We don't consider the age effect, but also age can affect the advertising effectiveness. So we can consider this kind of demographic properties in order to understand the effectiveness of these advertisements. Thank you very much for your attendance. If you have any questions,
Thank you for your presentation. May I please declare okay. Now our third presentation will be done by Hasan Dilek. His presentation titled "The Evaluation of Relationship Between Work Accidents and Occupational Health and Safety in North Cyprus."
Hello everyone. I would like to the organizers to thank all organizers this meeting for inviting me here. Let me introduce myself. I am Hasan Dilek from European University of Lefke. Today, the topic of my presentation speak is the evaluation of relationship between work accidents and occupational health and safety in North Cyprus. By the end of this talk, you will be familiar with understanding important terms, occupational risks, aims, hazards, and gaining awareness to precaution of occupational health and safety, and measuring work accidents as number of injury, mortality, and labor loss amount between 2006 and 2020 for all business sector and construction site. First of all, I would like to give an overview of 5 important terms. The terms in my presentation are obtained from Occupational Health and Safety Study Book. So I will briefly them here. Occupational health and safety is a branch for public health aims improving workplace health and safety standards. Work accident is an unplanned events and events that leads injury and dying of employee and damage to company property. Occupational risk is likely that leads injury as a result of exposure to occupational risk. Hazard define possible danger for health and life of employee. And finally, precaution defined to reduce and or prevent all occupational risk and hazards, all claims, prevention or activity done at work and workplace. Let's move on. Aim of occupational health and safety in North Cyprus. According to the study books, there are 7 aims of occupational health and safety in North Cyprus. They are summary: protecting injury, protecting health and safety of employee, educating, controlling, eliminating and coordinating occupational risks and work accident factors at work and workplace related rules. Let's move, and there are 3 different main hazard types causing occupational accidents. Finally, human-made hazards. Secondly, environmental hazards. Thirdly, occurrence of hazards at workplace. Firstly, human-made hazards are caused by managerial, caused by employee, and caused by incorrect or missing planning and projecting. Secondly, environmental hazards are natural disasters such as flood, earthquake, storm, and hurricane. And finally, mechanical hazards, physical hazards, chemical hazards, biological hazards, electrical hazards and fire hazards are occurrence of hazards at workplace. Let's take a look at methodology part. It is collected from the data of work accidents from the internet site of the ministry. Then it is a study on the data to determine the effect of work accidents on employee and economy of North Cyprus. Equation 1, equation 2, and equation 3 are used to find labor loss according to minimum wage and number of injury employee. So table 1 and table 2 demonstrates number of injury and the number of injured and dying employee, labor loss as a day and currency, and minimum wage for a day as dollar and Turkish lira. Let's move on to session and result parts. The results clearly demonstrate data of work accidents from 2006 to 2020 in North Cyprus as number and percentage to compare between construction site and all business sector can be seen, while 232 employee injury, 6 employee dying, and $250,000 labor loss were occurring each year for all business sector between 2006 to 2020 year. 42 employee injury, 6 employee dying, and 55,000 labor loss were occurred each year for construction sites. 18% this slide, 18% injured employee, 55% dying employee, and 22% labor loss originated work accidents from construction site to compare with all business sector. It is determined precautions to occupational hazards and risks at the source under control is at the source, such as machine, etc. Secondly, in the environment, apply different methods according to environment to prevent risk from their source, such as isolation. And thirdly, for person using personal protective equipment, such as wearing gloves, etc. In conclusion, this study measuring work accidents and harmful understanding important terms, aims, occupational risks, and hazards, and representing precaution of occupational health and safety in North Cyprus. Thank you for your attention. My reference is.
Thank you. Thank you for your presentation. Can we take your head, please? The last presentation of this session will be done by Ali Erhan Öztürk. May I invite you? Item of this presentation is identifying and managing most common risks in Nigerian construction projects.
Okay. Good morning. Yes, this was supposed to be done by my student, of course, master's student Vivian. She has some health issues, so I take it over. Obviously, she's from Nigeria, and we were mostly looking at the construction risk and identification of this mainly. I of course do other similar studies, not only on Nigeria. Students doing it with Oman, in Saudi Arabia, in Palestine, obviously Nigeria, and of course Northern Cyprus. I will talk about my goal. Of course, now I'm presenting it. This is a little bit different than the students' presentation. I will add my thoughts along the way. Starting classically, of course, we do have table of contents as it goes, introduction, literature, methodology, and so on. In introduction, as we all know that construction has associated risks. Everybody knows that. And it is inevitable. We cannot get away from it. And its effect of the way it is affected based on different risks changes from country to country as well. The whole this process is called risk management, of course. And here we try to plan, identify, assess, and provide the best method for handling these risks. And in this research, also the aim was to identify the risk factors in mainly Nigeria. Of course, to look at their connections, group them, and look into the major risk factors in Nigeria. Risk is from French, almost everything is from French, I guess, and first used in 1830s in insurance transactions. Of course, and it became popular and been used for so many years by so many disciplines. Here in construction, of course, when we say risk, we mean the construction aspects or effect of activities that would result in negatively, of course, in our golden triangle: quality, cost, and time. Here, also, of course, we mostly do identify risk items based on using tools such as questionnaire, and we do use statistical methods to analyze them, which has been being used since 1970s, and then in the 80s we started using Monte Carlo simulation, and then SPSS got into our life, and we started to do more complicated analysis. This management process, as a process, of course, we have planning, as I said, identifying risks, and this research, and my main concentration is this identification side. Then, of course, you assess the risk, create a response, and so on. Risk identification, how do we do that? Based on British standards and very commonly done all over the world. We look at professional point of view, mainly meaning experience of the professionals, interviews, another tool, questionnaires, historical information, past events, and so on. Here in this research, we use, of course, questionnaire. Why I'm interested in risk factors, mostly or identification for them, is when I start looking at different countries and developing countries, there are so many research done. I start to see quite a bit variations between country to country, and some were really interesting. For example, when I look at Chile here, I see that water being stolen is #1 reason in Chile, according to their research. So that was interesting, for example. And my student came to me, for example,
when she wanted to start this project. She said we are having problems in stealing of materials or equipment from the site. That's a big problem. I want to test that. So that was the idea of that, and we looked at, of course, results. But when I look at in general the risk factors, most common one I see is funding issues, lack of funding, or somewhat economical, such as interest rates, high interest rates, inflation, and so on, seems to be part of top 5 in almost all research. Here, research methodology, as I said, we search through literature review, create questionnaires. I will talk about them a little bit more. And we filter these risk factors and group them. And here we have the list of first 12 that we have identified for Nigeria. Some of them are general. And as I said, my student wanted to check this physical damage or theft of construction machineries, which apparently is a big problem, the way she thought. That was not the case at the end. And here, these are identified, of course, using searches on Scopus mainly to look at past research, which factors were used. We also do small scale interview or questionnaire, depends on the conditions for the expert knowledge in the field in Nigeria in this case, of course. And in other country research, we try to access them. The way I see, I mean, in Cyprus, we do get lots of international students, and I try to access their country through them, actually. They try to access our education system, and I try to use the other way around to get more information, which is normally very hard to do. It works for us. So there we identified 22 factors there. Questionnaire, I eliminated some of the slides of the student, of course. I don't have the whole questions and stuff. But one of the main things is in questionnaire nowadays is access, face-to-face issues due to COVID pandemic issues. And we mostly use Google Forms to access these individual experts to do the questionnaire. Of course, if we have a sample size issue, we have to always check, identify what should be the minimum population size in our research, and we don't have formulas for that. After we collect the data, one major thing, of course, I was going to say, we grouped these 22 factors in the 3 major sections under project security risks with 10 questions, technical management risks with 30 questions, and owner-client risks with 4 questions. Owner-client risk, you know, if you need to give the example, owner-client is, for example, change in the project or the objective of it, so it comes from the owner side, or technical issues, anything that can go practically on site, or security issues, mainly it was the first item, and there are other ones, of course, whether this equipment or material is being stolen and so on. So we group them into 3 groups. We check the reliability using Chromba Alpha first. There are few of them, and most common one is Chromba Alpha. As long as our number is above 0.6, which all are very close, some of them, but they are still at the limit, we consider the collected data as reliable. Also, there is a normality issue. We look at it. And normality has made 3 tests actually, and I do like Shapiro-Wilk one mainly because it is much better in smaller population size. Also, depending on normality, whether you have it or not, we have to decide on which test to run, parametric, non-parametric. Here we run one way ANOVA test. And we found that there is a significant difference
among the three groups. There was a test run as a whole as well for individual, but as I said, I try to summarize. And based on the relative weights here, we found that the technical management risk category is with 70% has the highest importance. Then comes the security risk with 20% and owner related risk is 20% and security risk 10%. If we look at each one a little bit in more detail, we see that technical management side 66% considers higher, 22% are at mid-level, and the 12% considers it as low impact. From this, we have top 5 technical risk factors identified. Of course, awarding project tasks unqualified designers, wait for approval of regard tests and project inspection, changing the scope of project, miscommunication between project parties, compressed project schedule was the top 5 in this case. Then we have all the crime related. I will not read the numbers, I'm running out of time. Risk factor here was the inability of owner to finance or continue financing a project was number 1. And then on the security side, it was theft and physical damage of construction machinery or equipment in this case. In conclusion, this is the summary of what I just said, but I want to conclude with actually all this research is part of the larger picture that I have in mind. By looking at all these different countries, I want to somehow merge it with North Cyprus and identify the possible effects and the experiences of other countries and the solutions how they can be implemented in Northern Cyprus cases. And of course, we do have references. Thank you for this.
Thank you for the presentation. May I take you here in case if there is any question? Okay, my friends, we have 15 minutes question and answer session. If you want to ask any question, here are the presenter to answer the questions. Yes. Can you present your question once more from the
I can send the findings of the elements. I think that I couldn't understand at first. Yeah. No, we didn't check the duration. I think that you said habits, the habit of the. We asked that question and we checked, but we didn't consider the duration of the advertisement.
Okay, if there is no any question, I think coffee breaks is one of the important issues in our conferences. So please, coffee break session now. Thank you.
Profesör Doktor Tahir Çelik, plaketini vermek üzere İnşaat Mühendisleri Odası Başkanı Sayın Gülkan Yağcıoğlu'nun sahneye aldı.
What's going on? Baby, what's going on? Cold-hearted woman, stop treating me wrong. Baby, what's going on? Baby, what's going on? Cold-hearted woman, stop treating me wrong. Loving you is wrong. That was all your place in That's when I decided.
Bizim iki blok bir fotoğraf alalım. Galo, bro.
Tamam, nereye gitsin abi?
4 adet sunumun yapılacağı ulaşım ve trafik konusundaki seçimimiz, 5. seçimimiz başlamak üzere. Oturum başkanlığını yapmak üzere Doçent Doktor Mehmet Metin Kurt hocamızı hazırlık bekliyor. Hocam
Okay. Today we'll talk about the transportation and traffic engineering. Welcome to this session. We have, first of all, our keynote speaker. I would like to introduce him, just briefly talk about his background. You see, of course, the details there on the screen. Professor Serhan Tanyala is involved with the traffic and transportation related subjects. Today we'll be talking about the autonomous vehicles, what we should expect in the future, both in the world and particularly in Turkey. Without extra explanation, I would like to invite Professor Serhan Tanyala to deliver his keynote speech.
First of all, I would like to thank the Chamber of Civil Engineers and the organizing committee for inviting me to this important organization. I am very happy to be here. The last time I was in Cyprus, it was 27 years ago for my honeymoon. So it was a very pleasant visit. So I would like to thank you again. Now today, I would like to give some information about my opinion about autonomous vehicles. What are they? What should we expect from them? What is waiting for us? Because it is somehow a new concept, but there are many studies are being done and presented in the literature. The first time that we have mentioned about this subject, it was 2010. There were very limited studies. At that time, no studies in Turkey. But after 2015, especially 2020, we see that enormous increase in literature about autonomous vehicles and their implementation in our daily life. Now, the layout of my presentation includes these headlines: the transportation concept, urban development, transportation relation, autonomous vehicles. What do we expect from autonomous vehicles, especially from capacity point of view? I will try to give you some information about that. And what are the threats and opportunities that autonomous vehicles will bring us during this time? First of all, I would like to give some brief description of transportation, what it means today. As transportation is defined as the displacement of physical unit from a starting point to a destination, or the transfer of cargo and passengers from one place to another. Today, not only physical elements are the subject of transportation, but also the transportation of information and images between 2 points has made it necessary to expand the definition. So this is what we just we should take a baseline for autonomous vehicles. And we can say that from Associate Professor Muzaffer Bakırcı's definition, if I can translate it in English properly or not, I don't know, but in this context, transportation can be defined as the activity of transporting people and their goods, raw or processed, and services means information and images from one point to another by various means, which are all included, we should discuss or use for developing systems that involves autonomous vehicles. Now, when we look back in transportation engineering, especially for transportation planning purposes, 3 different perspectives have been used in the design of transportation systems since the beginning of the 20th century. The first perspective, which was the worst one, but the one that most affects our daily lives, is the traffic perspective, that we put passenger cars as the main subject of our plans, and we try to develop our cities, our daily life according to give enough space for passenger cars. That which I'm very sorry to see that in Cyprus. Yeah, you are still working using unfortunately traffic perspective. The second one, the mobility perspective, it was discussed, and most of the transportation master plans are developed according to this perspective. The movement of passengers or goods are main objectives. But today, I think the first time we just mentioned about accessibility was 2006 or 2007, if I'm not wrong, that we started to use it in Turkey. The accessibility program is that it is the ease of people to reach their aims, for example, goods, services, activities, for example, the ability to reach health facilities, or get some goods to buy something. And this perspective showed its importance during this pandemic process. So the logistics also made some big leap that everybody understood what it means today. Now, for example, we start from traffic congestion. This is our daily lives most important, one of the most important problem in our daily lives. Now, when you experience a traffic congestion, then I couldn't make it, yes. Improvement of the transportation system is needed. And when we improve the transportation system, the increase in the accessibility, we observe an increase in accessibility. The increase in accessibility may lead to a change in land use, which may, if not controlled, increase of travel demand, and the increase of travel demand may result in traffic congestion also. So it is a problem of planning, and you should know the tools in your hands to make a sustainable transportation plan. Now, nowadays, we talk about in Turkey, sustainable transportation planning processes are being done in many cities, and the others are trying to make plans about this concept. But I am not sure that we all knew what it will bring us. So we are just doing it as it is a popular thing in the United States and Europe. Now, as we know that the cities belong to people and other living beings like animals or plants, but we design our cities according to passenger cars for a long time. If plans are made by not only transportation plans but urban design plans, if plans are made by considering the transport land use relationship, human-friendly, environmental livable cities can be obtained. But if we design cities for automobiles, we will achieve an environment where environmental pollution reaches incredible rates, traffic jams are constantly experienced, and people are unhappy. That we all know now today. Now, in this concept, autonomous vehicles may provide you some important tools, but it is the matter of how you use it. So we should understand the outcome, the threats, the opportunities, what they will bring us. Now, an autonomous vehicle can be defined as a vehicle that can transport the vehicle from one point to another without human intervention or remote control. Autonomous vehicles are thought to be able to detect certain dangerous situations in traffic faster than humans and react more quickly. As a result of all this, the use of autonomous vehicles is expected to achieve increased motorway and intersection capacities, reduce accident numbers, increase in time, fuel, and energy efficiency, and so on. But these are the benefits that we expect. It is not a new concept, although we just mentioned it for the last 1.5 decades, but researchers or scientists started to think about autonomous concept in 1925, early 20th century. Now, about 100 years long, we reached a point that this dream may come true. We also experience it or see it in different countries. Now, in literature, the 6 types of autonomous vehicle automation are defined. The first one, the 0 one, then there is no automation, that everything belongs to the driver and driver decides to do everything and control everything and etc. Now we try to reach the number 5 where there is full automation. And our studies are mostly focused on the full automation concept, and the results I will present here accepts that all autonomous vehicles are full automated vehicles, but they use the roads with human drivers. So it is the near future we will expect that. Now, for more efficient use of autonomous vehicles, 5 communication types are defined in the literature. The first one is vehicle-to-vehicle, especially from autonomous vehicles to autonomous vehicle communication, vehicle-to-network, vehicle-to-infrastructure, vehicle-to-pedestrians that we can briefly discuss along the way, and vehicle-to-everything that nowadays all the researchers are trying to do something about this one. Now, I must mention that autonomous vehicle concepts are mostly researches on autonomous vehicles are mostly done by electrical or computer engineers or automotive engineers. But as civil engineers, we design roads, we design intersections. We should know the outcomes of autonomous vehicles, what they will bring us. Now, this is a graph from Whitman, one of his studies in 2022. Previous research has mentioned that we expect to see autonomous vehicles in fully functional in traffic about 2030, but recent findings have shown that we should shift it at least 10 years. Now you can see that at 2010, there is nearly no autonomous vehicles on the road expected. About 2040, about 20%, but in 2050, we should realize the effect of autonomous vehicles on roads. And by 2080, all the vehicles may be turned as autonomous vehicles. Full automated vehicles will use all the roads. Now, the potential impacts of connected and autonomous vehicles are wide-ranging. These include but are not limited to following both subject areas: safety and unplanned incidents, travel demand and car ownership, emissions, air quality and global climate change, route planning, choice and in-vehicle navigation, accessibility, travel choice and social inclusion, provision of data for network applications and strategic planning, and link capacity, junction capacity, and network service levels. They will affect in one way or another, or both it may affect positively or negatively, as we will see as we go on. Now, I would like to talk briefly about the safety concept. When fully automated vehicles arrive and start to be used in our roads, we expect less traffic accidents, especially the accidents that involve injuries or deaths. This is our expectations. Numeric sensors, lidars, and etc. are used in the design of driverless vehicles, in addition to technologies, many mathematical algorithms which are constantly developed and tested especially for the prevention of traffic accidents. For example, all newly manufactured vehicles will soon have a new system to ensure that speed limits are obeyed in Europe. Now, this is arriving. It's somehow 3 or 4 type of automation, if I'm not wrong. But from the news, we know that especially we are just more aware of Tesla. There are various accidents happened, and it shows that the autonomous vehicles should be developed or continuously developed. Reasons about the shift in about 10 years is that technologies are still in development. There are serious concerns, especially with night driving. In a webinar in day driving and driving in daylight, but during the night it increases to 6 or 7. So it's a very important concept that should be solved. So that was the reason that the participation of driverless vehicles in traffic will be achieved later than 2020. Now, I would like to give, as civil engineers, we should, as I mentioned before, we should know about what will be the capacity. Communication systems like vehicle-to-vehicle, vehicle-to-infrastructure, or vehicle-to-everything may provide significant increase in capacity and improvement in performance of the highway network. However, in case of using roads with human drivers, safety will come to the fore and the expected capacity may not be reached. And in some cases, it may even lead to decreasing capacity. You will see that there is a threshold between safety and high capacity. So we should decide how to use the autonomous vehicles. Now, we made 3 different studies on different types of transportation facilities. The first one is the uninterrupted flow, the effect of the autonomous vehicles on uninterrupted flow, which we define as the freeways or intercity highways. And there are very limited number of at-rate intersections or no at-rate intersections. We call it as an uninterrupted flow. And so, as a recent study in the United States, we can see that the capacity of a lane, may, I cannot use it with either both hands, I cannot use it, but we may expect a capacity of 3,500 vehicles per hour per lane, which is a very high value. We can compare it when we talk in Turkey, we can talk about a lane capacity. Saturated lane value is about 2,200 or 2,500 vehicles per hour. It is somehow a 1,000 vehicle increase that we may expect. In the United States, 9 kinds of driving behavior defined for autonomous vehicles. 9 different driver behaviors are defined for autonomous vehicles that autonomous vehicles can use. The first one is the most cautious behavior. Very slow, very cautious, gives follows the leading vehicle with a long distance and with slower speeds. And the ninth one is the most assertive behavior, but we can just say it's an aggressive behavior of autonomous vehicles. The fifth one is the default parameter, which is very close to the human behavior. Humans which use roads, obey all the rules, and drives, I can say, perfectly, we can say, if there is a person, something like that. Now, first of all, we may define the headway value, change in headway values. You can see that this graph shows the headway values of human drivers, and the other all gives the relation between autonomous vehicles. You can see that the range of headway values in the range of human drivers is very high. But for autonomous vehicles, they are very close. So we can say that the autonomous vehicles are more drive deterministically. So we can control it. So we may use autonomous vehicles to control the traffic might be more efficient. Now, our studies have shown that when we use the first line shows the most cautious driving ability of autonomous vehicles. You can see the penetration rates in the first row of the table, and for the last row of the table, we can see that the assertive driving behavior of autonomous vehicles. For the first, second, and third driving behaviors of autonomous vehicles, you can see that there is a decrease in capacity of the roads. This is because you tell the autonomous vehicles that you should drive more slowly, you should give more space with the leading vehicle, so you can use a more safe driving. You can make a more safe driving. This is an important tool. We understand from here that if we use a vehicle infrastructure system, communication system, you can tell all the autonomous vehicles that we try to control the speed of the road. We try to control the dangerous driving of other human drivers. So you should use the first, second, or third option. Just follow this driving behavior. And although we may have a decreasing capacity, we may have a safer road. So we can decrease the accidents also. And what will be the expected, the highest capacity that we can expect from autonomous vehicles? As you have seen that 3,500 vehicles per hour is expected in the United States. From the graphic, you can see that our research has shown that it's a possibility when we have got a 75% of market penetration of autonomous vehicles in the system, we may reach that capacity, but our calculations have shown that we can expect 4,500 vehicles per hour per lane. It's a very high capacity. It has got other concerns. You can pass from a first section 4,500 vehicles, and the problem is where do you distribute them? It is the main problem, one of the main problems. So, but this is a limit that we can use in our future studies. The second facility that we searched in our studies, the effect of autonomous vehicles on capacity of signalized intersections. The first time I met with autonomous vehicles concept, I saw a simulation that there was no traffic signals and all the vehicles are autonomous and they drive like you would expect an accident instantly, but they use the intersection very well. So I think that we should understand the concept of unsynchronized intersection. What should we expect from it? Now, for unsynchronized intersections, one of the most important parameters is the critical gap of drivers on the minor road that should try to enter the main roads. You can see that the middle one, this one, is the critical probability distribution of critical gaps of human drivers. This one, probability distribution of critical gaps of driver behavior 1, and these are the driver behavior 5 and driver behavior 9 critical gap values. We made an algorithm, we prepared an algorithm to define the driver behaviors, to know the critical gaps of autonomous vehicles, and we see that, for example, when all the vehicles on the major road and in the minor road, when all the vehicles decide to use the most assertive driving behavior, we can see that as the number of vehicles on the main road increases, for example, 3,500, we see a decrease in capacity when the penetration of autonomous vehicles increases. So, but when we accept a cooperative manner, for example, not all the autonomous vehicles use most assertive behavior, but some of them use cautious behavior, some of them use like a normal human driver. We see an increase in capacity, a significant increase in capacity. So we by now know that autonomous vehicles cannot use a constant driver behavior. According to the traffic situations, according to the nature of the leading vehicle, autonomous vehicles should choose or may choose a different driving behavior to improve safety and to have a better capacity of intersections. And this is the service delay, which is an important delay for minor vehicles. The green ones show the delays of when there is no autonomous vehicles on the road, but the blue and the red ones show the penetration rates of different penetrations of autonomous vehicles. You can see that there is a significant decrease in delay also at the unsynchronized intersections. The most common accurate intersection management system nowadays is the signalized intersections. This is studied in the United States. As in the middle, we can see that when there is no autonomous vehicle uses the road, the delay values are at the middle of all other calculations. But for very cautious drivers, the delay is higher. For assertive drivers, the delay decreases. But you can see that we may not expect every time an increase in capacity, but we may expect safety. We should expect safety. This is the main reason. Now, this is a graph from one of my articles. This is a graph that shows when we have autonomous vehicles, but there is no communication. Not with other vehicles, not with the system, but all autonomous vehicles use their algorithms. We may expect a decrease about 10 seconds in capacity in delay also. So it may provide some improvements in the performance of signalized intersections. Now, this is interesting finding. Now, the comparison of human drivers and autonomous vehicles for acceleration and deceleration of vehicles. We have the information about 16 human drivers, their acceleration and deceleration properties at a signalized intersection, a traffic signal. You can see that the blue and the purple, these are the defined autonomous vehicles, the upper and the lower limits of acceleration and deceleration values. For deceleration, their behavior are very close to human drivers, but for acceleration, they accelerate more slowly. It takes time, but human drivers accelerate very more rapidly. So this is another important result that we obtained in our studies. I don't know if you know, in Australia, Rahmi Akçi, a researcher called Rahmi Akçi, a very important traffic engineer, has defined 5 types of driver behavior. The first one is the most aggressive one, and the 5th one is the most very slow driver behavior. The 3rd one is a normal driver, you can say that. From the graph, you can see that when drivers are very aggressive or aggressive, the yellow one shows the aggressive driver behavior. It's somehow these concepts are confused, but the yellow and blue one, the cross blue one, defines the aggressive or very aggressive driver behavior. You can see that there is an increase in delay when the market penetration of autonomous vehicles increase. But for normal vehicles, the green one, we obtain the most improvements when all the human drivers also obey the driving rules. So this is another concept that we can use to regulate the traffic and to increase the safety and to decrease the effect of aggressive drivers. Although the models show that when driver aggressiveness increases, the capacity increases and delay decreases, but the probability of traffic accidents increase. So our first concept should be to decrease traffic accidents. Now, what are the threats of autonomous vehicles? This is the main thing that all the researchers around the world are afraid of. In increasing car ownership, not only increasing car ownership, the increase in the usage of passenger cars. For example, you go to your work with your autonomous vehicle, and you can tell your autonomous vehicle that it should return to the house and park itself, and then at the evening, you can tell it also to come and pick you up and then return back to your house. You may not use a public transportation system. This is the main threat of autonomous vehicles that we should know, and this is why the concept of autonomous vehicles should be very well understood by transportation planners. And another concept is enforcement of regarding pedestrians. In most cases, in some researchers, they say that variable systems you should carry a variable code that autonomous vehicles will detect you. I believe that as you pay a lot of money to improve autonomous vehicles, the autonomous vehicle should see you, even though you do not have a cell phone in your hand. Okay? Because it's for the main concept is to provide safety. So as pedestrians, we should not just adjust ourselves for the autonomous vehicles. Autonomous vehicles should adjust themselves for people. It is my opinion, of course. And what are the opportunities? If we can increase capacity with driverless vehicles, we can provide less space for the road and more space for pedestrians and bicycles. So more green and for more opportunities for bicycles and pedestrians, and more green cities we may obtain. We can increase access opportunities for the elderly and disabled people. Of course, it should be planned very well also. We can use it for public transport in small settlements or campuses, which are being done in Europe. And I think in some technical university campus in Maslak, there are some studies on that. We can reduce the environmental impacts of transportation, reduce the capacity increase, reduce fuel consumption, emissions of air polluting gases due to delays. Driverless vehicles will be largely electric or hybrid. It's a positive result for the environment, but we should not forget that even electric vehicles pollute the environment. These are passenger cars also. This is a threat for also. And this shows that an optimization needs to be made when we try to use autonomous vehicles, when we accept autonomous vehicles in our lives. Now, autonomous vehicles are the main concept today, but in near future, we will face flying cars. It is not very far away. I think, if I am not wrong, a flying car is accepted to be used in traffic in some European countries, and some of them are on sale, and some of them are being developed. For example, Boeing was working about 3 prototypes of flying vehicles. And today you can see read some news about delivering goods by using drones or etc. So urban air planning is one of the main concepts that we will face in near future. And I'm very afraid to see a city like this. You see, we may not, if we do not control these developments, we may observe some traffic congestion not only at ground level but in different levels of cities because of flying vehicles. It's a scene from the movie Fifth Element, if you remember, if you have watched it also. Thank you for listening, for your patience.
Thank you, Serhan Hocam, for the presentation. I think we can take questions if now.
If there are questions,
because we still have time. If you have any questions, yeah. Microphone, please.
So I think autonomous vehicles cannot be seen as a single solution for the transport system, but for smart cities or for smart living, the use of individual transportation will have to be rethought.
Yes. Yes,
because otherwise we are drowned in immense amount of personal cars. So there will be some changes needed as well as transportation of goods.
So I definitely agree with you. Definitely agree with you. You see, autonomous public transportation systems should be taken into consideration of in city transportation. When we talk about autonomous vehicles, it's a very big threat for us, for Europe, for Turkey, especially for Turkey, because in Europe you may control it. You put the laws first and then you control it. But in Turkey, you just buy the car. So that is the problem.
So yeah, and one thing I think with the cars now available, they are not autonomous at the moment.
Yes.
So you mentioned Tesla, it's level 3.
Yes, yes, I know.
So it's you have to involve.
Yeah.
I know it. I drive one. So I must tell you, it's comfortable driving. It's a some minutes later, get out of the car. Yes. But I think there will be overall solutions, and not only a solution for public for individual transport.
Yes, yes. Thank you. You see that I am afraid that in Turkey we just buy the car. That is the threat for us. So we should know what we expect, how to use it. We should plan it first. Yes, yes. Yes. Yes, I understand. Thank you.
Thank you for a very interesting presentation. I mean, as you said, even you will have some clear picture by say 2050 how they are going to perform on the roads with automatic vehicles. I mean, what is your thoughts about these vehicles, particularly in some part of the world which are very populated and heavily congested, for example, like India, China, Brazil, Egypt, Indonesia? How they are going to be successful, if at all?
It's a very hard question to answer because I haven't experienced that type of traffic. I just watched 3 videos about those, but the first video, the simulation I had watched, it was very close to that type of driving in India or something like that. But I think that if we use autonomous vehicles, it may provide you, if used properly, may provide you to regulate the traffic and control the traffic and force human drivers to obey the rules. But in Turkey also, we sometimes come across some problems. We see that only a human driver can solve. So in near future, I'm not sure that autonomous vehicle should drive along all the roads around the world by itself. Intervention of that driver should be needed for a long time. So to control the vehicle, to decide when the vehicle cannot decide. As I say, it's although the market penetration rate is expected by 2040s, but still there should be important developments along the way. You see, we talk about the car following model. It was a very simple one, the Forbes model, but today some developers use intelligent driver model that was most recently defined in the literature, which is more effective than we try to use in our studies also. But they should also be improved. And as I mentioned that you should not expect one type of driving from autonomous vehicles. Autonomous vehicles should decide dynamically what they should do during the road. So it is not always the research should continue, not only for electric engineers or not automotive engineers, but also from civil engineers' point of view. If I can give you an answer that you wanted from me or not, I'm not sure, but it is my opinion about the usage of autonomous vehicles in the world.
Thank you so much.
You're welcome. If you want to ask questions, we can also talk in the cover break also.
Any other questions?
So thank you very much for this very interesting presentation. I'm really curious about the results you showed regarding if all autonomous vehicles on the road are of this particular aggressiveness level or that particular aggressiveness level, but presumably if this kind of setting will be available, then it will involve a psychological components, because just like some drivers are more aggressive, some drivers are, some passengers will want their cars to be safer, some others will want it to be faster. So I'm guessing there will be distributions of aggressiveness. So I'm just curious if there are any
one of my PhD students is working on this. One of my PhD students is working on that. One of the last grants was from her natural science thesis, but we try to improve that because we try to see the effect of autonomous vehicles with different types of drivers. You see in Turkey, we see that the 35% of drivers are aggressive and do not obey the rules, and it's a very high rate. And on the other hand, there are some issues that should be solved along the way. For example, if when an accident happens, who is responsible for it? The manufacturers, the driver, the owners, or the people who write the algorithm or something like that? We do not know anything about it. It's a process, and also some things are, for example, the research in Europe, they say that they do not know how pedestrians or the drivers react to full autonomous vehicles, and there is no driver in the car, or is no person in the car. How can we solve this psychological problem? So perhaps we can just darken the windows and nobody sees inside the car, etc., etc. And some studies are being conducted on that also. So there is a very long way in our goal to reach this goal, of course.
Well, if you have any questions after we finish the session, then we can continue with that. I think we have certificates provided to you.
Ana konuşmacımız olan Profesör Doktor Seyhan Tanye'nin plaketini vermek üzere TMMOB İnşaat Mühendisleri Odası Sakarya Şube Başkanı Sayın Sevim Uçak sahneye geldi.
Well, we will continue with the regular presentations. The first speaker is myself, so I'll be talking about the carbon sales and problem, how we can improve it to make it more realistic. Okay, good afternoon, I guess. Good time. Today, I'll try to simplify what is this research to make sure that everyone will get something out of it as a take-home message. Okay. Here we will be discussing what is the existing carbon sales problem, how they apply it, and how we can improve it. Let me get started. When we look at the outline, we have very few topics. First, we have an introduction of what is carbon sales problem. Then we will look into the proposed approach because of the limitations. And we have a simple case study from North Cyprus. And then we have few conclusions and recommendations. All right. Here, the map that you see is actually the case study that I have from that one. If you look at the definition, we have a bunch of cities that we want to visit and come back to our origin location. And what is the shortest total distance or time that we can have by ordering these cities in a certain fashion? Okay, so that's a very simple explanation of the TSD. And of course, like many methodologies, we have an objective function here, and it is either minimizing the total travel distance or total travel time. And in order to do that, of course, we need distances between the pairs of the cities or origin and destination and between destinations. And that distances will form the distance matrix. The next step is to create combinations. So we have to try different ordering of the cities, the order of visit time. And that is factorial of the number of cities. So if we have 5 cities, then we are talking about 120 combinations. So do you think we can do it in a short time by hand? Maybe. But with computer, I'm going to show you we can do it in like 0.2 seconds or less than that, depending on how is our approach. And For each combination, we obtain the total distance, and we pick up the one that satisfies the objective function. Well, most of the time, if you look at the internet, if you search in Google or other search engines, you get the distance matrix representation that is direct distance. That means it's like bird's flight, or I can talk about like crow's flight, which is very famous in Cyprus, especially in Paris. Okay. And the Euclidean distance is a direct distance, but Earth is a sphere, so there's a modification to it, other side. But is that enough? We are going to see it. Okay. And they do provide some advantages that I didn't mention yet. It's fast, but is it accurate? Well, unfortunately, there is some issues if we deal within a city or in small places like Cyprus. We will have some errors in the distances because of the street network is not represented. So let's look at the proposed approach. In the proposed approach, we decide to use the existing road network and also have a automated data extraction in real time. Okay, and in order to do that, we decide to use OpenStreetMap. I don't know how many of you are familiar with OpenStreetMap. It is freely available. It's the largest volunteer supported system, and there's a tool, OSIO, open source routing machine. It's very fast. It is written in C++, so you can extract, you can request the distances by giving the pairs of the electric and longitude values. And in order to contain everything in an algorithm, we use Python for that purpose. Now let's try to look at the case study. So here I assume that the union of the Chamber of engineering chambers and the architects, let's say they have to visit and deliver a new building code to certain municipalities. And I picked up only 5 of them. Of course, we can solve it for 20 municipalities easily. It takes a little bit more time. So we have to visit Lefkoşa, Gaziantep, and come back to the Union building in Çağlayan neighborhood. So here again, our objective function is to minimize the total travel time. And on the left hand side, you see the coordinates. The first one is the Union building's coordinates. The other ones are the respective municipalities. And here we have the map of it. If you look at the direct distances, you are seeing a symmetric matrix. It is both directions are the same because we are measuring it as a direct distance, like the crow's flight. Okay, a bird is flying. So nothing is wrong with here. The values here are in meters. And if you use your OpenStreetMap with OSRM and make a request, we get a different set of values. And if you notice that this is not a symmetric matrix anymore, because some roads are one way and the round trip may not be happening on the same street. Okay. Well, After the analysis, we see a slightly different order of the cities. The one on the left-hand side is the direct distance. By using the direct distance matrix, we have L that is almost 49 kilometers shorter than the actual. We are just talking about only 5 places to visit, and we have such a big error. And before coming here, I checked this order values by looking at here, taking the values, and the first one, the one on this one, if we use the road network, it will be 42 meters longer. Only 42 meters, but the objective function is the minimum total distance. So that's why the other one is being selected. All right, let's go to the conclusions. Today we talk about the transportation engineering, but in civil engineering you can apply the same to many areas. Maybe in a factory or the construction companies, they may benefit from it. So this is a very suitable tool for that purpose. And we propose to use the actual street network, which is more accurate. And as long as you have internet, you can in real time get the results immediately. If we reduce the total time, travel distance or time, the energy consumption and time consumption will be reduced. So that is an advantage if you think about many organizations, such as the logistic companies, use it. And we can apply it to the other disciplines. And of course, it's an open source, but there's no licensing fee. All right. Thank you. Well, we have 3 more presenters in this session, and I'm going to invite them first. Khalifa Galuz, he will talk about geopolymer modified asphalt binder. Thank you.
Hello and good afternoon, everyone. Welcome to my presentation. My name is Khalifa Salem. I'm a PhD student at New York University under Civil Engineering Department. Today, I'm here with my supervisor, Associate Dr. Shagan. The title that I'm going to present is Experimental Evaluation of Binders Properties with 2 materials that are geopolymer and acrylates styrene acrylation. We actually use abbreviation ASA as abbreviation for this big words. Obviously, I divided the presentation into 6 main parts. First of all, I will give us a brief introduction, related to the asphalt pavement and why we need the modifiers to add it to the asphalt binder. Then we will look at the materials that we have already used in this study. After that, the sample prepared. Next, I will talk about the experimental test process. Then something that we have found, it will be discussed. And finally, in a nutshell, I will conclude the presentation with crucial points that we have already found. Shall we start with this introduction? As we know, the asphalt pavement is used commonly in roads and urban streets, and this growing up to be the largest paving surface in the world. However, nowadays many roads around the world are suffering and affected by environmental challenges such as increased road traffic, aging issues, changeable temperature. All of these phenomena lead to cracks and rotting. Accordingly, numerous studies have been conducted to produce or establish a new material to be avoided these issues. So in this study, we try to evaluate new materials which are geopolymer and ASA related to the asphalt binder. The next part in my presentation is material. We used 60-70 penetration grade as asphalt binder. Here, this table shows us the physical properties of this asphalt binder, and these properties conducted by according to American Society for Testing and Materials. The sample preparations, having asphalt binder heated and complete liquid, we added both materials with different concentrations, namely 3, 5, and 7% by the weight of the binder cell. The geopolymer blended was mixed for 90 minutes with 1000 RPM speed with 150 temperature, while the ASA mixed for 90 minutes at temperature 170 degree. Here we have the experimental work. Actually, we evaluated these materials with rheological and physical properties. For the physical evaluation, we used two tests, which are softening point test and viscosity test. For the rheological evaluation, we used dynamic shear rheometer to test the rotting and failure temperature. The result discussion, the first result we have here is the soft point test. So it's clear that the modifiers has ability to resist temperature variation. For the added ASA and geopolymer improved and was increasing up to 20% compared to the base salt, as we see here in this picture, in this figure. For the impact of the viscosity, all values are limited to the specification we followed the super requirements, which recommended that wall values should be less than 3 Pascal second. For rating parameter, we should know that the lowest value of rating, the lowest permanent deformation resistance, and vice versa. So according to this statement and these current results, the best value we have is 5% for both modifications. For ASA, we have 142% improved compared with the zero concentration. The last one for rheological evaluation is the failure temperature. As we see here, the best concentration was 5%, with 13% for ASA modifiers and 4% with GEO polymer modified compared with base salt binder. The conclusion, first conclusion is the study was conducted to evaluate physical and rheological properties of modifiers, ASA and geopolymer modifiers. The second conclusion is the results demonstrate that ASA has the ability to be one of the best ways to improve the self-binder, while the addition of geopolymer addition has slightly improved. The result shows that the ASA polymer has the ability to resist darting and temperature failure. We can consider that 5% concentration could be the optimum modified content of the salt binder. Thank you very much.
Thank you, Carlos. I would like to invite you to come over here, so at the end, if you have questions, we will provide some answers. Thank you. And now we have Associate Professor Shaban Ali. He will share with us their research about micro-bauxite powder effect on mechanical properties of asphalt mixture. Thank you.
Assalamu alaikum, good afternoon. My name is Shaban Ali. I'm an associate professor at the university. With cooperation of University UTH and University of Hussein, Malaysia, we have one the PhD student over there. Done this study, which is the impact of micro. It's a bauxite, but we divided to two parts, nano and micro, to try to see the effect on that structure. So the outline here, we're just going to a slight introduction and asphalt modifiers and the problems that we have. We go to materialism method with a simulation here. There's no end. There's a discussion and conclusion. Everyone knows that recent roads need to show a better performance than in the past because we have high density or high density traffic volumes. Also, this results in increase of the load on the highways. With severe weather conditions, which represent precipitation, moisture, and high and low temperatures, it will cause serious structural damage on our highways, as you can see in the to mitigate, to eliminate, I'm sorry, you cannot eliminate it. So to mitigate such issues, we use some modifiers. We move to use some modifiers such as polymers in order to improve the asphalt. As Mr. Khalifa mentioned previously that he used ASA and the polymer to improve as well. So, but after a while, we find that we have a problem with the polymers as well. What's the problem? The problem that is phase segregation or phase separation. It takes a care because of the different in density between the polymers and the asphalt. So, moreover, they start to use nanomaterials to mitigate these issues. They start to further to use nanotechnology. The most various polymers that they use, SPS and EVA actually, and ASA. Then we have like nanosilica, nanoclay, we use it to improve the asphalt properties. But what I want to say here, those are chemical materials, which it's not eco-friendly for the environment, right? So what we are trying to have is a clean production. A clean production, we went to the coastal, the idea is coming from us. We went to the coastal, we get the soil. Beside the coastal, we get this type of soil, as you can see from here. And we try to get a nano and micro particle from this soil to modify the asphalt. Will we use the local material? This is the gradation of the samples that we use to mix the asphalt, of aggregate soil to mix the asphalt. And we use 80-100 penetration grade asphalt. The soil that we send it to the lab, then they divide it, they give us, we check using TEM, transition of, I don't know the full name, that's under microscopy. We use it to check is the particle become nano or not. Yes, we find out the factor was right. They supply us with a nano material. They said they were able to produce a nano material. Here, I just choose two of our tests that we have done. We have what we call that resilient modulus, and we have dynamic creep. Two different tests. This is the procedure that how we did this. Temperature was 25 and 40, and 40 for the dynamic creep. We simulate the weather as well, weather condition. We simulated. In the study, we just deal with short-term aging. You know, there's an argument between what's the short-term aging represent. Is it like 3 years? Is it, for me, the short-term aging is represent the mixing period, transport period, and construction period, around 5 hours. So we try to simulate it. We put the samples, as you can see here, in the lab for 5 days under a temperature of 85 Celsius for 5 days. Then we said that the condition is short-term aging condition. So this is the result of our studies. As we can see here, unaged samples, we just mix that salt with the modifiers and we get the result. We can see that here 5% of micro and 5% of nanoparticles. As I mentioned, we use two particles. We can see the best performance here, as you can see. Aging, short-term aging is represents the stiffness, oxidation of the samples, right? There, the aging index, we try to see if these materials are anti-aging or not. So, according to the aging index, we find out it's anti-aging as well. This one, as I mentioned previously, we are looking for clean production. So, it's soil. It's soil. We use soil to modify that soil. We can see that the improvement, I think, up to for 40% was up to 26 for micro and 33 for nanoparticles, which have a good improvement of resilient models. If we move further, that we can see that the dynamic creep as well, the material is still an anti-aging material according to the aging index over there. 5% of micro and 5% of nanoparticles are the best modifier contained here. We can see from this graph that, as we mentioned, the lowest permanent deformation is the best. We can see here 5% of nanomodified, or nanomodifiers, or nanoparticles is the best. While if you realize, if you have a deep look, you can see that nano was better than micro in terms of, you can see here, over here, this is the base as well, right? And the other one is 3%, I think, 3% of micro. If you go down here, you can see 3% of nano, which is the best for permanent deformation. Maybe it might be due to the dispersion of material. You know, if it's nano, yes, you are going to face another issue, which agglomeration between the particles, but we can see here maybe the dispersion was better. That's why micro, it's the same material, but nano is better than the micro. The conclusion that I just want to say that since it's clean production, the improvement, as you can see here, for 40 Celsius degree is up to 33, and 25 or 26, we can say around 26 for nano particles. Sorry, for micro, and 33 for nanoparticle. Also, it will consider a good material to modify that as well. This is all, and the full study actually you can later on if we send it to the conference proceeding or so on. Thank you very much for your time, and that's all from me. Thank you.
Invite you over here. And so, well, our last presenter is from the Cyprus International University, Mr. Dindar. We will be talking about the landslide susceptibility determination by using GIS and machine learning algorithms. Thanks a lot. Please.
Welcome, board. Thank you for coming to my presentation. Today we are going to present the study, the determination of landslide susceptibility based on GIS methods with MSW data with machine learning algorithms. I am Dr. Dindar from Cyprus International University, and we are making this study together with Dr. Can Alkalde from Sparta University. And here is the introduction. You know, the landslide is a natural disaster, a natural phenomenon that is a movement of gravitational mass from the stripe of soil and downward slope. In Cyprus, we have many of events for landslides, and the fact that the landslides cause serious material damage, especially to our roads, and in southwest of the Cyprus, we have many samples to see the landslide regions, especially Paphos state. And in Cyprus, increasing landslide activity occurs in past and present, and land use planning mistakes such as road concession and housing. So, I'm continuing the introduction. I want to bore you with I think the lunchtime is coming up. So, for successful urban planning strategy, we need to determine the possible places for landslide potentials, and many researchers and governments are making some kind of studies to detect the landslide potential before the landsliding. So we use some machine learning algorithms to detect the landslide places, and we use the historical background with the two different techniques of machine learning algorithms like support vector mechanism and random forest approaches. So objectives, we have three main objectives in here to determine the most effective methods that discover the potential. If in situ measurements like MASW methods, is it accurate, or historical records, historical events. And second one, the comparing accuracy and precision of random forest with support vector machine learning system to perceive that the algorithm in determining landslide susceptibility in semi-arid regions, and to identify the regions where landslide susceptibility is relatively high,
And our study area is Hygiene Mountains. The main motivation of us is to create a good model for detecting the machine learning system and to see the topsoil stability properties with different kind of approaches. So Cyprus has three main geology. I'm going to summarize it. These tectonical units are mainly like Hygiene Mountains, Rhodos ophiolites, and Mammalia complex. And these regions tend to be Mountains and the Kyrenia zone or the Peshwamak zone, which is a member of Alpine and Himalayan region. And it's chosen as the study of this project. And Permian and Upper Cretaceous age marl, limestones, granites, and marbles are commonly deposited in Kyrenia zone at the north of the island. So here is the methodology. We made some measurements using geophysical techniques. It's a kind of seismic method, it's an active method that we use, multi-channel analysis of surface waves. Our aim to detect the surface waves at the surface, at the shallow surface of the subsurface. So we are going to convert the Rayleigh waves to shear wave velocities. This is a formula. And in that, we are getting the layer velocity model from the underground. Here is the illustration of the MASW method. We are using a sledgehammer for creating impulsive power and seismograph detecting the travel time of the seismic waves. A computer is recording the measurements, and the profile length is approximately 55 meters for each profiles. We made 30 profiles at the station measurements at the Kyrenia Mountains sector. And the method, we use random forest to make the input, data input. And it was first suggested by Bryman in 2001 as a tree-based composite learning algorithm. The other system that we use for machine learning is support vector machine learning system. Is administered by machine learning modules that might be used for classification, regression, and anomaly detection. And here is the geology of the North Cyprus. There are several units or formations. At the Nicosia section, you can see Nicosia formation at the north of the mountains. There is alluviums at the north and the south side. So the Lapetos formation is going to take place at there. And Ardana formation, which is a highly risky for landslide potential, is at the east side of the Kyrenia. And there is also Katipia formation as a main bedrock of the Cyprus, and the formation and the Limassol formation at the southern sides, and also Todos ophiolite at the west-south side of the Cyprus. And here is the data, input data for our system. First, we created the map for slope, and the highest value for this slope is 70%. And you can see the mountains are taking 70% value at the north side. The other data for GIS is altitude, which is elevation. And the highest elevation for North Cyprus is 1,204 meters. And you are seeing the states of the North Cyprus, like Girne, Iskele, which is the other main city, Como, Famagusta at the east side, and the capital at the center of island. And expect another geographical data input for materializing the data input, and we can see their colors parameters. And the other map that we created is normalized difference vegetation index. And we are classifying the system with high or low for each study area location. And curvature is another terminology for geographic information system. And
we have 1.5 minutes.
Yes, so please, I'm finishing. So I'm going to show you the results of the project. Here is the one-dimensional shear velocity against the depth, the desired depth. We reached the penetration depth like 30 meters for each profile measurement. So in here you can see the gray color. So this gray color represents the penetration depth of the investigations. I put just 2 of the images, but we made 30 different stations. We can put it to the paper after this presentation. So we use size imager program to evaluate the dispersion curves and to make the inversion to calculate the shear velocities against the deeper zones. So for conclusion, support vector machine with MASW method, the accuracy of it is 72%. The random forest with MASW method is 68%. And we calculated support vector machine with historical background with 54, which is very low, and random forest with historical landslide, which is 51%. So I'm going to go to the conclusion. It has been determined that these method sets, data sets, are most effective methods that we are using with historical data. And the highest accuracy rate was calculated for the data set trained on the basis of geographic information system with MASW method, SVM, which is support vector machine learning system. And we calculated the 72%. And it was determined that the terrace deposits in the north and the south of the limestone, at the summit of the Kyrenia Mountains, are the most sensitive areas for landslide, depends on the machine algorithms. And the evaluations of the landslide susceptibility in the study area, the support vector machine algorithm showed more accurate results than random forest method. Thank you for your questions.
Thanks a lot. Well, I would like to ask the audience, do you have any questions or do you have any? Please, the microphone.
Slides. Did you calibrate your work also with actual slope slides, so that you can say, because I come from a mountain area, and the result is for me, yeah, when we would have to.
So it will be
put all the people out of the mountains. So that's a question for me. If you calibrate it.
Thank you. We are collaborating this study with geographical member from Süleyman Demirel University, and we used seismic active active method data to produce this kind of maps, and we used GIS, which is Geographical Information System too. So the best method is to make a look for literature to historical background. So we detected 10 different stations which occurred landslide in North Cyprus. And with our studies, yes, it's a plenty of data set, and we need to improve it. We will improve it by project, but and we will increase the number of data in the mountains. And as you know, the machine learning algorithm system, machine learning algorithm system is a new system for computer programs. So it's getting improved day by day. So we used to put the data from geophysical instrumentations. The next step will be maybe geological index assessment with geophysical data set, and it will be more accurate for determining the subsurface. I can hear you.
So we have hazard maps for all over the country. So perhaps it's interesting also for you to check that system.
But we have more in Cyprus, but it's the first study. Of course, I can take it for you. Yeah. Yes, sure. You can make a collaboration. Thank you.
I'm curious about, so you mentioned like 10 slides or so that you have.
In literature, yeah. We determined 10 different points.
Okay, so did you consider or did you do a classification of those, because landslides can have, as you mentioned at the beginning, they can have many different trigger events. So sometimes the rainfall, sometimes the earthquake, sometimes the acceleration of the or other artificial means. So I'm curious or concerned about whether you can add all of those up into the same susceptibility map or susceptibility study, because with the machine learning algorithm, because ultimately the algorithms, the machine learning algorithms, don't consider or don't know about physics of the problem. So maybe if you have enough landslide examples, of course, maybe it would be categorize them so that.
Yes, we have a small island, so we have not lots of occurrence of the landslides or detections in the North Cyprus, but we know that 10 different events happened from the historical times. So we take it as a as a base of our project. Then we think that if the first layer of the subsurface is faster than the second one, because as you know that multi-channel analysis of surface-based method gives you a chance to detect the shallow lower velocity zones. So we detected these zones and we discovered that there are some places in North Cyprus which is faster than, which is the first layer, is faster than the second layer. So it means that it will be a mass movement. So when we are looking for the literature, we found the yes, our thinking, our point is successful. Then we put it together in a NCE method with support vector machine program, because in support vector machine you can use many dimensions and you can increase your data set with different layers in JS. So it's very accurate for us to detect it and to prove it with NCE method.
So out of curiosity, is there a predominant mechanism for these landslides, or more like artificially induced, or inequalities or is what?
So we can improve it, or we can
No,
discuss it.
I'm just,
We can make it in the coffee break session.
Well, thanks a lot, everyone. If you have any questions, we can do it. You can ask to the other presenters in the afternoon. The meeting is completed now. Thank you for being here for a nice presentation.
I would like to invite Dr. Arya Sadilandiri, the Chair of Nature-Inspired Solutions for Building Working Group, to present a token of appreciation to the Chair of Session, Associate Professor Dr. Mehmet Metin Kunt.
Thank you very much. We are closing the session. Our next session will start after 1 hour. So we are requiring you to be around 2:15 here to start the next session. Thank you very much.
Siz oradansın hocam, Ömer Hoca.
Hatırası kalsın hocam. Seneye kısmet.
Bir defa isteme var. Kontrol edersiniz. Tamamdır. Tamam. Sırada belki değişiklik yapabilirim. Çünkü bir online bir sorun.
Aslında benim erken olursa sevinirim.
Yeah. This guy, şirket bir yardımcı ol. This guy is responsible.
Vallahi aynen öyle. İnşallah bundan sonra olmayacak.
En azından böyle aktivitelerde
Aynen
var.
öyle.
Daha ortamlara giriyoruz. Bir kahralar başlamak.
Görüşürüz. Seni gören çok güzel.
Nasıl? Evet. Tamam. Tamam hocam. Anladım.
Durumlar ya.
Size değil. Sağ olun.
Fotoğraf çek ama. Güzel çek. Çekeceğinde bir el salla. Sen de hafif durun. Acaba şimdi geçelim. Fotoğrafımı alasın. Sülaleyi çıkartın değil. Ha ben seni çekiyorum. Sunum olan benim be şimdi. Ayağa dedim o zaman dedim. Bu taraf çektim. Artık ya. Ben yok artık. Yazı çıksın.
Hocam Allah aşkına ne kadar Flörte birer verirsen. Şimdi ayağı çekmek için 5-10 tane minimumca geçiyor. Çekiyorum. Böyle alıyor.
Bakayım hocam benim olur.
Then what happens? Açabilirim. I can open the color. No worries. Right now I wear the color. This one is okay. Last time you said, oh, me. Yung fotoğrafı.
Hoş geldiniz. No, there is the double.
Okay. We are going on. In last two sessions, session 6 and 7 is left. And this afternoon, those two sessions are related with the material, construction materials. Session 6 will be organized, will be directed by Associate Professor Dr. Ertuğrul Aydın as the chair of the session. Okay, Hocam.
Welcome to section 6. I would like to invite our Professor Rafat Sıtıgi, distinguished invited keynote speaker, to the stage to make his presentation. It's a great honor for us to see Professor Sıtıgi here and accepting our invitation. Let me briefly introduce some brief things for the Rafat Sıtıgi. Is professor, sponsored many projects and research at Tapa Institute Engineering and Technology. He has extensive teaching and research experience over 33 years. He is among top 15 academicians. Total citation of 18,000 plus, with having H index 72, have 200 plus Q1 journal papers and 80 over conference papers. Thank you, Professor.
Thank you, Victor, and very good afternoon. And it's a very challenging job to speak after lunch and more challenging for the audience so that they do not see it, So thank you, the Chamber of Civil Engineers, and for inviting me here. So honor for me, this is my first visit to North Cyprus. I have been visited almost most of the Western European countries. And I would give a special thanks to the chairman of the session who basically got me connected to the Chamber of Civil Engineers. So you deserve more credit, equal credit to the Chamber of Civil Engineers. So See, this topic is very vast, and if you really need to cover all this topic, you need at least 1 year of lecturing, 2-semester course minimum. What my presentation is going to be technical, and as well as I would like to give some message basically. Otherwise, what we are talking about. I'll go through my presentation, but I will make a background first, and then we will go through some slides. If you look at the amount of whether it's a waste generation or a municipal solid waste or industrial, huge billions and billions of tons are being produced every year. And the percentage utilization is not that sufficient what we should aim for. So when we think from the civil engineering perspective, some of these materials have applications in structural engineering or in the sense of structural materials. Some have application in geotechnical engineering, but only their usage in civil engineering is not going to be solved with their 100% utilization. But as a civil engineers, we cannot take the onus of entire, like all the utilization as such. The focus is going to be how do we do it, and in some of the materials we have very established research, and for some the research is continuing, and for some the research is yet to be done. Now, this is no. I think some problem with the elections. Can somebody help me? I'm not getting the first slide here. Okay. So I come from, like, say, it took me almost 24 hours, I must say, to reach here. This is like 330 kilometers from Delhi. So, and Professor Yusuf has given me my background, so I'm going to skip some slides. So let us come to the first slide. We have 3 types of solid waste. Solid waste from home office, industrial solid waste, we have from mines, agriculture, industry, and so the solid waste management basically, when you talk of this research, you can, for the people who are in the academics, they can publish in the healthcare, construction, building materials, they can publish in the waste management and resource conservation and recycling. So look at the waste generation. Say in 2020, for example, 2.24 billion tons total, out of which industrial solid waste like 6.7 billion tons, C&D over 10 billion tons. Even these are some of the figures which are not really accurate, because some of the countries really do not know how much C&D waste is. And agricultural waste over 6 billion tons. So, to summarize, what are the major industrial solid waste byproducts? And I'm going to focus on some of them. We have thermal power plants, all of you know coal ash, coal bottom ash, etc. And then we have certain things. So the disposal of these byproducts is becoming a very, very challenging. Maybe for a country like India with a huge land, it may not be land filling, may not be issue, but in countries like, say, most of the countries, smaller countries in Europe or in, say, North Cyprus, you have a limited land. So you cannot even think of using land for refilling purposes. You must try to find out a solution so that you can use it. So, it's lack of land space, increasing cost of land filling. I do not know what is the cost of land filling in North Cyprus or Cyprus in US used to be, 10 years back used to be like $25 per cubic meter. So there's a huge cost even for disposing it off. So I consider the utilization of industrial as an attractive alternative to disposal. So we want to, first of all, we want to reduce. So we use a lot of plastic bottles, waste glass. So reduce, reuse, recycling. That is number 1 best option. Second, waste prevention. And third, burying, burning, and shipping. Like you must have heard the news. Some of these waste from Australia comes and dumps on the ports of China and India countries. Okay. So, the problem is this. So these are some of the listing of the byproducts you have. I'm not going to speak it. Out of this, some have established research. You know what are the final conclusions. For some, the research is still going on, and for some, the research is still to take place to reach to a solid conclusions. For example, waste glass. For example, I'm going to cover some of them. The problem which bothers a full-scale utilization of waste glass is its ASR, alkali silicon reaction. When we are able to fully solve it, we have solutions. Once we are able to fully solve it, this is going to be a wonderful material, either a cement replacement or a sand replacement, etc. So some of them, and out of these, I'm going to cover 2-3 to give you some of the scientific results, and then send a message. What is going to be there? And before I do here, most of the byproducts I am going to cover are going as a replacement of fine aggregate. My research is spread all over use of any materials as replacement of cement, fine aggregate, but for the last 10-15 years, the major focus has been on the utilization of byproducts as a sand replacement. The reason is why, my argument is, we can produce cement, but we cannot generate or produce fine aggregates. So, and most of these industrial byproducts, some of them are listed, can be very effectively used as a fine aggregate replacement. So I'm going to cover 3 here. One is going to be coal bottom ash, the other is going to be foundry sand, and the third is going to be waste glass. And maybe all of you are aware of the research, but I want to give you some idea about what I'm going to talk about it. Say you made a control concrete or the reference concrete, say 50 megapascal, for example. Some concrete you made. Then we made certain replacement, foundry sand, coal bottom ash, etc. And the value of the compressive strength has come down to say 25 megapascal. We as a civil engineer, I do not know the mindset of the people in the North Cyprus, but generally, see, compressive strength is one of the most important from which we define the concrete basically. So people say the strength has decreased by 30%, 40%, or increased by this much percentage. So we always talk in terms of percentage. And even if I say some strength has decreased, has come down to 10 megapascal, 15 megapascal, or 20 megapascal, that still is useful. The reason is we have a misconception that when we talk of concrete, our mindset only goes to a structural concrete. The concrete which you are going to use in the high-rise building, structural concrete. Like in India, we use minimum 20 megapascal concrete. I don't know what is in Cyprus, I'm still maybe minimum 20 or 25 megapascal. But the concrete which you use for making paving blocks, stones, like when you walk to the say, restaurant, you have paving blocks. That doesn't require 20 megapascal or 25 megapascal or 15 megapascal. Even by utilizing such materials, even if the concrete strength is low, and we are able to 10-15% 10-15 megapascal strength, we are able to utilize the byproducts. The focus is you should not worry about how much reduction. The focus is where we can use that concrete. So let me I think it doesn't like my presentation. Something.
Yes.
Okay. Start working. this will give you some idea of how much waste is generated. And percentage utilization is, some of the data is available, some is not, but it gives you like how much scrap, tire, coal combustion byproducts is all generated. And this presentation is with the organizers, those who are interested, and if they allow it, you can always have it. So, how do I do? There was an economist, Adam Smith, he said, every process is immortal. It never loses its entirety. And this kind of research, we are also talking of kind of a circular economy. Even if the glass bottle is, you have thrown it, it's again going to be used. So kind of a circular economy. So these are 3-4 benefits. Environmental benefits you have if you use these byproducts, economic benefit, and the product benefit. Economic benefit, you save the cost of fine aggregate cement depending upon what you use. So these 3 I am going to cover, and if the chairman gives me a few more extra minutes, so I will be grateful. So this coal combustion, we have 3: fly ash, bottom ash, and boiler slag. I am not going to talk about fly ash because every literature is there that maybe thousands of papers are there. I am going to talk about coal bottom ash. This is the fly ash generation. Look at the in India, 97 million tons, we have 120 million tons. So this is the situation. So actually, the problem with the coal bottom ash, why did I choose this? It is hollow inside part. It reduces the workability. So not many people wanted to use it, but as I said, if this much quantity, I will show you this table. Look at it. By 2030, it is going to be 600 million tons only produced in India, fly ash. If you assume 20%, I'm talking from the Indian perspective, and then you can go for a global perspective. Coal bottom ash is generally around 15 to 20%. So 120 million tons of this is going to be used. So it's difficult to use in concrete. So you need to design a concrete mix. So we have 2 options basically. The point which I want to convey a message as such. If you simply say it's difficult to use in the concrete, so run away from here. Let it lie like this. Let it spoil the environment. Let it spoil the land, water table, etc. Or work hard to find out its solutions. So this is my approach for any of the byproducts. It may be harder, but the time has come. We all must focus on finding out from the civil engineering point of view the possible usage. See, we cannot use all, but we can certainly create. And I will show you some results to justify it. I'll come to the directly. This is the table you have, like water absorption, calcium oxide values are very erratic because it depends. You're talking of class C fly ash or class F source or class C source. A lot of variations. The particle size are crystalline in nature. They are porous. So many people do not try to use it. We started this research almost 8-9 years back, and through one of the PhD students. So these are the irregular particles, so your workability also gets affected. So people don't want to touch it as such. But my thing is, any material, you must find out the solution. May not be a structural concrete, maybe on lean concrete or a low-grade concrete. Okay, let me come to this. Say, for example, this slum. I told my student, replace all up to 100% finally. Let us see what happens. Say, unknown territory. And this what is to be done for any material to be used. Look, see, slum goes down, So remember this slide. When we talk of concrete research, basically, let me put it this way, we should not judge the suitability of concrete only by one of the properties. One of the properties means I'm talking of fresh properties, strength properties, and durability properties. We need to take into account in totality all the 3 parameters. Because I'm going to show you a slide of compressive strength. If you only look at the compressive, this is Siddiq. Okay, this is another, he's a professor in England, some of you must be knowing, very famous researcher. And here you'll find very contrasting results in coal bottom ash. Because particle is porous, particle is crystalline, hollow, so what type of particle size you have used. But generally the workability is going to decrease. This is a result I am purposely showing you that you may also get some type of other results. But generally workability is going to. Now look at this compressive strength. Don't forget the slump. Look at this compressive strength. Look at the 28 days strength. If you look at this graph, you will feel on the cloud 9, top of the world. He said, even with 100% I am getting how much? Even with 28 days strength, I am getting around 35 megapascals. Even with 100% replacement. Any field engineers will say, wow, nice, 35 I am getting it. But for a structural concrete, you also need to have workability. Please remember, you also need to have work. This is the point I am trying to highlight. You need to see three properties in together. You only look at this is misleading. You need to see, then you have to see what slump, which percentage gives you a workable slump. If you're looking for a structural concrete, to pick up that percentage. Similarly, some of the various other people are trying to find out, and you will see the compressive strength more or less the same, doesn't because you're using superplasticizer for compaction or compacting, you are getting the compressive strength. Look at this, almost similar things. This huge number of papers are just trying to put certain papers just to give you a message or idea. Similarly, split tensile strength, one slide I put it, seeing the first author is one of my PhD students, and similarly flexural strength, almost same trend, not much of decrease. I'm coming to the permeability test. Look at this. This all falls under your at most at 28 moderate category or low category. You need to see three: workability, if you're talking of structural concrete, then workability, and then your compressive strength part. See, resistance to sulfate attack. See, after our research, we were the kind of first in coal bottom and foundries and in the world to use in the concrete. Many people have started, even in Turkey and all over Europe. See this, even shrinkage resistance sulfate attack is very, very effective. See, basically, let me put it in general thing. When we try to use these byproducts in concrete, my point is, even if it doesn't increase any of the parameters, keep the concrete at the same level, or even if little bit 5% decrease, still I will have to use it. Because the kind of money you save as a cost of price of cement and price of fine aggregate. Second, the amount of money you save in line filling costs, and more important, there is no measurement of the amount of money you save from saving the environment. So even if it, but most of these byproducts, they do improve the durability. They do improve the compressive strength. So that is a win-win situation. This is a very common question anywhere. What happens if it reduces by 10% or keeps the same level? Even then, we must use it because you are saving, otherwise it costs. So these are some of the things. Sign again. Not working. Oh yeah. See this again. Ghaffuri and Baruch. See, I'll give this credit to him. 99, he is a professor in Illinois Institute of Technology. He was the kind of first person who published paper on coal bottom mesh. But seeing the issues with the workability, he left the research. Then I said, we started it so that we need to find out solutions. See, drying shrinkage, all within the STM range, STM parameters. So it is not, none of the properties getting adversely affected. Point of the message. abrasion resistance, and you can use in the road construction, subway, base course, etc. kind of thing. So the conclusion, if you look at it, and if you're looking for a structural concrete, I would say 15, 20, 25% is very, very safe, because it gives you decent workability and good durability. But if you're looking for a higher percentage use, which you can use in paving blocks, paving stones, or hollow blocks, you can go for a larger replacement, as we do not need very good workable concrete. Second is, this is the waste boundary sand. This is the research we started globally in my school, and after that you find a number of papers floating around. And then I gave these two names, which is very popular in the elsewhere: the spent boundary sand and the waste boundary sand. What is this waste boundary sand basically? This metal casting industry, I am sure there must be many in North Cyprus and Turkey also. It is made of a silica sand, and the molds are made of a silica sand. Then you add certain chemicals to make the mold, and then the molds are heated up to say high temperature. And once it is heated many times to make the molds, the sand loses its cohesiveness. And once it loses its cohesiveness, it becomes useless for the industry, and they throw it out. And once they throw it out, I first used the name waste boundary sand. But then I started hating the word waste as something which you are using it, you should not call it a waste. So I gave the other name, a spent boundary sand. A spent the sand which is already exhausted its utility in the foundry. So these two names we kind of gave it. So look at the physical, they are angular. So when we started this, we found the properties are similar to fine aggregates. And sand, natural sand is a huge issue in India. I do not know what is the issue in Turkey or other parts of the Europe, but that is a big challenge. As I said, cement you can manufacture, sand you cannot manufacture. So look at this part. These are chemical composition, is very rich in silica. And these are the likely applications. If you put in the Google say foundry sand, you will find, I would say, lakhs of articles on use of foundry sand on CLSM. People in the geotechnical engineering may be knowing it. It's called controlled low strength material, which is called flowable fill. But for the concrete, we started the fundamental research here. So I'll show you some of the results of our things. Look at this graph. Look at this graph. For a person who wants to criticize, see, very small increase or decrease in the bar chart. That can be part of a statistical error. Yes or no? Maybe 5% increase, 5% decrease, part of a experimental error. Somebody wants to criticize any research, which people do, why you're wasting your time. Look at critically the graph. If even with the 25% waste boundary sand, our strength is not decreasing. This is the point I want to highlight. Even at 20% is more than the control. And since the particles are fine, they behave like particle packing behavior. So that is the reason you get these things. After my research was published, a very good friend of mine, who was professor in Wolverhampton, UK, Jamal Khatib, I think these days he lives in Lebanon. Then he called me, he said, I want to replace up to 100%. I said, well, go ahead. Look at this. It's Khatib, 2013-14, we worked simultaneously. Look at this graph. Even 60%, you are getting around 25 megapascal. So there are two perspectives to look at this graph. One is, you can, if you are very bent on criticizing something, you can say that strength is decreasing like a hell, useless research. But if you want to find out positives out of it, Even with 60% replacement, you are getting around 25 megapascal concrete. Even with 100% replacement, you are getting a strength which is more than enough for a pavement blocks, paving stones, etc. So the idea is how you are looking at it and what is the purpose. Our purpose is, at least my purpose is, to find out solutions to use in certain construction materials so that we do not have issues like land filling, etc. etc. Because concrete doesn't mean only structural concrete. Concrete means like right from 10 megapascals to 200 megapascals. So depending upon things, we try to find out. See, similarly, I think he is an author from Turkey. I don't know which university. I see. Look at almost same thing. Similar. The split I am skipping because split I will skip again. Elastic modulus. Look at the rapid chloride permeability test. It is behaving. It has improved the durability also, permeability also. So here this is a win-win situation. By using up to 20% or 25% in things, we are improving the strength, improving the durability. Because only with the compressive strength you cannot judge the concrete is good or concrete is bad. You need to see the durability, that is very, very important. This dicing salt also doing very good results if you have a look. Ultrasonic pulse velocity also gives you indirectly how the concrete microstructure is, how it is behaving. It has gone into all, as per a code, it is considered as a good quality concrete. Okay. Abrasion resistance on like 15-20%. We can see this is also producing huge quantity globally on this side. And this I can tell with more authority and confidence that this is a better material than coal bottom ash for use in the concrete. Because this is not a hollow material, this is a solid material and very similar to your natural sand or river sand. What do you call it now? River sand, natural sand, or fine agri, whatever you call it. I have not included, but I will give you an idea. Those who may be interested, they can contact me. After this, when you start a decision, we just at some point of time you come to a stage, you just don't believe in publishing. To talk in Europe, particularly Germany and the US, and not about sure about Turkey and North Cyprus. Whenever you want to justify to their agencies in Germany or France, they want to find out what is the leachate analysis, how it is going to affect the soil. If you're using, say, MSWS or foundry sand or coal ash or any material, so they want to do the leachate analysis. We have done it, not included in the part in association with a professor in microbiology in my school. And we have done treated foundry sand with microbes, fungus, bacteria to improve the leachate quality. As such, this material is not dangerous. You do not need to do those researches. It's a very, very safe material as such. But if you do like you go for the use of hospital waste ash, for example, or municipal solid waste ash, in that, if you really want to publish papers in good journals, you must include this. Otherwise, everybody does fresh properties, everybody does strength properties, everybody does durability properties. So what is new in your research? So if you do this leachate part, your publication will have a better value. So similar to the conclusions here, easily you can use 15 to 30% in structural concrete and block. You want to use higher than that, Jamal Khatib reference is more than enough. Now coming to this glass, waste glass, again you know how much is generated. Just have a look at this. Different types of glasses you have. Okay, and this quantity increasing exponentially every day or every year. And we simply cannot say we have an ASR problem. ASR problem is solved to a large extent with the use of metacholine and silica film, etc. But see, look at the quantity. Worldwide is how much? 113 million metric tons. Like India that much, whatever data I could get. But this is huge. Look at that. Recycling, nothing. And that usage we have to find, and this can be a wonderful material, I'm telling you, for cement replacement and as a final aggregate replacement. But with a caution, you need to be careful in grinding to the proper size. If it is irregular size, instead of helping it, maybe you may not achieve good strength for a structural concrete. Otherwise, lower grade concrete, there is no problem. So this is how it particle shape, particle size for the benefit of the audience. High in silica, but it has all calcium oxide, silica oxide, ferric oxide. So to be very honest, if you once it is finally fully solved ASR problem, it could be a wonderful material to be used in along with silica film and fly ash for high performance concrete, because it has decent amount of the calcium oxide, aluminum oxide, etc. So these are uses of waste glass, and look at how the I think the first author is from Turkey. It's very how does the unit weight varies, air content? There's a very marginal change in the air content. The graph looks like, when if you look at the axis rating, it's very marginal. But again, this again not from the Bible taken that this is the only research available for the unit weight. There's a lot, but it gives you an idea of how to go about it. Slump, look at the slump, not a problem. 20% replacement, decrease in percent. So this is not a substantial decrease. I to be very frank, I'm not concerned if property decreases. I'm not concerned as a civil engineer as a concrete materials. I will use it the other type of concrete. Objective is to find out its usage basically. Look at this. I think his first author is from Canada, McGill University. See, there was early research in 2000, early 2000, late 90s and 2004. But because of ASR issue, the people dropped it out because you cannot use in the durability part. But now the solution is coming up with the help of supplementary cementing materials. I'll show you some graph here. Serial compressive strength. Look at this. Even with 100% replacement, you are getting how much? Around 65 megapascal. But again, this research alone can be misleading. You need to see durability properties and particularly ASR along with the workability. But this, look at this. Kim et al. Similarly, split tensile strength results more or less similar. I'll come flexural. See, if you look at some of these flexural strength, the good strength achievement is consistent, is not much decrease to be controlled. Any whether it's research in Korea, research in Turkey, or research in Canada, something. So compressive strength is not an issue with this material. Water absorption, look, even it decreases, which is good in a way, but not to plus replacement. Is Song et al. From Korea, Lee from Korea. Silica reaction. This is the thing. If you find out this solution and we have a solution, then this is a wonderful material for concrete stainless fine aggregate cement, whatever you want to use. Look at this. Relative extension. These are the things that general. See here, look at this. The permissible is a 0.1, and then for 100%, you got this scheme at all. See this. This is a solution. Which supplementary cementing material? Look at this graph. Without fly ash, you have the high shrinkage. With fly ash, all within the range. Similarly, if you use fly ash or silica fume or metacoline or rice husk ash, you can control the alkali aggregate expansion, alkali silica ash. And in any way, if you once we design, let me go to the other one. So look at this. This is with metacoline. Look at this graph, metacoline. The latest research published in 2020. Look at this. With only 5% metacoline, all concretes, right from 0% glass to 50% glass are almost within the range of 0.1% expansion. And anyway, when we talk of high performance concrete design, whatever my knowledge goes, you cannot produce high performance without supplementary cementing materials. It can be, and not only one, it has to be in combination. Silica fume alone is not sufficient. It has to be GGBS or rice husk ash and metacoline. So even this glass can be a wonderful material once you are able to, and the result shows, look at the other result also. Same, it is below the things. Similarly, these are the green brown glass. So thank you, and with this I wanted to basically the 2-3 points which I am repeating it again is finding out the solution. And if you are the one who is starting, I remember when I first took the research on waste boundary sand, I used to get jokes from my own school, are you going to make it, are you going to mix the chicken curry something with it? So when you do something new, there's going to be resistance. People are not going to accept it easily, let me tell you. Because once it is accepted, I am giving you some secrets of publication. Once it is accepted, your paper is going to be cited very, very well. Because you are going to be like first in the things. Like most of papers published in boundary sand have my references. Initially, there was a lot of resistance. What is this material all about? Say glass also. Similarly, the waste plastic. Because in 40-45 minutes, I said cannot make it. But again, the next important topic is waste plastic, scrap tire. The only issue comes up with the for structural concrete is the bond between the concrete and the plastic. We have some solution, but it's not that we can blindly use in the structural concrete. So, and we have to find out a solution if we want to save our environment, landfilling, and reduce the cost of your concrete. Thank you. I think I didn't take much time.
No, it's okay. Thank you so much. I think that's.
Any questions? No.
Let us take some question and then. Any question?
There is one.
Good afternoon, sir. Thank you very much for the presentation. My name is John Schwarzer from Cyprus International University, Department of Civil Engineering. So my question is, some of these waste materials, and I know most of them, they require additional processing that might also add in energy consumption. So how do we reconcile the issue of the energy consumption to save the environment for environmental impact assessment?
Excellent question, and the answer is very simple. The material which I have, the first two at least, the first two I presented, coal bottom ash or foundry sand, they do not require any processing. They do not require any processing. Obviously, if you bring foundry sand from industry, you need to sieve it through 4.75, sieve. You need to remove some boulders or particles. Otherwise, technical processing is not required. And let me tell you, if you are going for a certain processes which is energy intensive, is going to increase your cost. And you really do not know whether the use of such material is really going to give you a structural concrete or not. So you need to really find out whether we need processing or not. This like glass doesn't need it, you know. You need to have only a very fine crushing machine. Uniform particles gives you. As such, there is no other treatment needed. You can do your research. Research is a different ballgame. I am talking from a very practical usage. If you want to use foundry sand by treating it or by cold bottom ash or base glass, by treating it, processing it is going to increase your cost by 10%, 20%. As a common man, I am not going to buy that concrete. Even I am not going to buy it. Why? I say he has used some materials which I am not aware of, and he is asking for 20% more cost. So the idea behind this research is you should, like in typical some material, imagine some material which is not available in North Cyprus, and you want to bring it from say Istanbul. It is going to give you a huge cost increase, I believe. So it's not, you're not bringing 1 cubic meter, you need thousands of cubic meter of things here. So concrete research, ideally, unless you're going for a 200 megapascal concrete, that is different thing. For normal concrete construction, try to use your local available material. Try to import something, the cost is going to increase. Similarly, if you need processing for what? If you take a material, do the physical test, chemical test. Obviously, I'm not saying you don't do any test. Even in your laboratory, if somebody comes with a bag of cement, you perform certain tests before use. Yes or no? You perform certain tests before use. So do the same testing for this also. Because material research, you should never use even cement without testing, like consistency, setting time, etc. So, in my opinion, processing, at least for these materials, is not required. Because I want to use it, not necessarily in a structural concrete. If it fits in, wonderful. Doesn't fit in, there are so many other scopes for using in the concrete. I hope I am able to convince a little bit to you. Any other question?
Hocam, you can use this, Hocam.
Thank you very much for this nice presentation and inspiring presentation, Professor. Just a quick question. In just respect now, when we do this kind of research, there are mechanical improvements. Also, we have environmental aspects. These are the pillars under the sustainability, actually. Also, we have the cost, and on the other hand, we have the social. Can you give us some hints regarding the social aspects of this kind of study? Because this is which we are currently seeking to answer in that sense. So, when it's mechanical, compressive strength, durability, these are the things. When it goes to costs, it's economical costs we can calculate and see the differences. And environmental, life cycle assessment can be done. But in the social part, can you give us some hints regarding the social impacts of these replacement materials, actually?
I really could not understand what exactly will be the social aspects.
I mean, how would this affects the social side of the communities who use those?
I can answer the very lighter side. Say, I'm walking on a road, for example, on every side you have a waste plastic line or waste glass line. If it's clean, you definitely would like better, I've not done any studies on the social side. But the other point which you raised, life cycle assessment, that can be a good, I've not done it because at this point of time, but that can be a good thing to take up. That could be a good point to take up, life cycle assessment. that can be good, some of people can pick up. But see, those things, social aspect, what this is a good point, life cycle assessment. See, when you talk of any research, you got some material from, say, Girni tomorrow, right? Not that you straightway jump to durability properties. It's a step-by-step process. First of all, you have to see whether it's suitable or not. You do not need to close your eyes and start using it. You have to find out its physical, chemical, morphological, and properties, and then see whether it's suitable or not. First of all, you need to judge its suitability from ASTM standard or Turkish standard from the cement perspective of fine grit property. Find out their physical properties. Then try to use in the cement, few tests to it. Once you keep encouraging it, then try to go for it. And not, see, please do not misunderstand me. I want to use these materials blindly in concrete. No. They need to set it like concrete center, for example. The finest modulus is similar to fine aggregate. Their particle shape is similar to fine aggregate. I omitted one chapter here, wood ash, for example. I spoke in Bursa 2 years back. We tested wood ash from at least 100 sources. And then when we did the physical chemical analysis, then we only choose those which fitted into ASTM C666, sorry, ASTM, what is the code for polymer material? It's skipping my mind. So you need to do that space, not saying blindly go for it. There are some other, even like in fly ash, for example, it has more better application in agriculture engineering than in civil engineering, fly ash. So you need to do all check whether they can be done or not. Like glass, for example, want to use a cement replacement. There's a good silica oxide, good calcium oxide, good aluminum oxide. So these things gives you confidence. Its properties are similar to cement, so we can use particle size, so we can use a cement replacement. So those things I'm not saying you just skip it. No.
Thank you so much. Any question? Okay. Thank you. Laboratory testing of viable soils, to present a token of appreciation to our keynote speaker, Professor Dr. Rahman. Now we will continue with the regular paper. We have 7 papers in this session. We will start with Dr. Şevket Bostancı. I invite Şevket Bostancı on the stage to give his presentation. Şevket, you have 10 minutes, please.
Good afternoon, everyone. My name is Şevket Bostancı from the University of Turkey. Following Professor Sittegi's presentation, that will be quite linked on local basis, actually. My presentation will be about the use of glass fiber in low carbon paste production, and I'll specify my reasons regarding to why I did use these materials in the upcoming slides. And here are the contents of my presentation. I don't want to touch regarding to save some time. First of all, giving you very brief on the background of my research. Nowadays, we get to hear more about SDGs Sustainable Development Goals by the UN, United Nations. And one of the aspects is reducing the carbon dioxide emissions, and this is not something new actually. However, we are trying to be on international basis, national and local basis regarding to Professor Spiri said, whatever we have got available on national level. However, performance loss is a major challenge, but I don't fully agree with the strength reduction as Professor Spiri also pointed out. That's why in my previous papers I did mention there should be a score board in order to give score for each property. So for the paste, as we replace the cement in order to lower the carbon dioxide emissions, what we can use in order to compensate these strength losses. Fibers are utilized in this aspect in order to compensate this strength loss. However, whether they are effective or not is a question mark. But as we say here, effective approaches, industries aiming to integrate these approaches, they have to be cost efficient at the same time. Otherwise, industry doesn't go for it. And also there's another aspect, circular economy, gaining importance of the circular economy in order to promote the sustainability further, because it's not only the embodied CO2 emissions, it's also the cost aspect. We can persuade industry to go for these approaches. I kept it short as possible, my slides. Here are the materials that I used for the PC, quite straightforward, under the EN 197 standard. And wood ash waste was the waste material in order to achieve low carbon. And I have done previous research on using wood ash in concrete production, but here I did use in the paste, and specific gradings I did use in order to compare with my research earlier. I did see it to 425 micron, and in order to make a comparison, if grading changes, what happens, I did see it to 300 microns. These are quite coarser when compared with Portland cement, but there are some other researches I have been doing. This is only glass fiber today. I have animal hair, and I have polypropylene fiber. In order to cope with all these projects, I did keep the sieve sizes quite coarser to extract more materials, to be honest. And PC was replaced by 5 and 10%. That is basically depending on the existing literature, which mostly think that 5% would be the ideal content. And also, I did use 5 and 10% in concrete production. So at least I can have a comparison again compared with my previous researches. In addition to that, I did use glass fiber. One of the reasons, and the major reason actually, amongst the fiber types we use in our university, glass fiber is the cheapest one we have got. And bear in mind, as Professor Spiri also said, we import them from Turkey, and that comes with a cost, and that comes in euros nowadays. In order to keep it on the cost-effective side, I will only use 0.25% of the total cementitious content. Here are the mixed proportions of the cement paste. Bear in mind, water to binder ratios are kept constant, and replacement levels were done on mass basis. And you see the abbreviations on the left hand side. GF represents the glass fiber utilized mixes. Okay, when I was doing this analysis, that was quite short time, I was going to go for the embodied CO2 emission calculations. So here are the system boundaries. As you see for the glass fiber and wood ash, transportation were neglected. The main reason is I was going to cover that weight for the wood ash, so that's ignored. For the glass fiber, there's no specific route that I have been following actually regarding to how it is obtained. It's obtained from Istanbul, by the way. And same route was followed for the cost aspect. after I did send the abstract, I decided to go for the cost calculations at the same time. Otherwise, it wouldn't be promoting the sustainability. That's why intentionally I left the title as low carbon. So I'll start giving brief regarding to the results and discussion. First of all, as you see, when we utilize the wood ash, fresh properties were lowered. That's basically due to the irregular shape and texture of the wood ash used compared to the PC, and also my colleague, Associate Professor Dr. Taylan, he did some study, microscopic study on the same wood ash, and he has observed similar issues. When we utilize the glass fiber, further friction is increased, thereby significant reductions were observed. However, 300 micron wood ash mixes achieved quite or slightly lower compared to 425. That could be due to reducing the grading may increase the surface area, so require more water. And a similar trend was observed by the flow table results. As we are being challenged by the time, I'm going to discuss quickly. For the strength results, as the strength is a major indicator actually, there is no specific reduction or improvement we did observe, as the replacement levels were quite low, 5 and 10%. However, at the initial phase, at 7 days, as expected, strength was reduced. However, over time, 28 days and 56 days, these got compensated, and further hydration provided to be through pozzolanic reactions. I suggest from 28 days and onwards, my previous studies suggest that the pozzolanic presence take place at 21 days. When we jump into flexural strength tests, as expected, due to the glass fiber presence, it acted as a bridging effect, thereby improved the flexural values significantly. When we go back to the compressive strength test, nothing specific was observed for the compressive strength, but for flexural, yes, we did observe. And the next slide will be about the porosity. When we utilize the wood ash, it increases porosity at the very early ages. However, due to pore refinement, which also supported by the strength test values, porosity values were slightly similar or slightly higher compared to the control mix. So there's no really major drawback by the wood ash utilization. When we utilize glass fiber, we observed slight increase at the early ages, but it got compensated at especially 28 and 56 days. As you see also, if we remember the fresh properties, it's quite linked actually regarding to 300 micron seed mixes had lower slump values, thereby it's believed to have more porous structure. That's why the porosity is increased. I want to jump quickly to the next one, sustainability evaluation. How I did do that? Based on the volumes that I discussed, I divide this volume by the given quantities, and I worked out the CO2 emissions and cost per cubic meter. And as you see, 5% and 10% replacement by wood ash decrease the embodied CO2 emissions by 5 and 10% approximately, respectively. And same applies for the cost. We mostly observe a reduction except glass fiber utilization. The reason is we do import this glass fiber from abroad, and it's in euros, thereby the currency rate going up nowadays. But most importantly, I try to make a relationship results show that it's quite comparable and nearly similar, except of 300 glass fiber. So wait for the fast track construction. We need to wait until 28 days onwards regarding the removal of the formwork. For the concrete production. Wood and glass fiber utilized mixes have improved their strength significantly. And also another aspect which I did observe also in the concrete production, 425 micron sieve wood mixes had lower porosity, and this may be due to better dispersion when it is quite coarser, and it's quite challenging when it gets finer. And also investigating would I see to 150 micron in my researches. It could give us promising solution for the sustainable production and promotion of the sustainability. And in order to further reduce these emissions and costs, we need to develop a national waste action plan. We could cope with it, especially the taxation on the landfilling action. And also we need to promote the use of waste materials. Otherwise, in this
He will present his speech online, and then he ready.
Hello, everyone. Sorry, can you hear me?
Yes, we hear you. Please, can you summarize it in 7 minutes?
Okay. I can't hear you very clear, but I hope you can hear me. Okay. Yes. Okay. Hello, everyone. My name is Behnam Rafi. I'm very glad to be with you. I will present this study on behalf of Professor Dr. Khaled Marar and Associate Professor Dr. Tulin Akçaoğlu. I will briefly introduce sulfur concrete and then literature review we have and experimental program and result and discussion and conclusion. In introduction, as you know, sulfur concrete contains mainly sulfur and aggregates, but to improve its properties, we need to add modifier. So in this kind of concrete, instead of Portland cement and water, we will just have sulfur. So cost-wise, it's very cheap because sulfur is very abundant, and we can provide sulfur from byproduct of gas company, petroleum companies. So, and this is a new material, and this is a new composite to use. Elemental sulfur concrete suffers from unstable molecular structure in long term. So, as I said, we need to add some modifiers to improve its properties. So for long-term reliability, we need to add some modifiers such as olefin, polysulfide, and these things. In our study, initially, I couldn't find any proper mixer for these kind of studies. So we initially started to design and manufacture our own mixer like this. This mixer has 2 reservoirs, and the inside inside we mix our material, and initially we heat the oil inside up to 150 centigrade, and then add sulfur to melt it. Then we will, in this study, we used high density polyethylene and linear low density polyethylene to modify our concrete. So we used sulfur aggregates and these 2 modifiers. I should also add that we preheated our aggregates up to 180 centigrade in order to save our time to heating the aggregates inside the mixer. As a result, we did FTR test to see if we can modify high density polyethylene and linear low density polyethylene by using these 2 modifiers or not. The results show that we couldn't modify the sulfur structure, but we can improve the properties of sulfur concrete. But at least FTR tests confirmed that the sulfur is not decomposed. In compressive strength and UPV test, we found that our control sample or specimen, we got 20 megapascal in 3 days, and adding 5% of modifiers, each modifier, high density polyethylene and linear low density polyethylene, we increased the compressive strength, and by adding 10%, it's almost the same, but adding more than this amount, we didn't have any improvement because during the mixing, we may have some balling problems. By adding more polymers and during the mixing, we may have some problems like balling problems. UPV test also confirms that adding 5 and 10% also the velocity of the pulses are increased, and it's obvious. In flexural strength and deflection, adding 5 and 10% increased the flexural strength. However, adding 15 and 20% of modifiers make our samples or specimens more ductile. So as you see, the modifiers, the polymers here acts like fiber inside the sulfur. And here you can see after flexural test, you can see the stretch of the polymer inside the sample. So this is the good result to increase the flexibility of the sample and specimens. As a conclusion, based on FTIR test results, it was determined that the sulfur is not decomposed. However, no chemical reaction between polymers and sulfur. It's revealed that by the UPV test that specimen with the lowest percentage of polymers are denser and more homogeneous than those with higher levels. And compared to the control sulfur concrete with no modification, the concrete with 5 and 10% of each polymer exhibited improved compressive and flexural strengths. And this is my references in literature review. If you have any question, I tried to keep very short because I had just 10 minutes. I didn't know that I can continue for 1 hour, sorry. If you have any question, I can answer your questions.
Thank you, Benna.
Now we will continue with Ramadan Ika. Ramadan.
Selamlar. Selamlar. İsmim Ramadan İlhan. Size kendi kendini iyileştiren beton üzerinde yapılmış çalışmalar hakkında bilgiler vereceğim. NCE, NCE, Engineering Composite, kendi kendini iyileştiren beton. Buradaki amaç çimento ve kumun yerine atık malzemeleri kullanmak. Atık malzemeler de kullanmamızdaki sebep çimento ve kum üretiminde enerji ve karbondioksit salınımı olmaktadır. Bunlar için de bunların yerine atık malzemeleri kullanmak için kullanılmaktadır. Betonun en bilinen problemi çatlaktır. Çatlak da yükten, hacim değişiminden, ısıdan, plastik oturmalardan meydana gelebilmektedir. Bak burada düz koyuyla gösterilmiş yükler altındaki NCE betonu. Alttaki kesik kesikle gösterilen ise normal bildiğiniz betondur. Ve burada NCE normal betona göre 10 kat daha iyi dayanığı göstermektedir. Sağdaki fotoğraftaki ise NCE betonun yükler altında çatlamış halidir. Burada dikkat edeceğimiz çatlaklardaki kararlılıktır. Çatlağın genişliğinin 100 mikronun altında olması gerekmektedir. Burada base materyal olarak benim araştırdığım curuf ve mermer tozudur. Bunları kullanmamdaki amaç doğada kirlilik yaratan bu maddelerin yerine bunları betona katarak standart betonun özelliklerini kat kat üstünde bir beton üretmektir. Burada tamamlayıcı malzeme olarak slag kullanılmıştır ve alkali ortamda kompleks strength'i bayağı yüksek bir dayanık kazanmaktadır uzun sürede. Ayrıca çatlamış betonla kendi kendini iyileştirme şansı tanımaktadır. Mermer tozu ise daha önce yapılan çalışmalarda görülmüştür ki birçok pozitif etkisi vardır NCE betonda, yani kendini iyileştiren betonda. Hem maddi açıdan hem de işlenebilirlik açısından. Burada NCE'de kullanılan fiberlardır ve mikromekanik teoriyle yapılmaktadır. Mineral sadece curuf kullanılmaktadır. Curuf ile birlikte fly ash, metakolin, uçucu kül ve geniş tabloda kullanılmaktadır bu beton çalışmalarında aktivite olarak. Şimdi bu maddelerin kullanılma amacı doğada endüstri atığı olarak kullanılan bu maddeler betona belli miktarlarda katılarak yüksek dayanımlar kazanmaktadır. Bu bizim standart NCE'nin kontrol karşılığı. Bir oran çimento, fly ash, kum, su akışkanlaştırıcı ve %2 oranında fiber kullanmaktadır. Literatüre baktığımızda Çin'in bu konuda çalışmaları vardır ve CSI jeli ve kalsiyum karbonat üreterek çatlayan bölgede iyileştirmeler yapılmıştı. İyileşme olmuştu. Şahmaran'ın bu konuda büyük çalışmaları vardı. Şahmaran ve arkadaşları betona fly ash ve slag katarak betonda 100 mikronun altında çatlakların tamamen kapandığı görülmüştü. Aynı işin çalışmasında ise atık mermer tozu ile atık mermer tozu çimento ve kumun yerine %10 oranında kullanılarak bayağı performanslı beton elde edilmişti. Mekanizma olarak beton çatladıktan sonra betonun içinde reaksiyona girmemiş olan çimento ile kalsiyum maddeleri dışarıdan karbondioksit ve su, yağmur ve değerlerinden oluşacak su yardımıyla reaksiyona girerek oluşan çatlağı 30 gün veya 60 günlük sürede doldurmaktadır. Tabii bunu etkileyen faktörler çatlağın genişliği, çatlağın yaşlı sıcaklık, kullanılan iyileştirme maddesinin miktarı, kalsiyum iyonlarının yoğunluğu ve iyilik mekanizması, iyileşme mekanizması iyileşmede faktör olarak bulunmaktadır. Bu NCE betonunu normal betonla karşılaştırdığımızda bayağı tüm özelliklerde kat ve kat daha iyi sonuçlar alınmıştır. Karbondioksit ve su yardımıyla bu mekanizma çalışmaktadır. Doğadaki dediğim gibi atık malzeme kullanılarak, beraber kullanılarak iyileşmeye yardımı olmaktadır. Ayrıca atık mermer tozunun diğer özelliği ise betonun volkabilitesini düzeltmektedir. Daha az daha az çimento kullanarak daha yüksek dayanımlı beton elde etmekteyiz. Diğer bize faydası ise uzun sürede bakım masraflarından bizi kurtarmaktadır ve bakım masraflarını minimize etmektedir. Dinlediğiniz için teşekkür ederim.
Teşekkürler.
Good afternoon, everyone. I am Kumar from Buckinghamshire Cyprus University. Today, I would like to present you a previous study that I have done in the university with one of my old master students, who is not here today. He graduated in 2020. So, the title is about the performance of recycled concrete aggregates containing concrete exposed to heating cooling cycles. Okay, here's the outline of our study. The topic is about recycled concrete aggregates, and first we should be remembering why it is needed or useful. Recycled concrete aggregates are actually very well known and very widely used all around the world for decades. However, here in Cyprus, still we are not used to employing these recycled concrete aggregates to our new concrete uses. The industry is not really using these kind of waste materials. And here you can see, even with these two photos, you can see the need for using recycled concrete aggregates in North Cyprus as well. The first photo, you're familiar with these quarries that we have on Beshbarmak Mountains. And you don't need to be an expert to see that these quarries are not managed in the best way, in the environmentally friendly way. Even if they are managed in a better way, we know that we cannot use quarried aggregates forever, and natural resources should be preserved. The second photo is also showing us another environmental risk. We are always replacing our buildings because of their completion of service lives, or sometimes just because we want to replace them with a more modern building. So we're demolishing them, and the waste needs to go somewhere. In Cyprus, unfortunately, even the landfills are not done in a controlled way. You can suddenly see some waste in the middle of a field one day. They're just dumped to nature. So recycled concrete aggregates could be a good solution for both issues, for reducing the amount of natural quarried aggregates that we are using, and also for reducing the construction and demolition waste that we are dumping to nature in this case, which should not be done. Okay, so here is recycled concrete aggregate particle photo that we have taken in our laboratory. So the dark part, let me a little bit summarize the issues about recycled concrete aggregates. The dark part is the aggregate, natural aggregate that was used in the old concrete, and surrounding the real aggregate, we have the old mortar from the old concrete. And after crushing the demolished concrete blocks, pieces, we are sieving them and obtaining the particle sizes that we need. And we are using this as the new block, as the new aggregate in the manufacture of new concrete. So, and of course, using this recycled concrete aggregates, we can use them, but we have to be careful about certain issues. One of the issues is that concrete itself is a heterogeneous material. And if you're using recycled concrete aggregates as a replacement to natural aggregates, you're going to have even more heterogeneous material. That is one issue that I will touch. In this study, we are focusing mainly on the thermal expansion differences, or the effect of these different thermal expansions of these different parts of concrete under heating cooling cycles. And why heating cooling cycles could be important. Even in Cyprus, well, we are used to having high temperatures in summer season. You all know, I think that the felt temperature can go easily beyond 45 degrees, sometimes 60 degrees Celsius is recorded in history. However, due to the climate changes, we are also experiencing several days with snow. This year in 2022, we had several days with snow. So we can have like 40, 50 degrees Celsius within seasons. However, this kind of temperature changes for some parts of the world can be even experienced during the day. In desert areas, you can have very high temperatures during the day and quite low temperatures during the night. So these expansions and contractions due to temperature changes is something that we have to look into. And as I said, when you're having the case of concrete mixes having recycled concrete aggregates, the increased heterogeneity of the material needs to be checked. We are expecting that the new mortar in the concrete and the old mortar and the old aggregates that is coming because of recycled concrete aggregates will be behaving in a different way, of course. And we have many studies checking the strength performance of these concretes, but there are quite less studies talking about the heating cooling cycles and thermal expansion differences. Actually, in this study, we're not going to measure the expansion amounts recorded, but we are going to try to understand their effects on the cracks, because we're expecting some internal cracks due to these expansions and contractions. So we'll be checking the strength performances after the heating cooling cycles. So we have two types of mixes, one control mix that was made totally with the local quarried aggregates, And the mix 2 was prepared by replacing 50% of the coarse aggregates by recycled concrete aggregates. And we proposed using temperature cycles between ambient and 160 degrees Celsius. And we had 3 different numbers, 3 different sets of heating cooling cycles. And we checked compressor and split tensile strength performances at the age of 28 after applying these heating cooling cycles. So we had 0 cycles like control, 3 cycles of heating cooling, and 6 cycles of heating cooling. And we were, in this case, we were recycling our laboratory waste. We used our laboratory samples that were used in certain tests, and we crushed our laboratory samples that were 3 years old, and we made the screening and sealing. We obtained the particles that we wanted, and we just use these recycled concrete aggregates for replacing the coarse particles. We didn't touch to the fine particles. We use natural sand for the particles. The design strength was 30 megapascal for the new concrete, and the cubes that we have crushed for using recycled concrete aggregates were C25, all of them. We selected same strength rate, and we tried to get some strength rate that was lower than our targeted strength. Here's our mix design. And heating cooling cycles, actually, we checked some literature and we tried to do something comparable to the literature. 160 degrees is not something that we will have in real life, perhaps. However, we use this extreme temperature to a little bit accelerate the effects of heating cooling. And duration of the heating period that we employed was 2 hours, and cooling period was 1 hour. And some mechanical tests as well. Of course, the recycled concrete aggregate particles had worse characteristics compared to the natural aggregates. This is something very well expected because they're old concrete, damaged concrete in most of the cases. And since the aggregate particles are having mortar around, coming in the recycled concrete aggregates, this old mortar is usually known to have more porosity, and this more porosity will be causing more absorption characteristics. So here we have first results about compressive strength development at 28 days. Okay, sure. So quickly, lime greens are the control set, blues are the particles, samples with the recycled concrete aggregates. We are seeing that with the compressive strength testing, natural samples, control samples, you cannot detect the degradation due to heating cooling very well with compressive strength testing. We will explain why. With the blue ones, we are seeing a decrease when we're increasing the number of thermal cycles of light. Using the percentages of drops compared to the natural aggregate samples, control samples, you don't see much difference. However, if you check the recycled concrete aggregate containing concrete within itself, you might see that 0 cycles and 3 cycles of heating cooling can cause up to 27% strength drop. And here we have the split and tensile strength for both mixtures. Here for both mixtures, you can see the strength drop in a better way. This is actually due to the characteristics of compressive strength testing and split tensile testing conditions. In some cases, compressive strength testing cannot really show you all the damages and deformations in concrete, since compression can really close the last slide. Okay, so we have seen that perhaps split tensile strength testing could be better in this case, where we are expecting internal cracks for understanding the performance differences. I basically summarized the conclusions while I was talking about the results. So main thing is that, of course, recycled concrete aggregates are having more internal cracks that is better detected in split tensile testing. Of course, we think that by managing the quantity of recycled concrete aggregates that we are introducing and managing the other concrete design mix parameters, we can still obtain concrete mixes that we can employ in many applications. Yes, I think this is
Thank you
most
so much. May I take your John? Stefan Babajar, may I invite you to
Good day to everyone. My name is Stephen Babajide Olabinton. I am honored to stand before you today, and I want to thank the organizers of this conference, the Chambers of Civil Engineers, and also I want to thank my supervisor, Associate Professor Mohamed Ali Musibafin. Thank you all. Introduction. Throughout history, concrete has emerged as one of the most utilized building components. According to Pascal 2017, it stated that after water, concrete is the most utilized on Earth. The ever-increasing volume of industrial waste is the root of many environmental burdens and problems. In recent years, waste materials such as coal ash, glass, steel slag, copper slag have increased rapidly. These wastes are primarily generated from industries and domestic waste, and the possibility of contaminating natural resources such as air, water, and sand constantly increases. It is required to help to improve concrete efficiency through the use of waste-related materials, and also to prevent river sand and valuable area from pollution dump sites. The use of wasteless powder and coal bottom ash in concrete industry will help to mitigate the environmental difficulties that are arising as a result of its presence. The problem statement is basically due to low income and also high numbers of underdeveloped countries, which they live in low quality housing. Some people reside in ramshackle housing made of waste materials, which they cannot afford the construction component of these materials. However, the most expensive materials used in concrete is cement, and the demand is globally increasing. When cement is produced, carbon dioxide is released during the mobility and processing method. It is consequently measures must be taken into consideration so that carbon emission by using greener building materials can have less impact in the environmental in terms of production and transportation. Here are my research goals. One, the evaluating the impact of wasteless powder and coal bottom ash in fresh concrete for different waste binder ratio, and also to ascertain how waste glass and coal bottom ash can be used or can affect the development of adding concrete. Also, to quantify the performance of glass powder and coal bottom ash as an alternate replacement of cement while using specific proportion. These are various researchers who have actually touched or worked on wasteless powder and coal bottom ash. It is noted that most of these researchers reported that incorporating wasteless powder and CBE improves mechanical properties of cementation composites. And also, it may be stated that wasteless powder overperformed with CBE. Okay, sir. I move to my materials. My materials used are wasteless powders and coal bottom ash. these are bottles generated from different houses, hostels, and in Lefkosia. And also, this is the process. These are my waste gas powder, the procedures, and these are ICPs. Co-bottom The co-bottom used here is a lignite coal, and the percentage of lignite coal is 25 to 35%. This is my nomenclature of my results, 20% optimum percentage. My results and discussion. I have different results which are based on the flowability or workability, also and the mechanical properties. I move to my flowability. It is stated that 20% of waste gas powder increase in workability, which means that it might be due to the lightweight surface area of glass powder that increase in flow. Also, my compressive strength. My compressive strength has an higher increment in compressive strength of waste gas powder, and it's increased in early stage. While also my my CPA partially reduces, but at 28 days there's an increment. Those are my figures over there. I move to my durability test. Absorption of water. It is noted that 20% of CBA absorb water, but 20% of waste gas powder, reduces in water absorption. Fire resistance also is a part of the durability test. In the sense that at 20, there's various tests I did in my fire resistance at 20 degrees Celsius, 40 degrees Celsius, and 600 degrees Celsius. And at 200 degrees Celsius, there's an apparent strength that is strength improvement. Also, at 400 degrees, it's deteriorated a little bit. For 600, it really reduces. That's because of the attribute of the breakdown in CHL and the elevation of carbon dioxide due to the expansion of the elevated of this temperature. In my conclusion, it is noted that a waste gas powder has been determined as the best for 20% replacement with a level of 1.5% of additive and also a constant water bender ratio of 0.35. And in my conclusion, flowability observation shows the workability of these samples enhanced as the glass powder content replacing cement expanded. And also, the compressive strength explain that development of strength increases at age at a fixed water cement ratio of 0.35. Substituting 20% of cement with the waste gas powder enhance the compressive strength. Furthermore, in conclusion, based on my analysis and conclusion, it is determined that waste gas powder and CBA plays an advantageous effect or important in terms of structural and long-term strength. And also, CBA can also improve overall performance of cement-based mortar. My recommendation, it is important to combine glass powder and other cementitious materials as a partial replacement of properties and as a partial replacement of cement and also fine aggregate. Also, in my research, I also explained that to conduct a long-time research, you can also use waste gas powder and co-bottomage in steel construction. So, addition of this research will be conducted along line to enable us to utilize bottomage and in addition of implementing bottomage into building structures. These are my references. Thank you all for listening.
First of all, my name is Ajuban Machibwe. I'm a doctoral student at the Department of Civil Engineering, Cyprus International University, and my supervisor is Associate Professor Dr. Mohammed Ali. I'll be talking about the assessment of ternary relation of quartz aggregates on mechanical strength, durability properties, and the microstructure of various concretes. These are my outlines, the introduction, methodology, results, and discussion, where we talk on the physical properties, the strength characteristics, the hydraulic properties, and the durability properties, considering abrasion resistance, and the same analysis. Previous concrete is a unique and effective tool which has been known to address several environmental factors, such as it improves the heat island, it helps to reduce heat island effect, it helps to recharge of groundwater, reduction in the total storm runoff, and it has been identified by the United States Environmental Protection Agency as the best tool for stormwater management because of its iconic interconnected structural core structure, which helps to increase the rapid percolation of runoff, and this helps to save the overall project cost. Its pebble concrete is a characteristic well-structured, post-structured materials that consists of a network of interconnected capillary pores, usually consisting of ordinary Portland cement or other cementitious materials, and quartz aggregates without any fine aggregates and lesser cement paste. And this gives it a high level of porosity, which can also be used. This high level of porosity can also be utilized in several construction projects. For this research, we're able to evaluate the effects of quartz aggregate size on the aggregate size and gradation on the physical properties, mechanical properties, and durability properties of quartz of previous concrete. Thereby, we're able to proportion different aggregate sizes. So, in order to achieve that, we proportion different aggregate sizes between 4.75 to 9.75 mm aggregates, 9.5 to 12.5, and 12.5 to 19 mm aggregate sizes in the ratio of 0 to 25%, 50%, and 100% replacement in single, binary, and ternary combinations, so that in order to do this, we're able to achieve a design array of 4 characteristics, and so that we can obtain maximum aggregate strength, mechanical properties, and also a good permeability and hydraulic performance. These are some of the applications. Basically, for the application of previous concrete, measured in pavements like parking lots, because of its lower compressive strength, and also, but recently, much more advanced research now, we're talking about the utilization of this because of its thermally insulating, in order to implement it in thermal insulating walls and also sound absorption walls. These are the aggregate sizes we utilize for this research, and some of the tests we carried out on the aggregate site are identified, like impact value tests and abrasion resistance on the aggregates. Some of the results we obtained on the aggregates, and for our mixed design, in this research, we had first 3 mixes were single aggregate combination. Then we also had the next 3 mixes, the binary combination, and also ternary combination of mixes. And water cement ratio was kept as a constant of 0.3, and also utilized the scrap size of 0.25%. And the method of first of all determine the optimal admission amount and the water cement ratio, after which we use this optimal amount result to find the effects of aggregate size and gradation on the previous concrete. These are some of the research features with the mixing the ball hand consistency test, and some of the this for the hydraulic property test. We did for porosity, water permeability, and infiltration rate. Then strength characteristics. Some of the results, these are for the physical properties. We're able to check for the fresh and hardened density. We're able to find that the results obtained for both the stages for fresh and hardened density were in line with the density of lightweight concrete.
And for the strength characteristics, we also have appreciable strength characteristics between 7 to 14 megapascal. Then also for the strength characteristics, we also observe from the research, we observe that the average size, as the average size decreases, the strength characteristics also increase, and also the strength for binary and ternary combination were higher than those obtained for single aggregate combination because of the interlocking, aggregate interlocking within the specimen, reducing the porosity. Then for the hydraulic properties, we also were able to find good results for both permeability coefficient, porosity, and the infiltration rates. These are some of the results we obtained. And for durability properties, we utilize the Canterbury test in order to find the mass loss as a result of abrasion resistance. We found out that the smaller the aggregate size, it is increased the abrasion resistance of the aggregates, and it gave us a good. These are some of the results we obtained. From the pictures, we found out that the level of deceleration after 500 revolutions at mixed stage, that's a ternary combination of aggregates. We found out that we had a lesser amount of mass loss and also higher abrasion resistance. Then for the microstructural analysis, we're able to the size of the pores within the samples, we are between 20 micrometers to 3.6 millimeter, and also we found out that the binding because of the limited number of the base, the binding also affected the strength properties. In conclusion, we found out that the strength characteristics is reduced with the strength increase with reduction in aggregate size, and also for the strength also we obtained for the single aggregate combination was lesser than those for binary and ternary combination. Then the values for flexurous, the values of the strength values also are in accordance with the strength requirement, the SM requirement for lightweight aggregates. And the hydraulic properties also we found out that the aggregate size also affected the interconnected pores, and which affected the total porosity and the permeability, and also the infiltration of the aggregate, the samples. For the pore structure, like I said before, the range of pores was between 20 micrometer and 3.6 millimeter. So these are my references.
Thank you so much. Presentation will be held by Madam Dara.
Good afternoon, everyone. My name is Omertan from Cyprus International University. I am also interested in the construction material, especially for the demolitions and recycled materials. Last time I talked about for the plastic aggregates, which is I presented in here. And this year I started to be interested with the sawdust, which is for receiving from our furniture industry in Alayköy, in the Mutfak, for their waste to reuse it again, and then we support to minimizing the damage for the environment for northern Cyprus. So generally, sawdust is known as a saw ash also, which is we use it for the. However, they have sizes which is we eliminated between 0.5 centimeter to up to 5 centimeter. In our concrete, we using as a finest versions, we replacing by fine aggregate. As we know it also, we can receive it the sawdust from drilling and cutting. At the same time for the wood pickers and stuff. I'm going quick a little bit. On the other hand, why we considering sawdust importantly for ourselves, because it is also affecting our environment. And nowadays, if you go to Alaykari, you will see that in the industry area, they waste the sawdust material on the lands, and especially it is affecting for the agricultural plants and stuff. This is the reason that I just want to work for this to be, maybe we can help to, in the industry, they apply for these things. According to that, it is affecting for the human health. At the same time, it is some of the people throughout the sawdust inside of the riverside, and it is coming inside of the water, and it is affecting for the plants, and at the same time for the animals and stuff. So generally, which it is we making some tests for the specific gravity and other properties related about our sawdust material, which is we get it from the limit. Sawdust with the fine aggregates. According to that, we using also superplasticizer because we try to be making the constant for the water cement ratio as a 0.5, because as you know that fine aggregate, I mean sawdust is absorbing more water according to apply, but we still didn't finish all the research yet. And some of the results is coming out from the last week and the previous week. For example, especially if we check it for the 7 days result, especially for the 50%, sawdust is really down, I mean decreasing the compressive strength. However, for the 30%, this, I mean, sawdust, when we use it, it is coming for the between lightweight concrete range for the strength. At the same time, the density is approximately 1,752 something, as I remember. At the same time, for the models of elasticity, every time when we increasing 10% from 30 to 40 and 50, it is directly decreasing because of the water absorption. On the other hand, for the thermal properties, when we check it for the thermal conductivity and stuff, when we started using sawdust, it started to decreasing the thermal conductivity. According to thermal conductivity, it is directly affected for the thermal transmittance, and hence it is increasing the R value, which is helping for us to using as an installation material. And on the other hand, in this research also I tried to apply for the statistical analyzing, which it is for the also cost at the same time for the, as Şevket Hocam talk about, which is for the environmental impact, such as for the sustainable assessment cases. We started using one way ANOVA's test method, which it is giving a data for us. On the other hand, I haven't added any figures and stuff because I have only 10 minutes and I don't want to be extended my duration. So generally for the conclusion, when we started using the sawdust, we see that we achieving more installation materials and it is helping for us to receiving lightweight concrete and it is increasing for the R value. On the other hand, when we started to making a concrete grade as a 30, we achieving by applying 50% of sawdust, approximately it is come around 17 megapascal, 17. So this is directly affecting more than half of the strength. Thank you for giving attention. Have a great day. Thanks again.
Any questions? I think no question. Tamam. Yes, hocam. Mikrofon.
Şimdi şöyle bir şey düşündük. Burada 25. sayfada bir atölye var. Bu atölye günün bitişinde planlanmıştı. Onu şimdi çay arasında yapmayı düşündük. Herkes çıkarken çayını aldıktan sonra basamaklardan yukarı 15 dakika içerisinde, süre 15 dakika çay molası. O süre içerisinde nasıl karıştırıp, nasıl tokmaklayıp, kalıp açınca ne çıkacak? 3 aşama. Onu yapacağız. Uygun olanları bekliyoruz.
Teşekkürler hocam. I think we are going to close the session. Yes, no questions. Thank you so much for your attendance. Altıncı oturum başkanı Doçent Doktor Ertuğ Aydın'a plaketini vermek üzere İnşaat Mühendisleri Odası Yönetim Kurulu üyesi Sayın Ayşe Pekrioğlu Balkız'ı
O zaman anons yapıldı aslında. İsterseniz o zaman özellikle de malzemeyi ilgilendiren iki session'ın arasında çaylarımızı alalım ve hemen binanın girişine geçelim. Çay molasını oradaki bir demonstration, malzemenin bir demonstration da yapalım. 15 dakika sonra da hemen burada. Saat 4:30. 4:45'te burada olmak şartıyla
Tamam, ben onu Şaban'a. Ama Şaban falan. Yok, tamam da mesela bir şey yok. Ve ancak yetin de böyle söyler. Bu türlü ne bileyim, yapmama var. Ama gittiğinde yanı söyler. Benim dedim. O da atmış ben. Orada bu adamlar tempo diyor, materyal yapamaz öyle. Tempo diyor. Adam dünyada bir eski. Adamlar yani beyaz kontrol ediyorlar.
Similar to the same as similar.
Yes.
Follow the program. I've got this program.
Two or three. Most first is just for 2 months. But there's no. So basically, this I think it's effectively key.
Bizim mikrofon. Kim getirdi onu? Sen mi getirdin? Ganimet dedim. Sen mi ganimet? Yok ya. Hadi ya. Aynısı bizde de var. Beşinden başladı. Ha? Yani sıkıldı. Bitti. Siktirdiler bizi. En son bir bölüm yok. Bir saatin daha var. Arabanın anahtarı yok. Nasıl yok? Bilmiyorum. Abi o değil. Düşük voltaj. Burada da tak bak geldi. Baktım. Nasıl? Bagajdan kamerayı alacağım diye. Çok ben bagajlarla açılıyor ya bagaj. Yani orada bıraktım. Elim kolum doluydu. Uzatmaları ne yaptın? Arabada. Bir tanesi orada. Diğerleri arabada. Bakıyorum bu ne yaptın? Bunlar diyorum. Aa, ben de bu. Yarın şey yapayım yani geçirirsen biraz. Hatta kameranın açıksa şimdi uğraştım ben. Kaçma be gel otur. Gidelim beraber bize gidelim. Tamam mı? Ellerine sağlık. Hiçbir şey olmaz. Sen de bırak. Hadi bay.
Nasılsın Musa? Ne var ne yok? İyi ki. Bu zaman var.
Evet, davetli komşular var.
Öyle. Hadi bakalım. Yok hocam.
Sen değil mi?
Yok.
Ya da senden de olabilir. Yani paylaşalım.
Bir şey yok. Yani aşırı.
Onları istemiştim. Hangi ev yapalım? Sadece bir alan yasal başka onlar tamam. Sadece iki kişilik asansör yapalım. Ha, anladım. Tamam. Bir kısmı yok. 15 metre istiyor. Bir şey söyleyeceğim. 370'den almıyorum. Kaç çıktı? 20 0. Tamam. Tamam.
Efendim. En sonunda mıyım? Size baklava falan keseceğim. Şimdi önünüzü almam lazım benim ya. Hani beni biraz... Ben sana bir baklava bir şey getirdim ben sana. Ne getirdim? Ne istiyorsun? Beni biraz önlere al ya. Bence İstanbul'dayım ben de Aslan Karadeniz'deyim. Aynen. Orada. Ne? Olsun. Ne Karadeniz bir memleketliyim yani. 22 metre tutuyor. Geldiğinde yine beni arayın. O zaman çıkıyorlar.
Now it is time to start the last session. This will be the last one, and we will complete the second National Civil Engineering Symposium today. I'm inviting, he's already there, but I'm inviting Session Chair, Professor Dr. Muhammad Ali Mosaber Pana, and I'm giving the floor to him.
Thank you so much, Joe. We are starting the second session, and as we are very behind the schedule, it was supposed to be started at 4, but now it's 5:30, and I know that everyone are tired, so I would like to ask from the presenter just follow the time, and for each presentation, 10 minutes has been specified. So please do not go over the time till everyone could go over the presentation and we could end up the session on time. So for now, I will invite Bilge Ishikoja to make a presentation about learning from earth and architectural heritage in Cyprus. So please upload there.
Yok gelmiyor.
Değiştirdik. Özür dileriz ama yararlı olduğuna inanıyorum. Herkesin kullanabileceğine inanıyorum. Onun için ileri gitme, geri gel. Ne yapalım? Başa gel. Baş. Geriye gel. Geri. Sonra işte bu dünya nüfusunun yarısı gelmiş burada yaşamakta ve prestij yapıları dünyada kendişle üretilmekte ve de kendi evini yapanlar kendince kullanmakta. Dolayısıyla bizim hem Kıbrıs olsun hem Türkiye olsun kültürümüzde de kendi yapı var. Benim elimde bir komut olsa da ben kendim yapsam o işi. Tamam. Nereye doğru söylüyorum? Geri gitmek. Tamam, geri gidiyorum zaten. İleri ortadaki. Şimdi şey dedik, dünyada prestij yapılarında kerpiç kullanılıyor. Çünkü onların kullandıkları teknikler kendiliğinden ilerliyor, pardon. Ve tekniklerle neyse sonuç olarak onlar çimento katkılı kerpiç kullanıyorlar. Biz ise alçık tereç katkılı. Alçık tereç katkı Teknik Üniversitesi'nin Mimarlık Fakültesi'nin malzeme hocasının ve Mezopotamya Anadolu içlerindeki şeylerden, geleneklerden öğrendiği alçık tereç karışımı. Şimdi biz dedik endüstri learning architecture mimari kültürden öğreneceğiz bazı şeyleri diye. Onlardan en önemlisi de deprem güvenliği. Bu şimdi kültür mirası. Deniyor ki kerpiç dendiğinde bu sadece komutla hisse olmuyor mu? Otomatiğe bağlamasanız, otomatik olmasa, ben komut versem. Nasıl kaybettiriyorsunuz? Geleneksel kerpiç yapıda öğreneceğiz. Fakat çağdaş yapı inşa edeceğiz. Bunu kısaca şöyle diyorum. Yani pamuklu dokuma, Sümerbank dokuması vesaire tarih boyu yapılmış. İlk baştaki kıyafet modelleri başka, bugünkü ihtiyaç ve kıyafetler başka ama pamuklu kıyafeti giyiyoruz diyoruz. Şimdi bu prestij yapılarından bahsettik, bunu da bahsettik. Kerpiç dendiği zaman insanlar bugünkü devirde yıkıntı ve geri kalmışlık olaraktan anlıyorlar. Çağdaşlığa ulaşamadık olaraktan düşünüyorlar. Fakat kerpiçin yığma yapısı, arka tarafta tuğladan olan yığma yapı, ayakta durmakla beraber betonarme yapı yıkılmış. Ne demek? Teknolojiyi bildiğiniz zaman o sizin için yeterli olacak. Burada da yığma yapı, herhangi bir önlem alınmamış. Bunu oradaki şeyde konuştuk. Yapının kendi ağırlığı %10 olaraktan yataydan tesir ettiğinde depremde köşegen kırmakta yapıyı. Köşegen yaşasın. Köşegen kırdığı zaman heyelan yapıp bina yok oluyor. Biz şimdi köşegen kırılmayı engelleyeceğiz. Tarih içerisinde kırsal bile köşegen kırılmayı durdurabilmiş. Ama bugünkü devirde inşaat mühendisleri, mimarlar, yığma yapıyı ve kerpiç yapıyı öğrenmedikleri için bunun önlemini alamıyorlar. Şimdi biz tekrardan mimari kültürümüzü korumak ve sağlıklı içinde yaşamak için kerpiç yapıya kavuşmak istiyoruz. Onun teknolojisini bulalım diye. Bunlar kırsal kerpiç yapı Kıbrıs'ta, bu da daha şehir olan kerpiç yapı. Sonuç olarak da muhtemelen güneyde koruyorlardır kerpiç yapıları, öyle düşünüyorum. Ege adalarında ama koruyorlar. Ve Avrupa'nın en çok ziyaret ettiği yerler Rodos vesaire hep geleneksel binalarını korumuşlar. Şimdi bugün neden tekrardan kerpiç yapı diye düşünüyoruz? Çünkü dünya enerjisinin 1/3'ini yapılaşma, 1/3'ini endüstrileşme, 1/3'ini ulaşım kullanıyor. Ve Türkiye sizin içinde endüstrinin enerji kullanımı hiç olmadığına göre ülkenin bütün enerji giderleri konutların ısıtma soğutma enerjisiyle. Biz onu %10'unu, %20'sini, %30'unu düşürebilirsek hem gereksel olarak kendi cebimizden tasarruf etmiş olacağız, hem ülkenin enerji giderleri azalmış olacak. Bir de çağdaş yapıları da dediğimiz zaman Herkes her şeyi anlamıyor. Burada öyle bir dış kabuk yapılmış ki içerideki iklim için klimalar kullanmak gerekiyor. Klimalar kullandığınız zaman nefes sisteminiz mantarlanmış oluyor, hastalık gelmiş oluyor. Şimdi tamam, doğru yere geldik. Şimdi insan sağlığından bahsedelim. İnsan sağlığı 36 dereceyle yaşıyoruz ve dış çevremiz iklimi 18 dereceden aşağı olursa çok fazla enerji kaybediyoruz. 24 dereceden yukarıda olursa atmamız gereken enerjiyi, arabaların egzozunu atmaları gibi atmamız gereken enerjiyi atamadığımız için her ikisinde de immün sistem, savunma sistemi düştüğü için hastalıklar başlıyor. Varsa hastalık ölümcül oluyor. Dolayısıyla çevre ısısı 18-24 arası olması lazım. Zaten Kıbrıs'ın ısılarına bakacak olsanız kışında 17 ve 1 gibi oluyor. Yazında 40 ile 18 gibi oluyor. 24 falan gibi oluyor. Sonuç olarak da dış çevre ikliminin yazın 24 derecesine evin içine alıp ceviz kabuğu gibi kabuğundan koruduğumuzda kışın gündüz sıcağının 18 derecesine evin içine alıp güneşi de evin içine alıp içeride bir 20 derece sağladığımızda ve bunu dışarıya kaçırmadığınız zaman artık sizin enerji kullanmanıza gerek yok. Bu aşağıdaki grafikte Teknik Üniversitesi'nin Ayazağ'daki binası dışarıdaki ısı yükselirken, düşerken içeride bir değişiklik olmuyor. Kerpiç yapılar. 2 minutes. Okay. Yaşasın. Bu durabilite ile ilgili şurada biz denedik. Toprağa alçı kere çıkarttığımızda burada pratik ölçeklendirme sistemi. Gelenekselde onu konuştuk. Saman ve saman takıldığı zaman samanın bitki özü, öz suyu malzemeyi stabilize etmekte. Geri gidelim. Bu kaleler, toprak kaleler işlerinde inorganik toprak ve organik herhangi bir katkı. Kıbrıs'ta saman yerine kaktüs yaprağı suyu da kullanılmakta ve dolayısıyla durabilite sağlanmış oluyor. İnşaat teknikleri çok yavaş olduğu için onu bütün inşaat makineleriyle, kalıplarla hızlandırmış oluyoruz. İç duvarları kerpiçle yapabilirsiniz, farklı malzemeyle de yapabilirsiniz. Burada inşaat tekniklerini konuşuyoruz. Birisi kompaksiyondur, diğeri parke taşı tesisinde ürettiğimiz bloklarla binayı örebiliyorsunuz. Bu şey içinde kırsal kesim insanlarına blokları verdiğinizde kendi evlerini örsünler diye yapılmış bir sistemdi kapı dairesinde. Bu da şatkırık makinesi, püskürtme makinesi. Bunu Direkkaya'da kullandık. Direkkaya şeyden güneye doğru hava meydanında. Burada zaten Mimarlar Odası'nın katılımları var, inşaatı gördükleri. Nedir? Toplaklama tekniğiyle bir günde 4 metreküp yaparsanız püskürtme şatkırık makinesiyle 1 saatte 5 metreküp, 30 metreküplük duvarınız varsa bu yukarıdaki gibi bir günde bitmiş oluyor şatkırık makinesinden. Tabii bunun için uçak pilotu gibi çok ciddi operatör lazım. Deprem güvenliği konusuna geldiği zaman yataydan gelen kuvveti yürütecek katmanlar taş tuğla dendiği zaman mukavemet değişik olduğu için tuğlaya enerji tarafından emildiği için tuğla tarafından bina ayakta kalıyor. Bu tarih boyu dünyanın her tarafında kullanılmış. bugün kullanılmıyor. Şu tarafta yatay kaydırma düzenleri İran, bu tarafta yatay kaydırma düzenleri Peru, bu taraftaki Kıbrıs. Ne diyoruz? Karpas tarafındaki bina. Büyük taşların arasında küçük taş olduğunda büyük taşlar yatay olaraktan küçük taşların üzerinde oynadığı için Kıbrıs biliyorsunuz deprem bölgesi. Ender de olsa ama deprem olan bölge. Dolayısıyla depremler bir riski olmamış oluyor. Bunu işte ilk önce acaba yüksek mukavemeti olan katmanlar mı koysak dedik. Ona hiç ihtiyaç yok. Yerinden kıpırdadığı zaman işi çözmüş oluyor. Aşağıda da çam ağacının yere düşmüş, kurumuş dikenlerini ara katmanlar olaraktan koyduk. Bu da aynı işi görüyor. Bu sarsma tablosu üzerinde şartlık makinesi, bu Ordu'da blok üretimi ile kamış yapı tekniği. Dünya deprem güvenliği için yüzey korumayı deniyor. İnşaat mühendisleri güçlendirmek istiyorlar. Fakat sallandığı zaman içi yine paralanıyor. Veyahut da kesitinin içerisine donatı koyuyorlar. Aşağıdan yukarı doğru duvar böyle gelirse, bunun içerisinde bir donatı varsa, bu zeminle çatı arasında oynadığında bu zaten duvarı yıkar. Yani inşaat mühendisleri o konuları, o Avustralya'da örnekti, bu da Avustralya'da örnek. İçeride bambu, dışarıda bambu, ikisini birbirine iplerle bağlıyorlar. Ve halbuki bütün buraları habire bağlandıkları yerler çatlıyor. Sonuç olarak da güçlendirmek değil, bizim istediğimiz yerden zayıf olsun ve bina ayakta dursun diyoruz. Bu sarsma tablosu yatayda kaydırma düzenleri veyahut da enerji söndürme düzenleri konmuş. İnşaat Mühendisleri Ankara Arka İşleri Genel Müdürlüğü birinci deprem yaptılar. 2, 3, 4, 8 defa deprem uyguladılar üzerine. Yıkılmıyor dediler, makineleri söktüler. Burada çok enteresan bir şey var. Burada bir çatlak varsa bir evvelki çatlağa kadar gidiyor. Ondan sonraki aşamalara geçmiyor. Sonuç olarak da çok şiddetli bir deprem bile olsa yapı yıkılmıyor.
Hocam, I gave you 4 minutes extra, so try to finalize the presentation.
Finalize.
Yes.
Okay. Şimdi dedik ki inşaatı yaparken kaydırmak üzerine yapacağız. Eğer ki mevcut içinde yaşanan bir binaysa ona da zayıflatma teknikleri keseceğiz. Ve bunu kestikten sonra kuvvet uyguladığımızda bir katmandan öbür katmana kuvvet geçmiyor. Bunlar da küçük deneylerle yapı. Bu aslında çok enteresan, bu mühendislerin bunu düşünmesi lazım. Kaydırma düzeni olduğu zaman moment şeyi düşmüş oluyor. Viranşehir'de kendi evini yapanlar, internetten girip bulacaksınız. Bir zamanda 6 metreye 6 metre bir bina. Kısaca dış kabuğu kerpiç yaparsanız içerideki ikilemi sağlamış oluyorsunuz. İçerideki duvarları istediğiniz teknikle yapıyorsunuz. Türkiye'de yapılmış uygulamalar. Bu Göbektepe Ziyaretçi Merkezi Urfa. Bu Altınoluk hafriyat toprağı ile yapılmış inşaat. 97 yapımı hala kullanılıyor. Peki, teşekkür ederim.
Now, based on the plan that we have, I should ask from Marwan, but he found some problems, so he recorded his presentation. Now, I would like to invite Aya Ahmed to make a presentation about energizing North Cyprus urban architecture, rethinking the future. Just could you please put the time?
Good afternoon. We would like to present our topic entitled Energizing North Cyprus Urban Architecture, Rethinking the Future. To start with, Cyprus is North Cyprus is mountainous island and they have used as construction. Cyprus employed a variety of building material, and stone was the primary building material used a long time ago, and now after 1940 reinforced concrete was introduced. The construction industry accounts for 23 to 40% of worldwide greenhouse emissions. Adab is naturally occurring building material, and it is one of the sustainable building materials that has been used nowadays. Natural materials should be accessed in order to utilize limited resources for a sustainable environment and to contribute to zero net carbon footprint emissions. As we know, there is a rising demand in sustainable building material, and because of this, the study that we conducted with Professor Ayşe Hoca is utilizing plastic waste in order to improve the properties and durability of those materials. Here we can see some of the traditional buildings in North Cyprus, from the Rish Pasha in Nicosia to the Girna Harbor and the Büyük Han in Girna Kapısı. Those are some of the traditional buildings that we can see here. What are the advantages and disadvantages of earthen buildings, or what do we call adabi? The ability to adjust the internal environment, they are available, they have good heat and sound transmission properties, they are cheap, they are affordable, but on the other hand, they are vulnerable to moisture. Because of this, we have to improve the properties of those earthen materials. Due to this, a new technology has been established at Istanbul Technical University by Professor Dokirishi, which enhance the durability of those buildings. We call this technology Alkar technology. What is Alkar? Alkar is a stabilized form of earthen building materials, which includes gypsum and lime and wood, which we are adding gypsum, lime, water to the earth. 10% gypsum, 2% lime, and around 20 to 22% water with respect to the dry weight of the soil. The energy usage in buildings constructed with Alkar technology is negligible, and they have zero net carbon emissions in comparison to reinforced concrete buildings. Alkar buildings are healthier than reinforced concrete structures, and also, according to the study that we conducted, structures constructed with Alkar materials are 13% less expensive than those constructed with reinforced concrete. Some of the previous studies regarding the stabilization of those Alkar, one of them is the usage of waste marble dust, and the other one was the polypropylene fiber. It was conducted by Professor Ayşe Balkis, and the results revealed that the usage of waste marble dust and polypropylene fiber content enhance the compressive strength, structure, and flexural strength of those materials. This is the polypropylene fibers, as you can see in this figure. Nowadays, as we said, a large amount of plastic waste has been generated due to the production of plastics yearly. Plastics, they are gaining popularity nowadays due to their strength, low maintenance, cost effectiveness, and lightweight. Because of this, we are trying to use them in construction to enhance the sustainability. In this study, we have crushed, or we have obtained those plastic waste from Hatip Oğlu from Sanayi Bölgesi. We have crushed them and received them to a size of 2.36. Those are the shredded plastic waste that we use in this study, and those are the properties of those plastic waste. The mix design that we prepared is we used 0.5, 1 and 1.5 percentage. And we studied the compressive strength, fracture strength, and some other properties. Those are the molded samples that we prepared for this study. Then the compressive and flexure strength test. At the end of the day, it has been concluded that the average compressive strength for after 28 days for the control sample was around 2.64 megapascal. With the inclusion of shredded plastic waste up to 1%, the compressive flexure strength after 28 days has been increased as well. Further increase in the shredded plastic waste causes negative effect on the compressive strength. As well for the flexure strength as well, as we can see, after 28 days, the flexure strength increases up to with the inclusion of 0.5% shredded plastic waste, further increase in the amount of plastic waste, it causes a negligible effect, negative effect on the flexure strength. To sum up, large amount of plastic waste are created each year, as we know, and alkali production is relatively simple, inexpensive, as I mentioned, comparison to other reinforced concrete material, which lowers the carbon emission and makes us a sustainable building production technique. The compressive and flexural properties, also the shrinkage properties of both mixes, had a positive effect on the sustainability as the usage of shredded plastic waste, lime, gypsum in the production of those samples. The usage of shredded plastic waste in alkali and the result that we obtained reveal that alkali or the modified alkali is an alternative construction material for sustainable production of earthen buildings, and the utilization of plastic waste in this research also contributed to protecting the environment and increasing the sustainability, increasing environmental sustainability. Thank you so much.
May I invite you to come and sit here? So after the session, if there was any question, we could go over. Now we have one online presentation, which will be given by Javid Worishi. He's gonna make presentation about recycling of fiber reinforced polymer FRP composite materials. So we could look here. So, sir, can you hear our voice? Unfortunately, we could not hear you. So, if you could please. But I think you could hear my voice. Okay, thank you.
Ask him to reconnect because it's from him.
Okay, sir. So they're telling me if it's possible to make reconnection, so maybe the problem might be solved. No, still we cannot hear your voice. But we could not hear you.
Okay, guys, can you hear me all right now?
Yes, yes, perfectly.
Wonderful, wonderful. It
so
needed a bit of, I had to reconnect, so that's why. Okay, I'll quickly crack on with my presentation.
Yes.
I'll share my screen.
So just please follow the time. We have a limited time in 10 minutes. If you could go over that, I really appreciate it. So you could start. Thank you.
Yes, thanks a lot. Can you see my screen, please?
Yes, very good.
All right. Well, thank you. Thank you so much, Professor Mohammad Ali, for kind introduction. And after all these glitches, now we are here. And thankfully that my colleague, Dr. Arya Asadi Langrudi is there. So he has been updating me about the time. So my name is Javed Qureshi. I'm a senior lecturer at University of East London in London, United Kingdom. And in today's talk, I will be talking about the recycling of fiber reinforced polymer composite materials. And again, my apologies for not being there in person, and I've really enjoyed today's presentations. So this is how my presentation is organized today. So first I'll give some background, and then global market share of FRP structures, and then strategies to recycle FRP and their pros and cons. And then after that, the cost of recycling methods. And finally, I'll draw up some conclusions. Now, construction produces about 1/3 of global carbon emissions, and there is a need to reduce these carbon emissions by use of sustainable technologies and sustainable materials. And FRP is such sustainable material with lower carbon footprint than traditional materials. In simple terms, FRP is simply carbon or glass fiber embedded in resin matrix. Now, for civil engineering applications, there are mainly 3 applications where we use FRPs. So FRP profiles for new build structures, FRP rebars in concrete, and FRP in strengthening. Now, the key driver behind using these materials is lightweight and corrosion resistance. But because these structures have been in use for last 30 to 40 years, recycling them is a major challenge. And in today's presentation, I'm going to talk about some tools and strategies to recycle these materials. Now, this is an example of Dawlish Bridge, which was constructed back in 1937. And it became beyond repair. So an identical bridge was produced, which is made up of FRP back in 2011, and it had no corrosion. Even it survived 2014 storms in the UK and was corrosion free. Now, global market share of FRP. According to JEC Group, the production of FRP is as much as $100 billion US, and the volume that is more than 12 metric tons. And it has applications in more than 15 industries, including marine, construction, and aerospace, and transportation. And the industry is set to grow between 5 to 6% over the next 5 years. 95% of all FRPs is glass FRP, and 75% use thermoset resin. Both of them are very difficult to recycle. And this is the market share. You can see that construction, global market share on the left side, it uses 26%, automotive 31%, marine industries, it is used in wind turbines as well. Now, interestingly, in 2020, the market share in Europe, it increased to 37%, which is quite promising improvement. Now, with that much application, the key issue here is recycling. So how do we recycle? And how do we dispose of the materials? So the waste is generated from production, or it is generated from use. And for as much as 40% of waste is from production, which ends up in landfill. And landfill and incineration are traditional ways to dispose of this material. But as Professor Rafat said today, that there might not be space in landfill, and there might be regulation. So across Europe, there are strict laws for dumping. But in United States, I mean, almost certainly you would you would dump it off in landfill. GFRP waste in Europe is about 304 kilotons, which is about 1/3 of its production. Now, what do we do with this waste material? So firstly, the material is cut and then transported. Then the strategies that we can use, it can go into landfill, and then we can incinerate or co-incinerate. The incineration is a burning process which produces kind of ash. The benefit of co-incineration is that there's a clinker which we can use in concrete. Now, there are three methods for recycling: mechanical, thermal, and chemical. Mechanical recycling is only commercially viable method, where we grind the material, we shred the material to reduce it into smaller parts. Other two are not commercially viable, and it requires a lot of money to certainly use those methods. Now, pros and cons. Landfill is quite cost effective, but certainly it leads to a lot of pollution, and it can create lots of greenhouse gases as well. Incineration and co-incineration, they have benefits, but they produce ash, which still needs to be a landfill. And again, it is these methods are quite expensive to build, and skilled labor is required for incineration and co-incineration. Recycling, on the other hand, it protects the environment, and it reduces the greenhouse gas emissions, and as a result, I mean, it could be useful for climate emergency. But again, the initial cost is really high, and the materials extracted, they may not have the same properties as the original virgin materials. And some of the processes may not be commercially viable. So for example, chemical and thermal recycling, they can only be used at a very small scale. But if you wanted to use them for larger scale, then you simply use mechanical recycling. Now, the cost analysis. Now, here you can see that landfill is the cheapest way to obviously dispose of the materials. But again, we may not have a space in landfill. It may not be suitable, and there might be very strict laws like in Europe. And out of two recycling processes, mechanical pyrolysis is again a type of thermal recycling. Mechanical is the cheapest one. And you can see that the chemical recycling, it costs huge money. So by all means, when the value of fiber is really high, like carbon fibers, this kind of recycling technique can be used. If the value is low, I mean, certainly it would be very difficult to use chemical recycling. Now, we have to come up with some innovative ways to deal with recycling when in many occasions recycling is not possible. So here on the left, you can see wind turbines, glass FRP. In the middle picture, you can see that the wind turbine blades, they have been used as bridge, as a footbridge. And I recently met up one of a colleague in America, Professor Larry Bank, who are working on this project, and they have actually produced a bridge. And on the extreme right-hand side, you can see that these wind turbine blades, they are being used as electricity transmission towers, so which is quite a useful use of this material. And then again, in the order of priority, we reuse the material. If it is possible, then repurpose it for different applications and recycle or recover, or we can co-process, incinerate. And the final one is landfill. So the conclusions are that recycling is a very major challenge, and we have to think in different ways to come up with new technologies. And landfill is the cheapest option. Mechanical recycling is certainly commercially viable, and low cost glass FRP is very difficult to recycle. And reusing or repurposing is the way forward. And these are some of my references. And thank you for listening. You can get in touch with me on these emails, and the copy of presentation is available at this side. Just bang on time. My clock says 10 minutes are over. So I don't want to take more time, and I'll be happy to take any questions at the end. And please have a look at this review paper. Thank you.
Okay, thank you so much. Thank you so much for your time as well. I know that you were waiting too much.
Yeah, definitely.
Thank you for your patience. Thank you so much.
Thank you. Thanks a lot.
So now I would like to invite Asli Bahire Barda to make a presentation about alternative approaches for sustainable concrete construction.
Öncelikle merhaba, ben Aslı Bardak. Çalışmam sürdürülebilir beton için alternatif yaklaşımlar. Dünyada en yaygın kullanılan bir yapı malzemesidir. Her geçen yıl nüfus modelleri bu üretimde artmaktadır. Bu konuyla ilgili gündem konusu olan karbondioksit, çimento üretiminden salgılanan karbondioksitlerin emisyonunu azaltmamız gerekmektedir. Çimento üretimi şu an dünyada insan kaynaklı karbondioksit gelişiminde 3. sırada etmektedir. Bu nedenle bunun önüne geçmemiz gerekmektedir. Bir ton çimento üretimi şu gün bir ton karbondioksit emisyonuna yol açmaktadır. Buna ek olarak inşaat sektörünün sürdürülebilirliğini davet edebilmek amacıyla beton formülasyonlarından, çimento bileşenlerinden yerine veya kısmen atık malzemeleri kullanmaktayız. Bu çalışmanın amacı birçok atık malzemeyi çimento bileşenlerinin yerine kullanmak. Kullandığımız malzemelerle çimento oranını düşürmek, aynı zamanda saf çimento malzemenin kompozitlerin performanslarını yükseltmek. Bu yaptığımız çalışmada fiziksel, mekaniksel ve aynı zamanda dayanıklılık açısından incelenmek. Kullandığımız atık malzemeler diğer türlü yumurta ve güçlendirmek için azot fayda kullanmış bulunmaktayız. Kompozitlerimiz çimento, otumaj, eggshell ve bazalt tübeler olarak kullanılıyor. Bu şekilde kompozitlerimiz. Karışık gruplarımız 2 ayrı aşamada yürütülmüştür. Bu çalışmadaki en önemli nokta maksimum seviyede atık malzeme. Yumurta kabukları 2 grupta ekleme olarak 2 grupta çimentonun yerine 3 grupta ise ekleme olarak kullanılmıştır. Daha sonra birinci aşamada yaptığımız karışımlar 7. günkü dayanım dirençleri karşısında en yüksek olan dayanıma sahip olanları bazalt fiber olarak yükseltmiş bulunmaktayız. 2 farklı orantıda bazalt ekleyerek betonun biraz daha fazla güçlü kullandığımız sampullar 50'lik kütlü prizmalar. Aynı zamanda yaptığımız testler 7, 28, 56 ve 90 gün. Yapılan testler çökme, yayılma, su emme, gözenekleri, basınç ve bükülme ve aynı zamanda sulfayt ve deniz suyuna karşı olan kilo kaybı incelenmiştir. Test sonuçları için konuşacaksak, bu yaptığımız örneklerde su ve çimento sabit oranla kullanılmıştır. Bu yüzden yer külünün daha fazla suya ihtiyacı olduğundan ve işlenebilirliğini düşürdüğü gözlemlenmiştir. Aynı şekilde dipler içinde daha fazla suya ihtiyaç duyulduğundan kullanılabilirliği düşürmüştür. Fakat yumurta kabuğu aslında kullanılabilirliği arttırdığı gözlemlenmiştir. Bu emme sonuçlarına göre yer külünün çok fazla suya ihtiyacı vardır. Çünkü kaba parçacıklara sahip ve daha fazla su emmeye ihtiyacı vardır. Özellikle 56 ve 90 günde tozların geç reaksiyona girdiğinden dolayı 56 ve 90 gündeki seslerde daha fazla suya ihtiyaç duyduğundan soğanma oranı. Yumurta kabukları ise su emme oranı fazla etkilendiğini gösterilmiştir. Yumurta kabuğunun içerisindeki kalsiyum oksitler aslında bu durumda ilginç bulmuştur. Çünkü onların aslında suya ihtiyacı vardı. Fakat bu testlerde yumurta kabuğunun aslında oradan kimyasal bir stabilizatör olarak hareket değil, aslında dolu madde olarak gözlemlenmiştir. Bunun dışında bazı polifler için de aynı şey savunabiliriz. Onlar da geçimsiz bir malzeme olduğundan dolayı suyu daha fazla emip kendi işlerine hapsediyorlar ve dolayısıyla suyun oranı azaltıldığı için de basınç dayanımı test sonuçlarına bakılacak olursa yer külü aslında basınç dayanımını artırmakta. Özellikle 56 ve 90 gün sonra basınç dayanımını artırmaktadırlar. Çünkü ilk 28 günde oluşturdukları boşluklar ve gözenekler çok büyük ve fazla olduğundan 28 gün sonra dayanımı artıran gerilerin aslında bu alana yayıldığını ve stajyer oluşturmaya sağlıyor. Bu yüzden de 56 ve 90 günden sonra basınç dayanımı çok fazla. Yumurta kabukları ise çimentonun yerine kullanıldığında değil, aslında ekleme olarak çimentoya katkı sağlaması için kullanıldığında basınç dayanımını biraz daha fazla arttırdığı gözlenmiştir. Bazal fiberler için ise kullanım oranını arttırdıkça aslında basınç dayanımını düşürüyor. Yüksek oranda kullandığımız lifler %16 ve 25 oranında bir artış gösterirken az oranda kullandığımız 21 ile 25 olarak artış göstermiştir. Bu da aslında liflerin yayılma kapasitelerinin çok fazla olmadığından dolayı daha fazla çimento ve suya ihtiyaç duyduğunu bükülme dayanımı için konuşacak olursak, bükülme dayanımında yer külü aslında çok fazla eğilmeye müdahale bir malzeme olduğundan bükülme dayanımını düşürüyor. Fakat yumurta kabuğu aslında burada destekleyip onun dayanımı artmasını sağlıyor. Mark olarak burada bazal lifleri aslında basınç dayanımındaki tam zıt gibi hareket ediyor ve burada basınç dayanımını lifleri yükselttikçe basınç bükülme dayanımı daha da yükseliyor. Bu aslında liflerin merkezin içindeki liflerle olan bağlantısının daha da artmasını sağladı. Ve son olarak sulfat ve deniz suyuna karşı olan bileşenler üzerinde çalışmışız. Ve bu çalışmada aslında yer külü kullandığımız malzemelerin basınç ağırlık kaybı olarak çok yüksek.
Sorry, just 2 minutes, please.
Okay. Then yer küreleri kullanıldığı malzemede ağırlık kaybının çok fazla olduğu gözleniyor. Fakat 90 günde yapılan testte ise %45 ve 88 oranında bir kilo kaybının düştüğü gösteriyor. Bu da aslında yer kürelerinin daha fazla 90. günden sonra iyi bir hayatın olduğunu gösteriyor. Bunun bazalt lifler normal, yani sadece çimento maddenin olduğu liflerle karşılaştırdığında tuzla nüfuzunu engellediği gösteriyor. Ve daha fazla kullanılan bazalt lifler ise aslında deniz suyu ve sülfat atıklarına göre bağlantıyı zayıflatıyor. Sonuç olarak bu araştırmada maksimum oranda yer küre ve yumurta kabuğu kullanmış bulunmaktayız. Aslında buradaki amacımız malzemeleri arttırdıkça göreceğimiz sonuçların ne olacağı ve bunun beton üretimi için iyi bir üreticisi için iyi bir cost reduction yapmasını bekliyoruz. Ve buna ek olarak aslında bu malzemelerin, bu atık malzemelerin alternatif bağlayıcı olabileceğini düşünüyoruz. Bu testlerin biraz daha detaylı olmasını umuyoruz ve son olarak sürdürülebilir beton için çalışmalarımızın iyi bir sonuç vereceğini bekliyoruz. Teşekkür ederiz.
The next one is Hassan Dilek. He wants to make presentation about performance of carbon 7 mortars prepared with base, glass, and brick. Does Asime invite you to come and sit here, please? Thank you.
Herkese merhabalar. Bilimsel etkileşim sağlayan 2. Ulusal İnşaat Mühendisliği Sempozyumuna organize İnşaat Mühendisliği Odamıza bizlere bu sunumu yapma fırsatı verdiğinden dolayı çok teşekkür ediyorum. İsmim Hasan Dilek, TEF ve Avrupa Üniversitesi'nde doktora yapacağım. Bugün yardımcı doçent doktor Pınar Akpınar'ın projemde önceki yaptığım bir araştırma olan atık cam ve atık tuğla içerikli katılaşmış çimento harcı performansı çalışmasını yapacağım. Çalışmamın özeti burada olmakla birlikte, sunumun özeti burada olmakla birlikte, çalışmamın neden nasıl dersleyeyim? Kısıtlı bir zamanımız olduğundan dolayı çalışmanın ana hatlarını buradan geçmek isterim. Hacminin çoğunluğu agregalardan oluşan çimento harcının beton gibi tüm dünyadaki inşaat sektöründe yaygın olarak kullanılmaktadır. Bu çalışmamızda ince ve kalın agregaların ülkemiz Kuzey Kıbrıs Türk Cumhuriyeti ile bulunan 5 parmak aralarındaki azı taş ocaklarından elde ettik. Fakat bazı taş ocaklarımız çevreye duyarlı bir şekilde yönetim mühendisliğinin kaynaklı olarak kısıtlı miktarda olan agregal miktarımız ise gün geçtikçe azalmaktadır. Bununla birlikte ülkemizde yaşayan insanlarımızın çevreyi kirletmesi ve depolanan atıkların kontrolsüz bir şekilde yapılmasından dolayı da doğamıza zarar vermekteyiz ve yaptığımız bu çalışmada atık malzemelerin çimento harcı içerisinde kullanılması belki de bu iki büyük çevre problemine bir nedenle çözüm bulunabileceğini düşünüyorum. Ayrıca literatür taraması esasında iki geri dönüşüm malzemesi olan atık cam ve atık tuğlanın çimento harcı içerisinde kullanılması konusu da sistematik olarak literatürde kıyaslanmasının eksik olduğunu söylemiş bulunmaktayız. öğütülmüş cam ve öğütülmüş tuğlanın doğal akredi olan dağ kumu yerine kullanılıp numuneler oluşturulup bu numuneleri 7 günlük ve 28 günlük basınç ve çekme dayanımlarını bu araştırmamızda gerçekleştirdik. Bu toplumuza geçtiğimiz zaman ise karışım bir numunesi olarak adlandırdığımız kontrol numunesi %100 doğal akredi içermekte. Karışım 2 A numunesi %50 doğal akredi, %50 asit tuğla. Karışım 2B numunesi %100 asit tuğla. Karışım 3 A numunesi %50 doğal akredi, %50 asit cam ve karışım 3B numunesi ise asit cam kullanarak üretilmiştir. Doğal akredi alanlarına. Ve tüm oluşturduğumuz, ürettiğimiz bu numuneleri 260 ve 270 milimetrelik slant değerleri arasında aynı akış koşulları şartlarında üretilmiştir. Bir diğer tablomuza geçtiğimiz zaman ise hedeflenen, daha doğrusu hedeflenen slant değerlerini bulabilmemiz için çimento, su ve çimento oranını ve ayrıca ürettiğimiz numunelerin sayısı da bu tabloda belirtilmiştir. Bir diğer tablomuza geçtiğimiz zaman üretilen numuneleri malzeme içerisinde kullanılan, doğrusu üretilen numuneler içerisinde kullanılan malzemelerin miktarları da detaylı bir şekilde belirtilmiştir. Burada ise kullandığımız atık tuğla ve atık camın öldürülmüş şekliyle resimlenmiştir. Ayrıca numuneleri 4 santim genişlik, 4 santim derinlik ve 16 santim boyunda üretilmiştir. EN 196.1.2 mm standartına göre de basınç ve çekme dayanımları 7. ve 28. günlerde gerçekleştirilmiştir. Sonuçlarımıza gelecek olur ise bu sonuçlara göre numunelerin içerisindeki hidrasyonun devam etmesi sonucunda tüm numunelerin basınç dayanımları 7 günden 28 güne kadar aralıksız bir şekilde artmaktadır. Ayrıca karışım bir numunesi olarak adlandırdığımız kontrol numunesi ise tüm numunelerde çok daha fazla bir basınç dayanımına sahip olduğunu gözlemlemekteyiz. Bir diğer grafiğimize geçtiğimiz zaman ise burada da 7 günlük çekme dayanımı numunelerin 7 günlük çekme dayanımı sonuçları belirtilmiştir. Burada dikkat etmemiz gereken konular %50 atık tuğla içeren numunelerin %100 atık tuğla içeren numunelerin çok daha fazla bir basınç dayanımına sahip olduğu, ayrıca %50 atık cam içeren numunelerin ise %100 atık cam içeren numunelerden daha fazla bir basınç dayanımına sahip olduğu, ayrıca %100 atık cam içeren numunelerin ise %100 atık tuğla içeren numunelerden de daha fazla bir basınç dayanımına sahip olduğunu görmekteyiz. Bir diğer grafiğimize geçtiğimiz zaman bu diğer grafiğimiz ise 28 günlük numunelerin basınç dayanımına dikkat etmektedir. Burada ise aynı basınç dayanımı davranışı bulunmaktadır. Burada da %50 atık tuğla içeren numunelerin, %100 atık tuğla içeren numunelerin basınç dayanımlarının daha fazla olduğu ve %50 atık cam içeren numunelerin ise %100 atık cam içeren numunelerin de hemen hemen aynı bir basınç dayanımına sahip olduğunu görmekteyiz. Bir diğer grafiğimizde, bu grafiğimiz ise ne kadar fazla bir numune içerisinde atık malzeme kullanılır ise o kadar çekme dayanımlarının düşük olduğunu görüyoruz. Ve de ayrıca burada dikkat etmemiz gereken bir husus ise bir numune içerisinde, doğrusu tuğla içerikli numunelerin atık cam içerikli numunelerden çok daha fazla bir çekme dayanımına sahip olduğunu görüyoruz. Bu grafiğimizde ise 7 günlük numunelerin çekme dayanımının ve diğer grafiğimiz ise 28 günlük numunelerin çekme dayanımını göstermektedir. Konuya geçecek olursak literatüre önemli bir katkıda bulunduğumuzu düşünüyorum yaptığımız bu çalışmayla. Ayrıca tuğla içerikli numunelerin diğer malzeme yani doğal takviye ve cam içerikli numunelere göre kıyasladığımız zaman daha fazla bir su ihtiyacına sahip olduğunu, fakat atık cam içeren numunelerin ve doğal akrega içeren numunelerin ise hemen hemen aynı bir su ihtiyacına sahip olduğunu görüyoruz. Ayrıca kontrol karışım olarak adlandırdığımız karışım birincisi çok daha fazla bir basınç, diğer numunelere oranla çok daha fazla bir basınç ve çekme dayanımına 7 günlük ve 28 günlük olarak söyleyebilirim. Ve son olarak ne kadar fazla bir numune içerisinde atık malzeme kullanılırsa o kadar 7 günlük ve 28 günlük numunelerin çekme ve basınç dayanımlarında bir azalma olduğunu görülmektedir. Burada da görüldüğü gibi yüzdelik olarak azalmalar belirtilmiştir. Son sözlerimi söylerken kullandığımız nedenler atık malzemelerin bulduğumuz bu sonuçlara göre çimento harcı içerisinde belli bir seviyede kullanıldığını da öngörmekteyiz. Beni dinlediğiniz için çok teşekkür ederim. Buradan da Pınar Hocama çok teşekkür ederim.
Now I would like to invite Vahid Tabrizi to make his presentation about effective waste utilization and behavior activities.
So, hello everyone. My name is Vahid Tabrizi, and I'm a PhD student in Cyprus International University and proudly supervised by Associate Professor Dr. Ayşe Bekroğlu. This study is the pre-study of my thesis title, so let's continue. My presentation divided into 5 main parts. First part, I will talk about the introduction, and the second is the main idea of this study, and the third one is the marble dust. I will focus on the marble dust as a waste material, and they will concentrate to the physical and chemical properties, and we will end in the conclusion. So let's start with introduction. So construction and let's say concrete is the main material of construction. So we know that these days, because of the rise of population, we need to, let's say, because of the rise of population, where the use of cement, the use of concrete is again increasing. So, based on the studies, the cement factories is one of the main reasons of air pollution, and because of the CO2 gases. Let's say carbon dioxide gases. So it just comes to our mind that what we could do to solve this problem about the let's say environment. So the main idea of this study is just what we can do. So we will focus on the let's say waste material. So in the waste material in highlight, we're going to concentrate in workability, mechanical qualities, durability, and tensile strength. So let's go to the marble dust. So why we use marble dust? Marble dust is one of the material which in Turkey we have a lot of mine, let's say. Because as based on this article which I mentioned, maybe 40% of marble all around the world it's in Turkey. So it's better to use marble and concentrate on marble. So let's go on with physical and chemical properties. So in the chemical properties, it's better to mention that the marble contains calcium oxide, massive amount of calcium oxide, something around 40%, little bits of ferric oxide and silicon dioxide. So in the figure, you can see the different shape of the marble waste. So the marble waste has a pie, marble waste pie, marble waste down in the side, and coarse aggregate from the marble waste. So as a workability, let's see. So marble sand, so when we talk about workability, the first thing is water absorption, which just comes to our mind. So the marble sand has lowest, as a fine aggregate, it has the lowest water absorption. And but we can add, for example, silica fume and superplasticizer for to better water absorption. And what else? If you want to, for example, to cover the economic point of view, we can add in superplasticizer to cover this point. So in this figure, you can see the percentage of replacement of aggregate, marble dust. As you can see, the better performance is when we use the 50% of the marble dust. So in mechanical properties, we will concentrate on the comparative strength. So properties of marble dust rely on few factors. First is superplasticizers, mineral dust content, water absorption, and coring condition. So in the figure, you can see with different percentage of replacement. You can see and in different days, they start, for example, 7 days, 28 days, and 56 days. We can see by increasing the percentage of replacement, we can see there is gradually increase the comparative strength. So about the tensile strength, factor which we focus on marble dust, we focus is water to cement ratio, chemical mixing method, shape of the cores, and the size of the cores aggregate. So in this figure again, we will see the let's say the percentage of replacement again. So in the tensile strength, you can see the sorry. I'm so sorry about this. Yes. Beg your pardon. So in the tensile strength, we can see it's noticed that gradually reduces by increasing substitution proportion with the tensile strength. So about the mechanical, again, the durability properties, again, water absorption just comes to our mind. And in the figure, we can see the water absorption by the percentage again. I'm just trying to show this. And with the in this figure, we can see the percentage when it is 20. No, I'm so sorry. It's better to replace 50% is the best percentage of the water absorption and the durability properties.
Right, just 2 minutes.
Okay, so about the carbonation, the carbonation depth again is very important. So the factors which we have to consider is porosity, water absorption, and shape and size of aggregates. So we can see the by adding for example, by reducing the better carbonation depths, is when the replacement is 50%. So in the end, we can see that performance of various types of marble dust, such as basalt, river sand, granite, concrete, is sustainable is suitable substitution of fine aggregate or cement. However, marble develops need suitable treatment before it's used. With the replacement is 50%. Basalt and river sand concrete produce better strong value. The mechanical properties of marble dust, for example, its comparative strength, tensile strength, effect of replacement of fine aggregates. The strength of marble dust specimens reduces it with the increase in percentage of fine aggregates. The durability properties such as water absorption and carbonation depths affect the performance according to the substitution of the fine aggregates. Thank you so much for your attention, and I'm really pleased to have you.
Thank you so much for your presentation. Now, I would like to invite Victor Ogochisa to make his presentation about cement replacement with based brick powder in paving blocks. Hello, good afternoon. Thanks for the opportunity for this present. I hope to say to the cement replacement with waste brick powder in paving blocks. I would just like to start with, as we all know, waste right now in the world is something we're trying to fix. So we're trying to mitigate the waste we have as landfills are filling up and discussing some environmental, some negative impact on the environment and also humans as well. So I'm going to do a brief introduction, talk briefly about the waste break, concrete paving block itself, material methods, result discussion, and my conclusions with some recommendations. Like I said, concrete is one of the fundamental materials we use right now, globally, all around the world. Everywhere you look around, there's always concrete. But the production of concrete has some negative impacts on the environment, such as CO2 emissions, which affects the ozone layers, etc. So we're trying to find ways we can mitigate this by reducing or either replacing parts of the concrete. And by one of the methods we used was trying to use some waste. Waste brick, for example, was what we used for this particular project. And roughly 950 kilograms per day is the waste produced, such as scrap waste brick. I'm going to show a picture. So we use that for this project. Waste brick itself is also part of it is part of the cement modified soils or cement treated base, etc. I'm going to talk about it. Waste brick itself. Sorry about that, but I'm going to show you in another figure. We're going to be using fired waste brick for this project. We're going to crush it and make it very fine at 150 micron. And like I said earlier on, roughly 950 kilograms per day is the waste that is generated per day. So you can imagine how much is generated per week or in months or in a year. And North Cyprus majorly has two production companies which we use to estimate this value. This is the picture of the waste brick. As you can see, it's cracked, so this can't be used, but this is basically waste. We use this for paving block because, for example, paving block is now the main structural component. It's a non-structural component, and so we use it because we can use it for pedestrian walks, kit parks, etc. And they are good products. They sustain loads. I'm going to put that. And they are skip resistant as well. So, like I said earlier on, we use them for pedestrian areas, driveways, even your garden, etc. And you can also design them to be in certain texture or color, depending on what you want to use them for. So we have some brick types, but the type for this project that we focused on was concrete paving and block paving. This is some type of paving blocks. Some also occur naturally like limestone. This is a Portland paving. This is walling. Like I said earlier, this block paving is going to be the type we use. And this is a more pictorial definition for the surface. So some benefits of the concrete paving include for the performance, application, reconditioning, reinstatement, and cycling and aesthetic. For performance, its strength is really good. For its application, like I said earlier, for pedestrian walks, for your driveway, for your garden, etc. Reconditioning, reinstatement, and recycling. I'm going to group these three together. For example, if there's a damage in one of the blocks because of the way it is put together, you can section it in a way which makes it an easy fix. So fixing it is not costly. So recycling as well, you can, when you degrade it back, you can include it back into a new batch. Aesthetics, like I said earlier on, for color, for design, you can use it. So waste brick was collected from the production companies here in Cyprus. We used the jaw crusher. I'm going to show a picture that shows this process. We use it to crush it to bring it down to a more fine state. Then we use the Los Angeles to break it down to 150 micron. Then we did the chemical composition as well for it. We're using XRF. So this is the first stage. Then we broke it down to this. Then we use the jaw crusher or miller as it's called. Then we use the Los Angeles machine. Then we broke it down to 150 micron.
This is the chemical composition of the waste brick, and this is the graph showing the aggregate we use. So I'm going to show you a table after this slide that shows the percentage we did. We made sure we did everything. We kept the water ratio constant. I'm going to show you soon. Then we use the vibro compaction method. For this project, we made sure we did it the same way the paving blocks, the steps, the way it's done industrially, we did the same method, just to try to copy the method to get on the similar values. So this is the table I was talking about. We have our water binder ratio, we kept it constant. Our main cost and fine cost as well, we kept it constant. Due to our percentage for fine cost, so the sample came out dry because there was no surface to cover. So this is 0% or 5%, 10% waste break replacement sequentially. Based on this picture, you can see on the surface that it's a bit dry. So these are the results that we obtained. We obtained after 28 days, 10% replacement was the optimum. And for density, there was a continual degree. For the competitive strength, it's really good because it's improved. And for the density, we can look at it in terms of when you want to transport your samples. It will be light, so your fuel, you save fuel as well, because fuel is another aspect, so that's another topic of something that we're trying to conserve. So in conclusion, like I said earlier on, there was a decrease, considerable decrease in the density, but 10% was our optimum. And some recommendations that could be made would be, for example, for this, we only after we demolded it, we only sprayed it once and kept it for 7 days or 20 days when we did the testing. So a recommendation could be that it could be either sprayed continually for 3 days or thereabouts, or it's totally immersed, like a proper concrete sample. And we could also do microstructural analysis to see the interaction between both the waste brick and between the samples itself. These are some of my references. Thank you very much for listening.
Thank you so much, Victor, for the presentation. And now, for the last presentation, we have one recorded presentation, which will be given by Marwan El Galal. He recorded something about influence of integrating rubber waste and earth construction other properties. So please play this presentation.
Creating rubber waste on earth construction Adobe properties. Here we have the presentation outlining start with the introduction, then literature review and material and methods. And also we will have some of the test results that we applied up to now, and also we will have conclusion. In introduction, we can say that earthquake construction is getting more popular in recent years due to the fact that it has the ability to provide sustainable and environmentally friendly buildings. Also, one of the key elements of earthquake construction is the alkali, which consists of sand and clay mixture with a specific proportion of gypsum and lime. For broader statement, we can mention that alkali might form significantly rigid material if the percentage of lime and gypsum is adjusted, but the mechanical and dynamic properties of alkali can be enhanced by adding waste rubber to the mixture, where this can minimize the environmental impact of waste rubber, since they will be used as recycled materials without any extra treatment. For literature review, current study regarding the earthquake construction Adobe investigated the influence of incorporating the polyethylene fiber, straw and plastic fiber with minimal percentage, as the case of Benji 2005, Dunker in 2015, and Ahmed in 2021. On the other hand, Bakirov Alkis in 2017 was the first to include waste in the production of earthen construction, where she used the waste marble dust and found that it enhanced the strength significantly when 10% is added to the mixture. For the material that will be used, we have a sand clay that can be collected from sites in order to check their property, where in our case, we will collect them from Famagusta city. Also, we have gypsum and lime powder that can be found anywhere from local suppliers. Then we have the waste wrapper, which can be used in different shapes, such as fine particles, powder, or even fiber. And here we have this flow chart which explains the methodology of the research, where we will be selecting the materials such as sand, clay, gypsum, then we will calculate the water content, and we will place the sand clay mixture with rubber waste from 0%, which is the mixture without rubber, up to 40 or more, to evaluate the compressive strength, tensile strength, flexural strength, material damping, and evaluate the unit weight shrinking. Then we will select the optimum. Also, rubber fiber, we need to consider the L/T ratio since it affects the results, and scanning electronic microscopy should be used to find the microstructure characteristic of rubber. However, rubber is recycled material. We need to find the chemical composition and how it reacts with other compounds. Also, we need to do some economical analysis. For the economical analysis, feasibility investigation will be done to compare the cost of this alternative material. Many things can be considered to find the economical results of this material, such as the cost of labor, transportation, skills needed for workers, and so on, just to compare the costs. Also, we have done some tests, and here some of the results that we obtained up to now. So in order to estimate the best amount of molding water mass, an experimental program should be designed. And here we prepare some samples with different water and clay contents, while the gypsum and lime percentage were adjusted 10% and 2% respectively. And we found that 12.5% of water in the mixture and 10% of clay are giving the highest compressive strength compared to others. Also, we have calculated the unit weight. For the unit weight of samples that has rubber, it was recognized that whenever percentage of rubber is increasing, unit weight of the sample is reducing, as shown in this graph. So the compressive strength is reducing when the rubber percentage is increasing in the mixture, which might be attributed to several factors such as adding the rubber reduces the workability of specimens, causing the following manual compaction to be ineffective. Also, the rubber is an inert material and does not react with water, which increases the amount of available free water in the mix. Also, rubber particles are more compressible in compression in comparison with the sand particle. It should be studied more. This should be studied more and more to find the acceptable compressive strength that mixture can provide. And in conclusion, we can say that this presentation addresses the new sustainable construction material to be used in regions with high seismic activity. This will be achieved by engrafting sheltered tile rubber waste into earthen construction material to produce lightweight material with energy dissipation properties. In order to achieve this project, testing program is proposed to investigate the optimal proportion of the mixture. And here's some of the references that I have used in my presentation. And thank you for your attention. Hello everyone, my name is Marwan Gilan, and today I'm going to present the topic of influence integrating rubber waste on earthen construction at the problem.
It was all presentations for this section. If there is any question, it's for sure there is no question. It's time. Okay, thank you so much. I will end up this session. Thank you.
7. Oturum Başkanı Doçent Doktor Muhammed Ali Musabebaha, takipçini vermek üzere İnşaat Mühendisleri Odası Genel Sekreteri Sayın Abdullah Ekinci sahneye davet edilir.
Ortaya alabiliriz.
Sonunda ikinci ulusal inşaat mühendisliği sempozyumunun sonuna gelmiş bulunmaktayız. Çok güzel bilgiler paylaşıldı. 6 farklı yerel üniversitemizden değişik sayılarda katılım oldu. Toplam 40 adet sunum yapıldı. Bu 40 adetin 35 adeti yerel üniversitelerimizin sunumlarıydı. 5 adeti de diğer uluslararası kurumlardan ve üniversitelerden olan sunumlar. Çok faydalı olduğuna inanıyorum. Şu an için konferansı burada bitiriyorum. Bildiğiniz gibi yarın ve bir sonraki gün diğer 2 etkinliklerle daha çok geoteknik mühendisliği özelinde. Çünkü biliyorsunuz inşaat mühendisliğinde 6 dal vardır. Dün ve bugünkü sunumlarda geoteknik mühendisliği ile ilgili sunum yapılmamıştır. Çünkü onlar özel olarak yarın ve bir sonraki gün daha detaylı sunumlar olacak. Heyecanla onu da izleyeceğiz. Katıldığınız için çok teşekkür ederim. Sağ olun. Bu arada buradaki arkadaşlar lütfen ayrılmayın. Burada bir hatıra resmi çekelim.